Welcome to the Indian Institute of Remote Sensing, popularly known as IIRS. Located in the foothills of the Mussoorie Hills in the beautiful town of Dehradun, IIRS is a constituent unit of Indian Space Research Organisation, ISRO, Government of India. This continuously evolving entity is today a premier internationally renowned institute for capacity building, research in the field of remote sensing, geo-information science, satellite positioning and navigation technologies for natural resources mapping and monitoring, infrastructure development, environmental and disaster management. The foundation of the institute was laid on 21st April 1966 under the aegis of the Survey of India as Indian Photo Interpretation Institute, or IPI, with the collaboration of the Government of the Netherlands. The institute began its first postgraduate diploma program in May 1966 for mid-career professionals in 4 disciplines, namely aerial photography and photogrammetry, forestry, geology, and soils. During the initial years, International Institute for Geo-Information Science and Earth Observation ITC faculty were deputed to IPI for supporting its training programs. The Institute's present campus at Dehradun was inaugurated on May 27, 1972. Later, in July 1976, the Institute became a part of National Remote Sensing Centre, NRSC, erstwhile National Remote Sensing Agency, NRSA. The Institute was renamed from IPI to IIRS in 1983. With time, new disciplines such as urban and regional studies, marine and atmospheric sciences, water resources and geoinformatics were introduced. IIRS has been a part of the erstwhile NRSA till 2011. For ensuring efficient utilization of Earth observation systems and ISRO's forthcoming initiatives, IIRS became an independent unit of ISRO on 30th April 2011.
It gives me a great pleasure to welcome you all at Indian Institute of Remote Sensing, Dehradun. Thanks to the visionary efforts of the leadership of ISRO and ITC Netherlands, this institute was built in 1966 when remote sensing and space technology was at a primitive level in this country. Today, we are a unit of Indian Space Research Organization which is dedicated to the capacity building in the field of remote sensing and GIS. IIRS Dehradun is also actively involved in developing capacity towards remote sensing and GIS for developing nations like Africa, the countries of Latin America, countries in Southeast Asia and Pacific region. Through its Aicte program, IIRS is engaged with large amount of countries, and we have conducted training programs for more than 96 countries. Indian Institute of Remote Sensing, Dehradun is also actively involved in research and development activities using Earth observation data from Indian satellites for various applications.
In recent years, disaster management and distance learning programs are also introduced to further strengthen the scope of capacity building and skill development on mass scale. The capacity building programs of the Institute are designed to meet the requirements of various user segments, such as at middle and super
Indian Institute of Remote Sensing, Dehradun has emerged as a leading center for developing capacity building in the field of remote sensing and GIS through its various educational programs like MTech, MSc and PG Diploma.
The Institute also houses the headquarters of Center for Space Science and Technology Education in Asia and the Pacific, CISTEEP, affiliated to the United Nations, and offers postgraduate program for national and international participants since its inception in 1995.
The primary
Visharotrama
objective of this
Isrodi
center
Award from the
is
central
to
meeting,
develop the human
state-of-the-art
resources
Fuji-based
in the
algorithm for
Asia
the
and
Earth
Pacific region,
observation data.
wherein they can
His
utilize
current research
the
interests are
space,
in the area of
science,
soft
and
computing based
Earth
machine learning
observation
for a
information
single
for
day and
various
temporal
development
multi-sensor remote
activities of
sensing
their
data
regions
for
and also
specific
for
class
disaster
identification
management.
and mapping
This
through
is
in-house
without
development of
looking
the
for support from
SMIC tool.
outside whenever
He
there is a
also works in
crisis in
the
their own
area of
countries.
digital
So it is
photogrammetry,
more like
GPS
making
and
them empowering to
LIDAR.
handle
Now
themselves
I request
whenever there is
today's
a requirement
keynote and
for
resource
development
person Dr.
or
Anil
for
Kumar sir
disaster.
take over the
The
session.
training and
Sir,
education programs are
welcome to the
meticulously
session one,
designed
sir.
by the domain
You can start
experts
the session,
under
sir.
the guidance of
Thank you.
Board of Studies
Good
and
morning,
Academic Council.
to all,
IRS
and
is
I'm
also the
thankful
nodal
to
center for conducting remote sensing and GIS courses
Pscmrcet
for United Nations affiliated
University
Center for
at
Space Science and Technology in Asia and
Vijayawada,
the
AP,
Pacific.
and
It
I'm
is also
thankful to
called
Dr.
as UN
Ravi
SESTEP,
for
and also
considering
for the
me
Aicte program
as
of
one
the
of the
Ministry
resource
of External
person
Affairs of the
in this
Government of India.
faculty
Many of
development
our
program.
trainees and students are serving as geospatial
The
leaders
topic what
in
I've
government
chosen and
and
what they have
ministry
given
sectors.
is already
I know the
displayed.
Indian has got
That
number
is,
of satellites,
remote sensing
and in the remote sensing ground they are doing
applications
excellent,
in
and we have
irrigation
benefited.
and
We learned
agriculture.
these things, and we'll
So in this
apply
topic,
to our
you will see
department as a whole.
initially I'll just try
and it will be
to
benefited.
initiate and
Presently,
cover the
scientific,
basics of
technical, and
understanding about an
techno-management
image,
activities are carried out by three
and
groups. That is,
with respect to remote sensing
geospatial
images,
technology and
the
outreach
issues
program
what you
group,
can encounter while
geosciences and
processing
disaster
these
management studies
images,
group, and
specifically
program planning
when you
and
are trying to
evaluation
extract the
group,
information
with 11
which is
departments,
related
namely
to irrigation
photogrammetry and remote
agriculture
sensing,
point of view.
geoinformatics,
Then
geo-web
you will see the
services,
real
IT and
actual
distance learning,
methodology or
geoscience,
technology what you have
disaster
developed,
management
and you can
sciences,
easily extract
agriculture and
the
soil,
irrigation related issues,
forestry
maybe
and
like
ecology,
water, different type of
marine and
water bodies you
atmospheric
want to map,
sciences, urban
or
and
you want to
regional
map
studies,
specific
water resources,
agriculture crop,
and budget
or you
planning
want
and
to go
monitoring
for
departments.
third level mapping
Along
like
with
some
this, a
disease
dedicated
crop,
team of
or
personnel
which
and
is more
general administration
important
and
nowadays.
construction and
People talk
maintenance
about crop
division
insurance.
facilitate
So for crop
administrative and
insurance, you
other
can see very
support
good
to the
input
institute.
which can be generated
Program
from
planning and
this
evaluation
methodology.
group is involved
Plus,
in all
very common
techno-managerial activities
word
of
you
IIRS
hear
and
in the
SysTeam,
domain of
including budget,
agriculture,
projects,
Recording
and
in
student affairs
progress.
monitoring.
that
IIRS
yield
provides
estimation. So
training
yield
and
estimation
education
at the
through
district
research.
level, at
This unique way
state
of
level,
capacity
if you want
building
to estimate, you
calls
require
for
the
techno
very
management of
accurate
various
information
programs
is area,
and
in
projects
which area or
undertaken at
how much area
IIRS,
the particular
and
crop
it has
has
been
grown,
looked after
and then you can
by
estimate
the
how much is
Program
the
Planning
yield
and
from
Evaluation
that
Group, that is PPEG. PPEG also takes care
crop, and
about
you
various
can have
student
pre-estimation
affairs,
also before
and
the
in
crop is
fact
getting
PPEG
harvested. You
acts
can
as an
estimate.
interface
So these are
between the
for
students
all these
and the
applications,
IIRS.
you will see very good.
In the last more than 50 years,
Applications what
IIRS
we
has
will be
trained a
sharing our
large
own
number of
experience
professionals
in
and
this
students,
lecture. I
including
hope my
participants
PPT and
from
voice
96
coming fine.
countries.
Please confirm.
Upon my arrival here, all the introductions and all the modules that have been given to us with regard to remote sensing have been
Please
of high
confirm
benefits
my
to me,
PPT and
and
voice is
I'm
coming
of
fine.
a high prestige that are also going to benefit my
Okay, so
ministry.
we are going
Remote sensing
further.
and GIS is
So as I mentioned,
useful
we'll try to
to
understand what is image.
identify
So
features
if you
by
see
their
image,
characteristics, and
normal where you can see
especially
the image of different objects
water
already
resource,
created by
water
sensor.
bodies.
But if you zoom
For
in,
my country,
you will
water
see
resource
the
is very
squares.
important. Only
Generally, these are
18% of
basically
water
called
is formed
pixels.
inside
They're
of
generally
country,
squares, which is easy
and
to
for
handle. And if
monitoring
you zoom
and
further, you will
analyzing
see
water
the grids
resources,
basically,
we can
which are
use
having
remote
rows and
sensing
column.
and GIS
See,
and
this
their
rows and column
applications.
basically gives the
IIRS
location
has
of
also
pixel
started its
in an
outreach
image.
program in
And further, if
2007
you see,
to
you
strengthen
can see
the
the numbers
academia and
basically
user
in this
segment
pixel,
in
and these
space
numbers are called
technology and its
digital
applications
numbers. So
using
digital number can
online
be
learning
reflected
platforms.
energy or
A
emitted energy,
countrywide network
or
of knowledge institutions has been
it
set
can
up
be height
where
value or
a
so forth.
large
In the
number of
context of
participants
image,
is getting
generally
benefited.
it is
The online courses are
reflected
offered
energy
in
or
two modes,
emitted
live
energy.
and
In the
interactive
optical
mode
image,
and
generally it is
e-learning mode,
reflected one.
based on the
In the
concept
thermal,
of
it is
learning
basically
anytime,
emitted
anywhere.
energy.
Around
Then if you see
900
further in the context of
academic
remote sensing
and
also,
government
this is a
institutions
water,
across the
it's
country
like sea
are
area and
networked
this is
with
a land
IRS
area. If
outreach
you
program.
zoom
And
this
every
portion
year,
and try to
around
see how this
20,000
image is,
participants
so
benefit
image is
from
looking
these
like
programs.
again
Along
print
with
form
this,
like a
we also
chessboard,
organize special
black and
programs for
white with a
various
single
government
band.
ministries
Then
and
if you
government
zoom further,
departments
at each
under
pixel
the
you can
National
see
Flagship Program.
numbers.
We further
Right?
intend to
So these
extend our
numbers are
network
basically digital
nationally
numbers. So in
as
the
well
case
as
of remote sensing
internationally
also,
to cater
the
to the
concept
large
is same.
user
You
segments
have
of the
pixels as a
society.
square boxes,
Research and
and that is the
development form an
smallest
essential
unit in
part
the
of the
image.
activities of
And in these
IIRS,
boxes you
and
have
the
only
Institute
the
has carried
numbers.
out
So
many
actually image
pioneering
is not
studies.
this. So this is not
Recently,
image. Actually,
IIRS
this
has
is image
designed and
where
developed
you see the numbers,
geospatial
and that is
solution
main.
for forest
If you
fire
see in a
reporting,
body,
consisting of an
made of
Android-based
flash
mobile
and bones
app
is not
and
basically actual
web-based
body.
dashboard
The
application
inside what
for
you have
Jammu and
soul, so
Kashmir
that is
State
important,
Forest Department.
and that
The app
controls the
enables
body and
intuitive
everything.
user
So same way here
interface
in the image what
geotagging
you
of
see
sites,
numbers, that
along
is
with
the
various
actual
details about forest
backbone
fire
which is to be
events.
processed to extract the information.
Geological mapping of Kumaon Himalaya was a
In the
landmark study,
multispectral
which
image,
is referred even today for various other geological studies.
again here you can see you have numbers.
Integrated
but here in
Surveys in
this direction,
Karimnagar
Z direction,
district,
you have
Andhra Pradesh,
number of
for
layers.
resource
Each layer
planning
is a one band,
has paved the
and
way for
these are the
nationwide
numbers, and
project
if you
on
pick out
integrated
one
mapping for
pixel,
sustainable
suppose
development,
it will give you 5
popularly
values.
known as
So here you can
IMSD.
say this is feature vector.
Pre-feasibility
Each pixel
studies for
value,
hydropower projects in
from
the
each
Himalayan
band, if you pick
region
it out,
and
that is
development of
called
methodology
feature
for
vector,
landslide
and it may
hazard
have 5 or 6
zonation
values.
are
So these
some
are
of the
the
other
values.
examples.
Suppose if it is 6 band, so
A
5
flagship
bands, so
activity for
you will
development
get
of
5 values.
methodology
So
for
we'll
the
have
National
5 by
Carbon
1
Project
matrix.
under ISRO
So you
Geosphere
now you can link the
Biosphere
image with
program
respect to
was also
mathematics,
successfully
and you can see
completed.
the matrix is coming into picture.
The flux
So each
towers were
pixel
established at
information you can store
Barkot
in
and
the matrix form.
Haldwani in Uttarakhand to measure
Then you come
carbon flux,
about
which are
an
first of its kind in the
solution. So
country.
in the domain of
IIRS has
resolution
also
of an
initiated
remote sensing image, there are 4
multidisciplinary
types,
and multi-institutional
but the resolution
research
means how to
program on
distinguish a
mountain
particular
ecosystems and
object with respect
services,
to other objects,
processing and
you can use
applications of
different
microwaves,
parameters. Here I am showing you
hyperspectral and
parameter with
high-resolution
respect to spatial,
satellite data
or you can
are the
say
current thrust areas of
spatial or
research.
spectral. So here if you
During
see
the last
in a
5 decades,
false color
the
composite,
infrastructure
this
of
is
the
stadium if
institute
you
has
try to
grown,
see,
with many
which is
new
at
facilities
2.5
such as
meter from spot
state-of-the-art
image. So you
distance
can see
learning
this much
center,
details,
lab and
but if
field
you come at
instrumentation,
0.5 meter
data
at an
center,
ortho image as a
computing
true color, you
infrastructure,
can see
including
more detailed
high-performance
information
computing
here.
platform,
Then if you come
modern
at 10
library
meter,
with digital
so the
resources,
same stadium is appearing
students'
like this.
hostels,
So now you can see
creche
very less
for
information
children
is
of working
present.
women,
And if you see
recreation
same
facilities like
stadium
all-weather
at 20
swimming
meter,
pool,
you can
indoor
see
and
it is
outdoor
very
gymnasium,
less.
etc.
All the components
IIR's
visible, like
campus is highly
seats
secured
is not
with
much
round-the-clock
visible,
security
and this
provided by
field, the
Central
ground is
Industrial
covered with
Security
grass, is
Force,
hardly visible.
CISF.
You can just say that it is
Infrastructure and
can be
facilities in
detected
IIR
by
is a
color,
world
but
class
here
in
you
nature.
can see shape, size
Scientists
is more
here are
dominating. So with
very
respect to the
knowledgeable,
resolution
highly
of an image,
qualified, and
there are
they can
different
extend
information
technical
present.
support
So
whenever
accordingly, we
required.
have to think
And I
about
feel
how
very
to
privileged
capture
to
these
be here, and
informations
it's a good
to finally
opportunity to
extract
carry out
that
high-end
object.
research.
Apart from the
Then
rigorous
coming
training
to,
activities,
machine learning,
IIRS staff and
specifically
students
for
actively
Earth observation
participate
data
in
processing,
cultural and
you can
social
see some
activities.
requirements with respect to hardware or software.
IIRS
Like for
contributed
data
in different
processing,
government
we require large
initiatives
memory
such as
is required,
Swachh Bharat
large
Mission,
training
Digital
data is
India,
required to
and
train
Smart
the
City
algorithm.
Planning.
But nowadays, it is not
IIRS is
necessary
developing
that we
new
should have a fear
mechanisms such
that
as
we require
distance
very
learning
large training
programs,
data, but nowadays there are
webinars,
very
and
good
online
algorithms
content
which can
generation
work with
for
very
reaching out
small
to large
training
number
data
of
also.
students.
Some algorithms
IIRS
specifically
continues
like
to
deep
grow
learning
and
or ANN,
evolve
they have
with a
some
vision to achieve
generalization issues.
excellence
Generalization
and
means
remain in
they
the
can work
forefront
good
for capacity
training
building
data,
and research
but the
in
results
remote
for
sensing,
testing data is not so
geoinformation
much good.
science, and their
Then we have to think
applications.
about how to make more robust for testing data also. Then maximum parameters are free. That means these parameters has to be optimized so that the algorithm can be used for testing purpose. That means for
Today I am going
classification
to
or
cover
detection
Earth
purpose.
observation sensors and
Then
platforms.
coming to narrow down the machine learning algorithms,
So before
there are
I'll
so many
start
algorithms.
with,
I'm
you
talking
can
about
see
here
you already have gone
fuzzy-based
through the first lecture that
approaches.
what is the
Why?
definition of
Why
remote
for
sensing.
Earth
So remote
observation? The
sensing
question
is
is why
what?
I'm talking
It
about
is going
fuzzy-based,
to be
because
like
they
you
can
are
handle
seeing
the
me,
mixed
I am
pixels
seeing
very
you.
nicely.
That is also called
Mixed
as
pixel
remote
means
sensing,
more than
but
one
that
class
is
is present
because
in a pixel.
you are
This
seeing
happens
that
number of
through
times.
the light which are
the pixel can
reflecting
be
from.
representing the boundary of
So
two or more
normally
than two
remote
classes,
white is called
or
as remote because
one
it
class
is
is smaller
observation is being
than
done at a
other
distance
class.
without
So
physical
again,
contact with the
if
object.
this area is
And sensing
represented by
is
a pixel,
detecting the
so again we have
electromagnetic
mixed pixel.
radiation
Then
coming from the
non-linearity,
object.
that means if you see in the
So
feature
we are
space,
why we started
class
using
separation is
remote
coming like
sensing
this.
to any of the sensors which are placed on satellite
And
or
this
any other
separation is coming to
platform,
be a
because
non-linear.
we
It
are
is not a
able
straight
to
line, so
observe
it is
or
non-linear.
extract
So these
information
algorithms can handle the
from those
non-linearity. These
by
algorithm can handle
utilizing
the
those
noisy
wavelengths
data.
which are
The noisy
beyond
data
human
can be
capability.
the pixels
As you know that
created by
our
the
human
sensor or from
eyes
the
are
ground.
only
So these are
sensitive
the
till
unwanted
visible
pixels.
wavelength region.
How to tackle
But
this?
beyond
So
that
these
wavelength region,
algorithms
like
are robust,
infrared,
especially some
microwave
of the fuzzy
wavelength, can
algorithms are
also
very
be
robust
used for
to
sensing the
handle the
data.
noisy pixels.
Now, in
And due
this
to this
lecture,
capability, the
I'm
algorithm
going
becomes
to
more
cover that
specific,
whatever
that they can
sensors
map
are
a
there,
specific
how
class
it
of
is
interest
kept
what
in
you are
some
looking
of the
for. So
platforms
just
to
single
observe the
class they
proper
can extract, and
information.
you will see in the
Why
coming
it is
slides
important
this
also, that I am also
capability we
going
have
to tell.
explored a lot
Like
to
most
map
of your
single class
cameras,
from
if
a given
suppose you are
image. And there are so many
hanging your
applications where we
camera
want
like
only
normally
one
and
class.
you
We
are
don't
trying to
want
take
all the
photograph, it will
classes
not
to
be
be
able to
extracted.
give you
It
the
depends
proper
application to
photograph.
application.
So for taking
So
proper
then capability to
photograph, you
identify
have
single
to
class. So
keep
from
your
this
cameras in a
application we can
stable
use the
platform, or
algorithm
you have
to
to keep
map
your camera
single class
stable
at a
to
time.
your hand. Then
Then
only you
required
can take a
small
proper
training
photograph
data.
from
That
the
is one of the
camera.
beauty of these fuzzy based
Similarly, even
algorithm.
all the
They
human
require
beings
very
are also
small
equipped with some
training
of the remote
data. So
sensing
with these
sensors like
positive
eyes,
things,
ears,
I
and
will
nose.
be
And
focusing
it
on
requires a
fuzzy based
platform, like our
classification
head is acting
approaches.
as a
Otherwise, in
platform
the
to
literature,
keep
you
these
can hear
sensors to
about
collect
decision
proper
tree,
information.
random forest,
So this slide you already
support
have
vector
seen
machine,
something similar to that. So
linear
normally
mixture
in this
model,
remote sensing process, you might have seen
and
that there is an
in
energy
learning domain
source which is
ANN.
coming from sun. If
And
I'm
then
talking
further you
about
can go for deep
passive
learning.
sensor,
Deep learning, you
if
have
you
so
have
many
remote sensing sensor
CNN
which is having
and
own source of
modified versions of
illumination
CNN and
and
so
it is
forth.
sending, that is
So there are
active
unlimited
sensor.
algorithms,
So
but
what is actually
these
happening here?
algorithms
From
become
sun,
more
energy is
complicated
coming,
during for
interacting with the
training
Earth's object.
or the
Some are
training data
getting
requirement and so forth. But these
absorbed,
fuzzy
some are
based are very
getting
simple,
transmitted, and rest
just
of the
like look
energy is
like a
reflected
small
back to the
mathematical
sensor. If it
expression.
is active
And if you
sensor,
use them,
sensor
you can
itself is
get
sending the
very good
energy and
results.
backscattered energy is received by
I
the
hope
sensor.
my
But
PPT
in
and
between
voice
that,
is
if
coming
suppose the sensors
perfectly.
are placed
There
on
is no issue.
satellite and it is in the space,
Noise to
we'll have
sensors
some
clear, sir.
interfering objects
Thank
like
you.
atmosphere.
So it is
And you know that
always
some of
to check
the
that you are
energy
able
which
to
are
receive
coming
my
to from the
PPT and
sun
voice,
and
and
going back to
also
the sensor,
it is an
it is getting
alarm that
affected by
you are
your
not sleeping
atmosphere.
in my
So
class
this needs to
during
rectify
my
whenever
Clear
we
the
are
voice and
receiving the
video.
data and
Thank
we are
you.
fixing it.
So
So whatever
now
sensor
coming to
which is
linking
collected,
these things
which has
through
collected the data
for
on board
classification
satellite,
is very
and
common. You're
that
already knowing
satellite's
this
data
supervised and
sets needs to be
unsupervised. So
transmitted
these are the
to
two
nearby
modes.
ground receiving station.
And
And in that
nowadays
ground
people are
receiving
also talking
station,
about, we
we
have also
need to
used
fix certain
two
issues,
further
because you know
concepts of
that while data
classification. One
acquisition
is semi
is taking
supervised,
place, certain errors are getting introduced. Like here in this case, you
one is
know that atmosphere
semi-supervised,
is one of
and
the things
second
which are
is
playing a role.
reinforced
Even
learning. So
sensor
this
and satellites are
semi-supervised and
also
reinforced
electronic
learning has came when people
devices
are talking
and
about deep
mechanical
learning.
devices. So
So
this
nowadays you
also
can have
causes some
four
of the
types of
errors. So these
classification
errors are
with
getting
respect
fixed
to
in this
learning.
ground receiving
One is
station,
supervised,
and that's
where
why
we
it is
provide
written
the
as
training
ground
data,
receiving and
and
processing station.
algorithm maps
Now,
according to the training
whatever
data.
sensor data
Unsupervised, there
which
is no
has
training
acquired,
data. It
whenever
iterates the and refine
some
the
urgency is
parameters
there
to
and
divide
sensor
the
are
image
away
into
from the
clusters.
range of the ground receiving
Semi-supervised means
station,
we have a
then if you
less
require the
training
data,
data, and
then
we have a
what we need
large
to do, we need
unlabeled
to
data.
transmit this
So
data to
then
some
we can go
nearby
for
communication
semi-supervised. That means we have
satellite,
a small
and
labeled training
that
data, and we have
communication
large
satellite is sending the
unlabeled
data to the
training
ground
data.
receiving
And
station.
fourth
Then
one
after
is when we give
rectifying the
rewards
errors of the data which get
as a
acquired
negative or
during the
positive
introduced
rewards.
during the
So
acquisition
according to the
process,
rewards,
then we are
algorithm
further
train. So these
analyzing
are four
it and
methods,
we are
but I will be
generating
focusing
it
little
for
on
various
supervised and unsupervised little more.
generating the
So
products
here you
for
can see
various
for
kinds of
supervised
application
case,
like
we
land
are
use
providing the
mapping,
training data of
geological
three classes.
applications,
Suppose, for
forestry
example,
applications, and
from an
so on.
image for C,
Now
B,
you
and
can
A.
see here,
So A
like
is
if you will
labeled as
compare with a
water, B is
simple
labeled as
example like
agriculture, and
mobile
C is
phone,
labeled as rock.
like if you are away
So
from
using
the
this
mobile
label
tower, that
data,
mobile
this is
is
the
away
input
from the
image,
range
and
of
here the
mobile
classifier
tower,
is used,
you
which
are
is
not
supervised
able to
one.
receive
So
the
here you can
signal.
see basically classes
So
C,
similar thing
B,
happens
and
whenever
A.
your
So you
satellite
can
is
see the
away
label
from
also,
the ground
and the
receiving
image is
station. It is
divided
not
into three
able to
classes.
send the
But
data
in
to
this
ground
case,
receiving
so there is
station.
no
You
here
can see here in this
training
particular
data.
animation that
So
how the
we just
satellite,
give
whenever
the
satellite is
number of
coming in the
clusters,
range, your
images to
ground
be
receiving
divided,
antenna is
and here you
also
can
moving
see
and it
this
is receiving the
cluster
data
1,
in form of
cluster 2,
electronic signal.
cluster 3,
So that
and cluster
electronic
4. So
signal
here
is
we don't
then
have labels.
converted converted
has
to
just given default
two-dimensional
label
image.
C1,
Now,
C2,
this is the
C3,
example
C4,
of some ground
and
receiving
it is not a
stations which
single
are placed
stack.
at
The algorithm has
Sadnagar,
iterated
Hyderabad.
number of times,
So, we have
and
total
then it
4
has
ground receiving
divided the
stations
data
for
into
receiving the
clusters. Why?
satellite data
The
at
question comes, why
NRSC
the algorithm
Hyderabad,
has
that is NASA
iterated
Remote
number of
Sensing
times?
Center,
Because
Hyderabad.
there was no training
And these
data.
antennas are at
To run the
Sadnagar.
algorithm has to assume the
Now,
algorithm
what are the
parameters. So whatever
definition of
parameters has
sensors
been
and
assumed,
platforms? Because
they have to
combination of
be
these two are
refined.
creating
So
the
for
image data
refinement,
of the
it
Earth
does
surface. So
iterations, maybe
sensors
10
are a
times, 20
device
times,
which
whatever
records the
iterations we give. So
electromagnetic
accordingly,
energy
it
that
iterates,
depends
and
upon the
then
different type of
after the
sensors,
last
like if it
iteration,
is
we get the
optical sensors, like
cluster. So
which
here,
is using
one thing
visible
in the
to
output, you'll see
reflected
the label is
infrared.
missing. We
So they are
cannot say what
receiving
is yellow,
reflected
what
energy.
is red,
If
and
it
what
is
is
thermal
green, and
sensor,
what is
it is
blue.
receiving
Right?
emitted
What is this
energy.
class name?
And if it is
So later
microwave
on,
sensor, it is
we
receiving
can
the
refer
backscattered energy.
the
And
ground or
platforms
some
are
report,
what?
and then we
Like
can
we
give
have
the
to keep the
labels to
sensor
these
in a
clusters.
stable
The
platform. So these
application of
sensors are kept
unsupervised
so that
method
they are
is when we
acting like
don't
a
have
carrier bed,
the ground
and we
information,
are able
but we
to
have an image of that area.
capture
We
the
can
data sets
initially
in a proper
guess
way.
with the help of unsupervised approach that how many
Now let us
maximum
go to the history of the
classes we can
different types of
extract from
platforms,
this
how
given
remote
image.
sensing
So
actually
initially we
evolved.
can
So it
assume, say, a
evolved
number
with
of
the
clusters, say
invention of
50.
cameras. So
So
first
in the
photograph was
output there will
taken
be
in
50 clusters,
1827.
and then
Then
we
in
can start
1858,
trying
they
to
started
correlate with the
using the
ground data.
camera
If we
by
get the ground data from the
placing it in
report or
hot
from the
air
ground,
balloon.
and
So
then
you
we can
can see
start
here, this was
merging
one
these
of the person,
clusters,
Nadar, who
and finally from
started taking the
50 we may reach to
photographs.
30
So this
clusters.
was one
So
of
this
the hot air
concludes
balloon
that from a
photograph in
given
that earlier
image
times.
for a
Then
given
in
area,
1861
we
to
can extract
1865, they
maximum
started
30
using this
classes.
balloon
So the application
photography
of
in American
unsupervised
Civil War.
approach is
After that,
just to
in
know how
1888,
many
rocket cameras were
maximum
invented.
clusters we
Then
can
in 1903,
map.
prison-mounted cameras were patented. So you
Coming
can see
to
here
further
that how the
sub
cameras were
classifications
mounted
in the
on the
classification
prison,
domain
and you
is
can
called
see the image
hard and
captured by the
soft. It
prison
is
that
also called
wings are coming
subpixel.
in this
So here
particular
you can see
image.
one image which is a 5
After
band.
that,
So
in
if it is a hard
1906, photograph
classification
from kite
as
was taken.
supervised or
So this is
unsupervised,
one of the
so we get a
photograph
one layer
of
output,
San
and
Francisco
here
taken
one
from a
pixel is
kite.
labeled to one
Then in
class. One pixel is
1914 to
labeled to one
1945,
class.
during World
So
War,
this is a water,
this
then
plane-mounted
pink
cameras
is
were
your
used.
vegetation,
And after
wetland
that,
is
in
this one, and then soil.
1956, U-2
So
spy
like that
planes
you
were
can
used.
basically label.
Then
And if it is a soft one,
1957,
what
first
happens? You can see
satellite
the
was
output is not
launched,
single layer.
but
Since
major
we are extracting
evolvement had
4
taken place in
classes, so we get 4
1967 when
outputs,
that
one
Earth
output
Resource
for
Technology
one
Satellite program
class.
was
So these are
started by
called
NASA.
fraction images. Why
So
fraction images?
that satellite
Because we
was
have
launched
assumed that
in
in this image there are mixed
1972,
pixels.
and when
That
they
means
launched
in
a
a
series
pixel there
of
is more than
satellites, they
one class.
renamed
So
as
how to
the Landsat
extract?
series of satellites.
We are applying
So
here
this was
fuzzy
the first
concept,
image
and
taken
it
from the
generates the
Landsat
fraction
1
images.
satellite from
And
Dallas.
in
So
the
you can
fraction
see how
image,
the image
these
of
numbers,
Landsat 1
fraction
satellite
values
image is coming.
0.7, 0.3 are basically membership value.
Now, the
So
platforms
membership
which are
value means
carrying the
degree
sensors
of
are
belongingness.
categorized
By
into
what
three
degree the
categories.
class is
Now,
present in a given
one
pixel.
more
So
thing I
for
would
each
like to
class,
add
we
here,
have
like
one
right
fraction
now
image.
also for airborne,
Then you can see now
or you
little
can say for a
bit
lower
idea
height
why
data
we should
acquisition,
use fuzzy
some of
based
the platforms
classifiers,
are still being
because
used like
for a
hot air
given
balloon
pixel
and kite. But
level land cover
there are
mapping,
some
you may
limitations of
have
those
here
platforms.
3 by
Those
3 9
platform limitations
pixels,
are that
and you can see they are
altitude is getting
representing to
affected when
grasslands.
there
That
is
means
a
they are the pure
wind.
pixels. So
So
you
you
can
can see
simply
here, they are
since they are pure
ground-based
pixels,
platforms
you
are
can simply
whenever
label
we are
them.
using some
These are all
planes and all, and we are
grass
taking the
pixels.
photograph.
But in the same case,
Airborne platforms are
there is a
like some
boundary
of the
of
helicopter
land
or
and,
stable
and
wing
grass. Then the question
airplane
comes,
can
these
be
pixels you
used.
can see very clearly
And
water.
nowadays,
These
people are
pixels
using
very clearly
drone
you
for
can label as
capturing the
grass. But these
images.
pixels, I
And
think, is a
spaceborne
question mark
platforms are your
what the label should
satellites.
be given,
So you
because
can see
partially
here
there
the
is grass
synoptic
and
coverage
partially
of
there is
various
water
platforms.
body. So
So
then if
whenever
you apply
platform is
hard
with 800
classification,
kilometer
you have
altitude, you can see it is
underestimation
going to
or
cover a larger portion
overestimation
at that
of
time.
classes. So to
And
avoid that,
airborne
you
platform
can
with 10
handle the
kilometer
mixed
altitude, you
pixels
can see
through
it is also
fuzzy
covering
domain.
a smaller area compared to your
I hope
airborne
my
platform. Then
voice
a
and
hot air
video is
balloon or
coming
drone
fine.
which can fly to 100 to 400 meters altitude, so that can also cover a smaller
Okay,
portion. And 10-meter
thank
altitude,
you,
some
thank you.
crane or some
I'm
tall
continuing
building can be
further. If
used for
there are
taking the
questions, you
photograph.
can drop in the
And people
chat
can
box. If you
stand
want, I
on the
can take
ground and
now, or I
can
can
go
take
for
in the
free data
end
collection.
of my
So that is
lecture,
around
as you
1 meter
wish.
height
I
that
don't have
is
any issue.
required.
Both
So as you are
both the
going towards the higher
modes is
altitude, the
comfortable to me
area
to
of the
reply
coverage
your
is going to
queries
be
if you have.
larger by those
Uh,
satellite-based sensors.
Now coming
Now
to
coming
real
to
remote
ground-based
sensing
platforms,
image. This
why
is
we
one
started using
image west
ground-based
side of
platforms?
Dehradun
Because
of
this is
Panta.
used to
Here you can
record
see this
detailed
is
information
Yamuna river.
about the surface, which is compared with
This is
information
Asan
collected
river,
from
which
aircraft
is
or
meeting to
satellite
Yamuna,
sensors.
and this is
So
Gir
we
river.
have to
So
also
these are
validate whether
tributaries to the
whatever
Yamuna, and there's
information was
Asan Barrage.
collected from
and there is a canal
space-based
coming
platform
from
or
Dakpathar
airborne platform, whether it is how much
barrage.
accurate and
Now
what
you
are
can
those
see the
actual
fraction
features
images. We
are.
have
So
tried to
for
map
better
barren
characterizing the
lands,
target also, we
agriculture,
need to go to ground
then
for collecting the
dense forest
information.
and deep water.
So
you can see the pockets where
suppose
you have
we
more
have
dominating
collected
barren
remote
lands,
sensing data from
then
satellite or
agricultural
airborne
lands with
platform,
crop.
and
This is the
that had
dense
collected
forest
for some of
and
the
this is the
forest or
deep
some of the
water.
cropland.
If you
But if
have
you
been
want
gone
to know
for
that which
hard
crop it is, so
classification,
for
all
that
the
you need
water
to go
pixels
to
have been labeled as
the
deep water,
ground-based
but in
data
the fuzzy
collection.
concept, these
Then coming
pixels
to
are labeled as
sensors,
deep water
what
and other
could be
pixels
used,
are
what can
shallow
be
water.
used
Here you
for
can
that
discriminate
ground-based
the
platform?
subclasses
So sensors
because
may
the
be placed
output
on a
is
ladder,
representing as
scaffolding,
0
tall
to
building, and
1. So
crane.
this is the
So
membership
this kind of
values.
features can be
Now
used
we'll be
for
moving
putting the
further
sensors.
how to
Then coming to
handle the
airborne
noisy
platforms,
pixels. One,
normally
we
they
can
are
handle
stable
with the
wing
help of
aircraft.
classifier.
Sometimes
Further,
helicopters are
if you want
also
to remove
used.
the noisy
And
pixels,
nowadays we can also tell
add the
UAV platforms
contextual
are also coming
information
under
in the
this
given
section.
classifier,
But
and to
coverage of
make these classifiers as
area coverage of
hybrid
that particular
soft
UAV platform will be
classifiers.
small,
So
and you
here
have to fly
I
it
will be
again
showing
and
you
again
some
because
examples. So what you have tried here,
that
we have
works with
tried to
batteries.
add contextual
So
information
this
through
is
MRF,
actually used
Markov
for
random field,
providing detailed
or we have
images
also
and
experimented
facilitate the collection
to
of
add the
data
contextual
over
information
any portion
using
of the
local
Earth's
convolution
surface at
method. Through
any
window
time.
approach,
But
the
there
neighbor
are
pixels
few
have been picked
limitations
up
with
to
this.
apply their effect on the center
Limitations are
pixel.
what?
So both
We
way
can use
we are
that
able to add the
aircraft
contextual
data,
information.
aircraft acquired data
Contextual means
only when
neighbor
that aircraft
correlation,
lands.
how much the
But in
pixel is
case of
correlating with
satellite,
the
once you will
neighbor
launch the
pixel. So
satellite
here what
and it
happens,
will
we can
revolve
improve the
around the
accuracy
Earth's surface,
in the output, say
and
2 to
you can
4%,
use the data because they are
if we
going to
add this
transmit the
information in
data
the
to ground
base
receiving
classifier.
station
And
whenever it is in the
it
range
gives
of
the
time.
correlation
But in
basically
case
with
of
respect to
airborne
spatial
platform, it
resolution
had to
or with respect to scale of the
aircraft had to
natural
land,
or
then only
cultural
we can
region.
use this
If
particular data.
in a class, if you
Second
see like
limitation
urban,
of this
sorry,
airborne
in
platform is
agriculture,
what?
you get
Flying
maximum
of
correlation.
aircraft
So
is not a
and in the case of
economical,
urban,
or
you
you
get
can say
least correlation. So
economical
that concludes the agriculture
option,
or
because
water body has higher
in
contextual
difference between this
information,
airborne
and the
platform
urban
and
type of
spaceborne
class
platform
has
is
the
what?
least
Airborne platform
correlation
cannot provide
information
the
for a
temporal
given
resolution
area.
data, means we
When
cannot
the
revisit again
resolution
and
is
again,
coarser,
and flying it
then
again and
the
again
correlation
will
is less.
cost
For
you more.
finer
But in case of
spatial
satellite,
resolution,
once you
the
will launch
correlation
the
is
satellite,
more.
it will
So this is
revolve
also
and
very
it will
important
work
for the
till its
same area.
lifetime
If
and
you are
provide you
looking
the
through
data
coarser
sets.
image, the
Now coming
correlation
to
will be less.
spaceborne
When you're looking the
platforms,
same area through
spaceborne
finer
platforms are
image, the
categorized into
correlation
two
is
types:
more.
space shuttle and satellites. Satellites are more
Previously, if you see,
commonly
people have
used,
applied
and
this
satellites are
correlation
objects which
concept
revolve around
through
another object.
pre-classification
The
stage
satellite
using
name
low pass
came into
filter,
picture
or
when
after
Kepler
post
was
classification using
observing different
median filter. But
planets and
nowadays,
he started
during
observing
classification,
Jupiter.
you can
He
apply
found that
the
some
correlation
objects are
concept
revolving around
using
Jupiter
prior
planet.
energy
So
function
it was
or
appearing like
through
something is
local
guarding that
convolution
planet.
method.
So
So
that
here,
in
talking
his
about prior energy
language,
function.
that
So
particular
this is the spectral
guardian
information,
named
and this is the spatial
guardian
information,
word is
and this is the
named as
global
satellite.
positive
The meaning
energy
of that
function, which
guardian,
has to be
satellite means
minimized.
guardian.
And once you
So
do
that
it,
was the
so you can
thing
see the
name given
global
by the
positive energy
Kepler.
function, this
And
conditional
you
energy
know
or
that
spectral
the moon is, in
information,
case of our
and
Earth,
this
moon is
spatial
the natural
information, which
satellite,
is adding the
whereas
contextual
man-made satellites
information from the
include those
image. And if
platforms
you minimize this
which is
one,
launched
we
for
can
remote
get the
sensing,
output.
communication, and telemetry
So here you
purposes.
can see one example,
Now coming to
like as
space
an
shuttle,
irrigation point of
space
view,
shuttle
if
are
you are
the
mapping the water
platforms
bodies.
in
I
which
will show you
man
other
can
slides
sit
also. This is one of
and
the
can go
example
to the
for
space and can come
accurately
back. So
mapping
that
the
is
water
called as
bodies. In
space
the image,
shuttle.
what
And
happens when you
satellites are
are
what?
mapping the water
Whenever you will
bodies,
launch a
the
satellite,
shadow
it will
part
revolve
in
around
the
the
image
Earth's
get
surface,
labeled as class
but it will
water. So
provide you
question
data
comes
till
how
its
to deal with.
lifetime.
So
But
one
after
thing
that
is this:
also
the
it will
ground
revolve around the
photograph we have
revolving
taken
around the
near to a
Earth's
dam.
surface.
So this here you can see this is a
Now
dam we have
coming to the
mapped,
satellite,
but this is
how
a
the
road which has
satellite
a
is
eucalyptus plantation
revolving
along
around
the
the
road.
Earth's surface.
The
So
question comes how
normally
to
the path
avoid this,
followed by
because these
satellite is
pixels, which
called
is road,
orbit,
are also
and the
getting membership
satellite
value to
moves
be
as
class
per
water. So
Kepler's
how
law.
to
So there
avoid
are
it?
see
So
Kepler's
we have
law.
applied
First law is
with
what?
this is without
Normally,
contextual
whatever
here,
planets are
but once
revolving
we
around
add
Sun, so
contextual in
they
the
are
fuzzy
making an elliptical
classifier,
path
you
by
can see
considering
that
Sun as one
shadow
of the
part has been
fifths.
removed.
Second law
So
is what?
irrigation
The
point of
line
view,
sweeping,
you can,
line
if you're
joining to
mapping
the
the water
planet to the
bodies,
Sun
you can
sweeps
easily
out equal
remove the
areas
shadow
in equal
effect.
interval of time.
Specifically the
So
water
suppose
bodies,
if
if
this
you're
is
mapping in the
taking,
hilly
this is
terrain,
area A1 and
undulating
it is
terrain,
taking
there will
T1
be
time, and
shadow,
this is area A2,
and
it is taking
question
T2
comes
time.
how to deal
So this
that.
product
So
is
you
going
can
to be
add
constant.
contextual information and you can minimize this
Third law
effect.
is the
Or
square of the
there is one
period
more
of the
technique, you can
planet
add
is
the
proportional to
indices
the
data,
cube of the
so that also takes
semi-major
care
axis.
to remove
So if
the
suppose it is
noise.
taking time t
Here
to
you can see
complete
one more
one
case,
orbital revolution,
how to
so
map the
square
water
of
bodies.
that time
Parallelly,
period
basically, we have
is
tried to map
proportional to
the
this
paddy
semi
fields.
cube
We
of
have
this semi major
experimented
axis. This is your
this
major
on a
axis.
study area,
So
which is
cube of
east side
semi
of
major
Haridwar
axis is
on the
this.
Naziabad
So
NH
this is
74
proportional
highway.
to the
So
cube of
here we
semi
have
major
tried
axis,
Formosat
that time
image,
period, square of that
temporal
time.
data from 10th August to 4th
Now coming to
December.
few of the
Objective was
satellite
to map
orbital
the
characteristics.
rice
So
fields or paddy
normally
fields. So these are
satellite
the
orbital
paddy fields which
characteristics
were
are this,
there
that
in the
is
month of
altitude,
say
inclination angle,
August to
period,
December
repeat cycle, swath,
2014.
ascending
But
pass and
parallelly, you can
descending
see
pass, and
we are able
perihelion
to map the
approach.
water bodies
So
also.
altitude is
So this is a
normally
canal coming
considered
from the river
as the
Ganga,
height
and
of
this
the
is the river
platform
Ganga.
from
So
mean
for
sea level of your
irrigation
Earth
point of view,
surface.
again,
So
if you are
whatever
looking to
sensors are
map the
there,
water bodies, it can
and they are
be
flying with some
dam
altitude
reservoir
with
area or
by
some
from mean
river
sea
or
level of your
canal.
Earth surface.
You
So
can
that is
easily
called
map
as
through
altitude.
remote sensing, just
Inclination
using
angle is,
like here we
suppose
have
this
tried
is
the
your
fuzzy based
Earth, and this
classifier,
is
and you
making
can
an
extract the
equatorial
single
plane,
class like
and
water
suppose
body.
this
And
satellite
then
is
if you have
orbiting like this.
channels,
So whatever
say
angle made
canal
between this
networks, if you
orbital
want to
plane
map, you
and
can easily map
equatorial
the
plane,
canal
that
networks in
angle
your
is called
area.
as inclination angle. Now, why
Here,
it is important?
further using
Suppose
the
if
contextual
some
information, there is
satellite is
small water
revolving
body near to
around
the dam.
by making
Here, when we
45
have
degree
this is the input
angle,
image,
then what will
and
happen till
this
plus
is the
45
fuzzy
degree
smooth,
latitude and
fuzzy
minus
with
45
smoothing
degree
concept.
latitude, the
So
data
through
will be
smoothing,
acquired.
when we are adding the
So
contextual
to
information,
complete,
it is
to get
basically
the data
dissolving the
for whole Earth
boundaries, and
surface,
small
the satellite
details
should
has not
be
been picked
near
up.
to the
But
pole,
when we have
so that
applied
it can
FCM
acquire
with
whole
DA
Earth
model,
data
you can see the
data
small
sets.
water bodies which are patches
Now,
here, which
coming
can
to
be easily
period,
mapped and
period is
preserved nicely.
time
So
taken
this is
to
the one
complete
advantage
one
in
orbital
MRF. We can have
revolution
two
by that
categories:
satellite.
smoothing
So that is
concept and
called as
DA
time
model.
period.
And DA model will give you
Repeat
much better
cycle
accuracy
is,
than
you can
smoothing method.
calculate the time
Specifically
period
for
by
water bodies, we have
solving the
experimented.
normal equation, that
Then
is mv squared
also,
by r is
if
equal
you
to
are dealing with
mg.
noisy
If you solve that
image, so
equation, you will
how
get the
to
time
deal with? We
period.
have
So
experimented with
where Earth's
adding the
radius
local
and your
information
height
method
of the sensor will
through
be
window concept.
used as
So
that
here you can
particular
see this is
r,
the input
then you
image.
can
There is no
calculate the time
noise.
period according
Assuming
to
this
that.
is it is
Now
a
coming to
noise-free
repeat
image,
cycle.
and this is the
Repeat
output.
cycle
So
means
we
if
have
suppose
got the
Earth
output
is
through
orbiting
NPCM
from
S
west to east
classifier.
and
NPCM is a
satellite is
fuzzy-based
revolving from
advanced
north to
classifier,
south,
and
if
here
suppose it is
we are
making
adding
the
the
same
S
orbital
concept
path,
as a special
then
concept through
after
local
some days, so
information
that is
method.
called
So
as
later on,
repeat
what we have
cycle.
done, intentionally
Coming
we have
to
added
swath,
1%
swath
taper and
is
soil
like
noise,
whatever your
and we have
camera you are
classified the same
using.
image. Here
So
you can
it is
see
seeing certain
1% noise
portion,
has been
certain
handled
width.
very
So
nicely.
that particular
Later,
width, whatever
later
is
on, we have
seen by your
increased
sensor, that
the
is called as
percentage of
swath
noise
width. So
to
you
say
can see, suppose this
5%.
is the sensor which
Same
is
taper and
placed
soil noise.
and it is
Now
making
here you can
certain
see
width, so
5%
that is
noise
called as
has
swath
been
width.
also
I'll show it
dealt
to
very
you with
nicely.
some of the
So this is
video.
one concept, how to deal
Coming
the
to
noisy
ascending pass and
pixels in
descending
a given
pass.
image.
So ascending pass
And
is
how
what?
we do
Suppose
all
this
these
is
things, we
my
have
Earth,
developed our own
Earth which is rotating
SMIC
from
tool
west to east,
called
and satellite is revolving from
subpixel
north pole to
multispectral image
south pole.
classifier, which is
Suppose it
capable
is moving, if
to
it is moving
robust
from
for
north pole
different
to
fuzzy
south
based
pole, so that is
algorithms,
called as
large number of
descending
fuzzy based
pass.
algorithms
And
with
whenever
different concepts.
satellite is moving
This
from
is
south
basically
pole to
developed
north
as
pole,
an
that is
in-house
called
tool.
as ascending
I hope
pass. So what
my
is happening whenever Earth is
PPT and
rotating
voice
from
is
west to
coming.
east,
It is a
sun is
long
fixed at some
lecture of
position
2
and
hours,
it is
so
looking
I
to
have
the
to
Earth's
check
surface. So
always,
whenever it is
and
moving from
maybe
north
in
pole to
minute I
south
can
pole,
give break.
then
If you have
sun is looking to that
questions in
area,
between,
and
please do
most of your
ask.
passive
I can
sensor
check
requires
from
sun's
the chat
energy. So
box
during
or
that
later.
part, it is going to acquire
You
the
can
data.
you
And
can
whenever it is
see
moving from south pole to north pole, your active
here
sensor
I
can
don't
work.
see in the chat
But
box
some
any
of the
question yet.
sensors, like thermal
Maybe you may
sensors,
be giving
can work
you may be
during
asking the question later. No
ascending pass
problem.
also,
I don't have any
because it
problem.
is receiving, it is
So
acquiring the
going
data,
further, now
which
moving
energy,
towards
with
more
whatever energy gets
towards
absorbed during daytime.
irrigation,
So
and
nighttime will
specifically
be emitted.
I will give
So
more
that
emphasis for the
energy is
agriculture
actually
side, which
taken
is
from
very
sun
important,
only. So
because
that's why it
India
is
is a
called as passive
agri
sensor, but
country,
it can
because
work
it is
during
more
ascending
dependent
pass
upon the
also.
agricultural
Now
activities
coming to
than
perigee and
industrial
apogee.
purely.
as you know that
and
your
it's very diversified
satellite is
country where
moving with
different
an
crops
elliptical
are
orbit,
grown in different
and
seasons.
whenever
And at
satellite's
state
position
wise,
is
you
at
can
the
see the
farther
changes of the
point, so
crop.
that
So it is
farther
very, very
point is called
important
as buoy,
to
and whenever
study and
satellite is
use the remote
closer to
sensing
your Earth
technique in
surface,
the
that is called as
agriculture
buoy.
domain. So here you can see I will be focusing to map specific
Now,
crop
on the basis
stages
of those two
through remote sensing, and you
orbit,
can see the
your
crop
satellites are
insurance
categorized into two
part,
types, that is
uh,
geostationary
which can be
satellites and
having a good
sun-synchronous
input
satellites.
from this
So
methodology,
sun-synchronous, as
specific
I told to
vegetation
you, that
mapping
most of your
and
optical
post
sensors can
damage
work
mapping.
your descending pass. So that's why it is
The
called
first
as sun synchronous, because
study I'm
it
talking about the
requires sun's
paddy
energy,
fields
so it
which
should
are
be synchronized with the
transplanted
sun. So
at
whenever
a
Earth is
specific
rotating
date.
from
So
west to
if
east, sun is fixed
date
at that
wise the
position,
plantation is
and
going
during
on,
movement
can
from
we
north pole
map
to south pole,
the
that data
paddy
is
fields
getting affected.
transplantation every
So
say
you can
1 week
see here,
date
this is
information?
one of the
So
examples. So
because
most of
paddy
your sun
consumes a lot of
synchronous
water, so we can
satellites are
estimate
having
basically
altitude of
indirectly
700 to
weekly
800
basis
to
how much
900.
water
Some
is
satellites are
consumed.
having
Once we
600
know
kilometers
weekly
altitude.
basis how many fields
Orbital
are
inclination is
transplanted with the paddy
normally
crop. Here we have
98.7
studied
degree, which is very close to
different
pole.
districts we have
Orbital
covered in
period,
the
if it is
Haryana state
700 to
and
800
some
kilometer, it
in the
takes around
Punjab
90
also,
minutes to
like
orbit that
Ambala in
satellite,
Haryana, Pewa, Ladwa,
orbit that
Kurukshetra and
particular Earth
Radhaur. So these are
surface.
4 or 5
It is
districts we have
also called
covered
as near
to
polar
map the
and near circular.
paddy
Satellite
transplanted
orbit is
fields.
fixed in
Here you can
space,
see one
basically north
example.
pole
If
to
we
south
want to
pole,
map the
and Earth
paddy
rotates beneath
transplanted
it, that is
field on
west to
8th of
east.
July,
So you can see
so
here
what we have
satellite
done,
orbit is fixed in space. So
we have
because
taken
of that
2
orbit fixing
pre-transplantation
of this
date image,
orbit, you can see,
19th of
and the
June and
movement of Earth from west to east, your
9th of
whole
June
Earth data gets acquired.
and one date
Normally it
after
crosses the equator
transplantation, that
during
is
morning
13th of
time, so that
July.
it can
And here
receive
you
the
can see the
reflected
concept
energy
of
from Earth's
multi-sensor
surface.
rather, not even
Satellite
bi-sensor.
orbital
These
plane
two
is
images
near
are from
polar, and the
Sentinel 2.
altitude is such that
This is a
satellite
Landsat
passes
image
each
and this
place
is
at same local
Sentinel-1
sun
image.
time.
So here we are using
This
3 sensor
cover
image. And
entire
why
globe,
we are
and
using
examples are your
temporal?
Landsat,
Because
Spot,
if you
NOAA,
take
IRS.
single date image,
IRS is your Indian remote sensing satellite
the
series.
spectral, if you see
Coming to
4 dates,
geostationary
the
satellite,
spectral of
so you know that it is
paddy
why it is
fields,
called
because
as
what happens, the paddy
geostationary,
fields
because
are
it appears
filled with water
stationary
after
to
some
your
time
Earth.
when
It
the
is called
paddy
as
has to
sun
be
synchronous.
transplanted.
Here it is called as
So
geostationary.
during
So you can see
transplantation,
here
the
how
paddy
that Earth
fields
is
and the water bodies looks
rotating,
same.
and
So how to
satellite is moving
distinguish? You can
as
see
such
very
that it
strong
continuously going to
spectral
look to the
overlap
same
with
period.
the water
So
bodies, right?
orbital
So how
inclination
to
of these
separate water
satellites
bodies with the
are
paddy
around
fields?
0 degree,
So the
and period
very
of
good
orbit, because it takes around
concept
24
is we have to
hours
use
to
temporal
rotate. So
images.
period of orbit is around
So if
24
it is a paddy
hours.
field, if you try to
And for
notice, at the
global
first
coverage, it
date,
requires
it
several
is fallow.
geostationary satellites.
Here it is
In sun
fallow.
synchronous satellite, for global coverage, one
Then
satellite is sufficient.
next
But
image,
in this
it
case,
is
because it
water
is
is
going to
applied
see some
so
smaller
that it is
portion,
getting ready
so
to
for
be
remaining
transplanted. In
portion,
the
we have
third,
to
the
launch the
paddy
satellite
is
at different
transplanted.
position, and then we
And
can
fourth
acquire
one,
the
it is
data.
growing. It is further growing. The
Now, this
transplantation
satellite is
plant
good
is
for
further
repetitive
growing. So it
observation,
is
but poor
showing
for
this signature.
spatially detailed data.
And if you
Why
see
the
water
spatial
body in
data
the
is
same
poor?
time,
Because of the
here
altitude.
water
So
body
I'm
will
going to
remain
tell
water
you
body.
about, whenever I talk about spatial
If it is
resolution,
a
I
parallel
will tell
river
you that
or
height is
lake,
one of the
again this
factor
is
which
water
is playing
body.
a role for providing the
Again in this time,
spatial
this is water
detailed
body.
information.
And again
Now,
this time
there is a larger
it is
distortions at
water
higher
body. So in the
latitudes.
paddy field
Why? Because your
also, this
Earth
is water
surface is
body.
not flat,
This is
and
also
your
looking to be water
geostationary
body, and
satellite
this is
data sets are going
partially
to
water and partially
having larger swath width,
pigment is there,
and
the chlorophyll
because of
content. So
that, it is
here
going to
the
cover
graph
that
of
Earth
NDVI will
curvature
be
also.
different, and here
So
the
at
graph of
higher
NDVI will be
latitudes, we have
different.
larger
So you can
distortions.
easily distinguish the
These satellites
paddy
are west to
fields. But
east
here we
and mainly
encountered
used
one
for
problem.
communication and
The
meteorological
dry
application,
canal
weather
was also
forecasting
coming as a
applications.
paddy
GOES,
field. The
Meteosat,
question came
INSAT,
how to
and GSAT
separate
series
this.
satellites are your
So what we have
geostationary
done, we have
satellites.
in the same image data,
So you can
we have
see
added
through
one
this
more image of
animation,
6th
like
March,
how the Earth's
and in the
surface is,
area, if you see
Earth
in
is
6th March,
rotating, and because
mainly
of
it was showing
rotation of Earth and
wheat
revolution
crop,
of this
because the
satellite,
6th
whole
March
Earth
is a
data
Rabi
gets
crop
acquired
season.
again and
The
again.
moment we have
So this is
added the
comparatively
5th image as a
economical
6th March
compared to
image,
your
you can see
airborne
the canal was
data
somewhere
sets.
here that has been easily removed. So this is a very good example of
Now coming to sensors, so your
mapping a
sensors
specific
are
crop
categorized
at
into two
different
types,
time
passive
interval.
and
We have
active sensors.
completely in this
So
work, we have
passive
mapped
sensors are
the
what?
paddy
Whenever
fields
sensor is sending
every
the
5
sun
to
is
10
sending the
days. So we
energy,
can
and
estimate
reflected
how much
energy is
fields has
recorded by
been
your sensor.
transplanted
That is your
every
passive
5
sensor.
to 10 days.
And
And
active
then we can
sensors are
estimate
whenever
the
it
water
is having
requirement
own source of
in that
illumination,
district for
and
the
it is
paddy crop.
receiving back the same from the
With single
target.
date, you
That
cannot map
scattered
these
energy is received by the
specific
sensor. So
crop
that is
because
your
we are going
active sensor.
level 2
So
or
most
level
of your
3
microwave
classification. Level 1 means just agriculture with crop, agriculture field
Now
with
that
crop.
those
Level
sensors
2
are
means
also categorized
in
into
that
two types,
field which
imaging and
crop
non-imaging
is there. So
sensors.
here we are able to map
Non-imaging
the
sensors are
paddy
what? Which is
transplanted crop.
not, which is a
So
kind of
that way
profiling
we can go for
profile
level 2 and
devices.
level 3
Like suppose
classification in crops. Here we have experimented the
spectroradiometers
classifier
are there.
as a
So
CNN model,
spectroradiometer
and you
is a
can see
kind
the
of
structure of the
device
model,
for
120
each
layers
wavelength
of
what reflectance
CN64,
values are
then max
getting
pooling,
received.
and then
That is
dropout
kind
and
of
so forth.
spectral
So
reflectance
this is
curve
the,
which are
and
measured
this,
by a
you can see
particular
the model accuracy and the
device.
model loss.
So
We have
that
got
is
it
called as spectroradiometer.
while
Means for
working with
each
same
wavelength
model
what
for
reflectance
mapping the
values are
transplanted paddy
going to
fields.
come. So that is
We have
measured by
also experimented
spectroradiometer.
to add the
Coming to
LSTM
active
layer,
sensors,
which is
sub
RLM
laser
layer
distance
of
meter, laser water
concept in
depth
CNN,
meter, and
and tried
microwave
to see how
altimeter.
much it is
So laser
effective. It
distance
was little
meter are
least effective
some of the
compared to CNN model,
particular
but here you can
instrument
see
which
still
is
the
going to
structure. This is
target to
64
a
CNN
object,
layers,
and
then LSTM,
laser pulses
and then
are sent,
dropout,
and
then
two-way
max
travel and
pooling,
received back
then
by the
conversion of
sensor.
64
So
like that.
two-way
So these
travel
are
time of
model
those
for
laser
CNN
pulses
LSTM
are
we have
getting
used, and you can
calculated,
see
and
the
using that
model
we can
loss and
calculate
model
the
accuracy.
distance. So same
It
thing
was
can be
little
done for the
less
water depth measurement also. This laser
to,
water depth meter
output
are
in
normally
comparison
useful for
to
measuring the depth
CNN
of
output.
lake and some
Next,
lower depth
we
of
have
water.
developed a technique
Microwave
how
wave
to deal
altimeters can be used for
heterogeneity
measuring the
within class,
sea depth.
considering
Then
each
coming to
sample
imaging
impact. So the
sensor,
concept what
now
you have tried,
normal
that
photographic camera I
we
have
are
listed over
using
here
the
as passive
impact of
sensor,
each
but let
sample
me tell you,
in the
whenever you are
classifier,
using
and we
external
can handle
energy
the
source like
heterogeneity,
normal
which is
outside
not
light,
seen
and then
in
you are
the
taking photograph,
conventional machine
then
learning
only it is
algorithms
passive
like
sensor.
C
But whenever
means,
you are in
maximum
dark, you are
likelihood,
using with
or
flash
fuzzy
these
classifiers,
cameras,
or
then
support
that
vector
is
machine.
working as
So they
active
are not
sensor.
capable because they
Now
generate
coming to
statistical
most of your
parameters, and they
sensors
cannot
which
deal
are
the
acquiring
heterogeneity within
data
class.
are
Just try
using
to
this
understand the
optical
heterogeneity
scanner,
within
that is
class.
across
So this
track
can be
and
a
along
forest
track
patch.
scanner.
This can be
And coming to
homogeneous,
thermal
but
scanner,
here you can see little
thermal scanner is
heterogeneity
also one
within
of the
forest.
scanner which
And
is
this is
going
a
to provide
dry
you
land,
two-dimensional
but here
image.
somewhere it is
Coming to
white,
active
that is dry
sensors, active
soil,
sensors
and
are
somewhere it is
synthetic
wet. So
aperture
in the
radar
complete
and
this
LiDAR.
polygon,
So
you
these are
can
the
see it
sensors
is
which
not
are sending its
homogeneous.
own source
There
of
is lot of
energy and
heterogeneity.
receiving
So
back
if you
the
try to
sensor.
map
So
this,
they are
you will
also
not get
providing
much
the
better results.
two-dimensional
But what
images
we have
of
tried,
the
because in the conventional machine learning algorithm,
now
what we
coming
do
to
from the
across
given
track
samples,
multispectral
suppose
scanning.
there are 10
Now
samples,
in
we try
the
to
name of this
generate the
across
mean
track
parameter,
multispectral
and
scanning is
using
also
this mean
called as
parameter,
Wisp-Broom
we
scanner. Now
use
why it is
and
called as
train the
across
algorithm.
track and
But we are
Wisp-Broom?
not doing
You
the
can
same
see
thing.
through this
We are
particular
using these
animation. In
samples
this
as
case,
mean.
it is having a rotating scan mirror,
So once we
and
do
it is
that, we
rotating
get an
pixel
impact
by
of each
pixel and
sample in
moving
the
in further
output,
direction.
and that way we can
And
see
this
the
scans the
heterogeneity
earth in a
within
series of
class has
lines.
been
So
handled.
it
In
is
an agriculture
appearing like
field,
it
why
is
the
moving
heterogeneity
across the
comes?
track and
Because
collecting
water
the
is not
data.
applied
So
uniformly.
why it
Because
is
it is
called as
applied
whisk
through a
broom?
small
Like you are
channel,
using a
water is
broom
not going
and you are
uniformly in the
moving
field.
in across the
Fertilizer
track
is applied
and
by
scanning the
hands. It is
and
not applied
collecting the
uniformly. There may be
data.
somewhere more
So
fertilizer
for
and somewhere
each
less
wavelength,
fertilizer.
the
So with that,
detectors
you
are
can see
different.
in the
Suppose
same field, the
multispectral data
crop
sets
health
are
is
there,
not
which is
same,
having
right?
blue,
Somewhere
green, red,
little
near
weak, not
infrared
much
band.
weak,
So
small
for each band,
weakness
the
is there.
detectors
So
will
with
be
that, you
different.
can see the
So in
heterogeneity
this case, the
within
lines are
field. So
oriented
that
perpendicular to the
basically
direction of
gives you
motion of sensor
diversified
platform
impact
across the
of
swath.
that field
Data
on
are
the
collected
image, and
within
then
an
when you
arc below
classify
the
that
system,
pixels,
typically
you don't
from
get the
90
very
to
good
120
results.
degrees. So
So
you can
how to
see here
deal with
this particular
the
inclination
example
angle
is through
is
heterogeneity.
actually 90
Now
to
I can give you the
120 degree.
live
That is
example
called
of
as
this one.
field of
We have
view. And this
experimented this
particular
in a
smaller angle,
Banasthali
whatever
area,
made
which
by
is
that
near
detector, that is
Jaipur,
called
which
as
is a girls'
instantaneous
university,
field of
well
view.
known
That is a
in
solid cone
India.
viewed by the sensor.
So we have
So
tried to
normal
map
examples,
specific
your
crop,
multispectral
specific
scanner,
wheat, grass,
thematic
and mustard.
mapper,
So here
and
I'm giving you
operational
the
land imager
example
of
of
Landsat
mustard crop
satellites
when we
are
have used
using this
individual
Wisp-Broom
samples.
scanner.
So you can see this
AVHRR
was a
of
test
NOAA
field.
satellites are
I
example of
myself has
Wisp-Broom
visited this field,
scanners.
and this is the Banasthali campus, and they have
Coming to
the
push-broom scanner, push-broom scanners
runway
scan
strip,
the earth
because
in
they
a
have
series
flying
of
club
lines.
also.
So
This is
in
the
this
runway
case,
strip.
there is a
So this was the
no
field which
rotating
was
scan mirrors are there. In
checked by
place of
myself,
that, we have
and on the
linear array
ground this
of
is the mustard
detectors.
field.
So
And you
thousands
can
of
see when
charge
we are
coupled
using
devices are
individual
placed in a
sample, that
linear
means we are
array,
using each
and
sample
at an
as it is.
instant, it is
It is
collecting
quite
the data with the
homogeneously
movement of
mapped. But
satellite.
when this
So
field has
forward
been
motion of platform
mapped
to record
to
successive
statistical
scan lines and
parameters
built up
by
a
fuzzy
two-dimensional
classifier,
image
you can see
perpendicular to the flight
complete
direction.
field has not
So
been mapped
examples,
properly.
linear
Somewhere
image,
few pixels are
imaging
left. So you
self-scanning,
can
wide
see
field
due to the
sensor of Indian remote
heterogeneity,
sensing
the
satellite
output is
series,
not so
and
much
high resolution
homogeneous.
visible of Spot 1 are the
We have
examples of your
experimented for
push-broom
grass in
sensor.
the same area in the
So
Banasthali
I will, before
area.
I'll
So within the
move further,
campus
I'm
there is
going to
cricket
show
ground,
few
there
of
is
the
a parade
animation to
ground, and
understand
further
these
one
two
more field
scanners
within
in a better
campus. They
way.
have been came very
So
nicely. If you see here,
you
the
can
cricket
see
ground
here
came,
how
but
the whisk broom
this
scanner
field did
is
not came
working.
hardly, and this field also came
You can
partially.
see it
If
is
you see
collecting
outskirts near to the
pixel by
runway,
pixel
there
using
were
a
good
rotating scan mirror
grasslands
and
which was
moving in
not
a
picked up
further
here.
direction.
But when we have
Now,
used
because
individual
of the
samples,
movement
you can
and
see
the
these
satellite is
fields has
also
been mapped very
moving,
nicely.
the time by which the
Same way for the
sensor is
wheat
receiving the
crop,
signal is
these were
very,
the
very
two
small.
fields which
So
was
that
checked
is
by
called
me as a
as
ground
dwell
truth
time.
data,
So
which has
that
been
also
mapped
I'm
very
going to
nicely.
tell that
But
how
here,
the
if
dwell
you
time
see,
is
the
less in this
same
case.
training field did not came
And
so
this is
nicely when
scanning.
I'm using statistical
This
parameters.
has
So
to
this is a
scan by
new
using mirror scan
innovation.
velocity
We have
and
just
collector
tried this
rate.
last year onwards. One paper is
So this is
published in
called as
JAR
whisk broom
Spy
scanner.
Journal
Across the track
by
it is
Margang
collecting
et al.
and moving in further
And a
direction.
second paper is under review.
Now coming to the
And
push
few
broom
more
scanner,
papers we are
in case of
experimented
push broom
for
scanner,
different
you can
classes,
see
so
with the
that we
movement
can
of satellite,
get a good
the push broom scanner is
check
collecting.
on
It's
this
like pushing
proposed
the
methodology.
broom in
so
further
that
direction
specifically
and
for
collecting the
heterogeneity
data.
handling.
So along
With
the
an
track,
image.
this
We have
scanner
also
is
experimented
moving
with
and
UAV
collecting the
images,
data. So
specifically
that's
for
why this is called
cauliflower,
as
because you
post-bloom
can see
scanner.
one flower
And this
itself,
particular
the
area which
cauliflower
is
itself
getting
is a very
covered, that width
heterogeneous
which is
object.
covered by your
Somewhere
satellite, that is
very
censored,
green leaf,
that is called as the
somewhere there is
swatch.
shadow of the leaves within
You
the
can see
by
through
the
this
its
animation,
own
this will
leaves they are
make you
giving
more
shadow.
clear about the
Somewhere the
swatch
leaves
width.
are too young. The
So
center part
you can
they are
see
too young, and you can see there is a weed here.
that how the
So
scanner, in
weed
this
is
case,
giving very
Pscmrcet
good
scanner being used,
correlation
and it is
with the
scanning
center part, which
and
is
it is
cauliflower.
collecting the
The shadow
data. So
part,
this
what we are
particular
getting here,
area, the
this
width
shadow
seen
part
by
is
your
coming
sensor,
here.
that is
So
called as
again, you can
swatch.
see very strong
And
spectral
how Earth
overlap.
is rotating
So
and
that
that
is a
scanner is
challenge
moving, that is
how to
shown with
deal
this particular
these
image.
spectral overlap due to shadow or due to green young leaves of the cauliflower with the wheat fields. We have tried with the preliminary
Now, I was talking
results,
to you
and we got
about
very good output, and it has good hope to work further
dwell
and
time.
improve the results.
So
You can
dwell
see
time is the
these
time
cauliflower has been mapped
seen
still
by
very
that particular
nicely, and
detector
the
to
weed is
your
not
Earth
so much coming
surface.
dominant.
So you can see here in this
So
case
you
of
can see the
across
usual
track scanner, this mirror
cauliflower
scan
tree.
velocity is
Still,
around,
we have
scan
to work
rate
for the
is 2
center
into
part,
10 to
which
the
has
power
not been
minus
mapped
2
so
second
nicely.
per scan
Maybe we
line.
have to see further
Here
how to
the
add some
size
few
of that
samples in this
particular
location.
pixel is 10 meter by 10 meter, and the
For
swatch width is 20
further on the
pixels.
crop side,
So
you
there
can
are
see we have
total
experimented
2000 cells
to
to be
map
acquired for
sunflower
this particular
crop.
scanner.
In northern India,
So
we
dwell time can be
we don't feel
calculated by
much
scan rate per line,
crop
that is
of
2 into 10
sunflower,
to
but
the
in
power
south
minus 2 second
we
per
may have,
cell,
I think, more
and total
sunflower
cells
crop, but
present in
still in
this
the
swatch
Pscmrcet,
width
one
is
of the
2000.
district
So you
called
can see
Shahbag
here, whenever we
area,
have
we are able to
calculated, we
get
are
this
getting
crop
1
in
into 10 to
majority
the
in
power
bulk.
minus
So
5
again, we have used
seconds
the
per
temporal
cell.
images,
Now
and this
coming to
crop
your
generally
along
grown
track
from
scanner,
Feb
which is having linear array of detectors.
to
So
April
in
and
this
May,
case, dwell time is
and we
cell
have taken the
dimension
images
upon
from
velocity
21st
of the
March to 30th of April,
along track scanner.
say
So
6 or 7
the
images.
scanner here
So
is
using
moving with the speed
CBSI
of 200
NDVI
meter per
approach, we have
second,
tried to
and
reduce the
size of the
spectral
cell
information,
is
and
10 meter
this
per cell.
NDVI you know,
So when
but
we
CBI
calculated
is a
10
new
meter
proposed
per
approach
cell
by
by
us.
200 meter
What
per
is the use of
second, we are
CBI?
getting 5
The
into
CBI
10
is
to the
basically
power minus 2
class-based
second per
sensor
cell.
independent.
Now,
The approach
why
of
it is
this
important?
is that
It
it
is
gives a
important
feed
because
of
for
which
getting a
bands
better
should be considered in
resolution
NDVI.
data,
In
we
theory, we have
should
read
receive, or
we have to
sensor should
use red
receive more
and NIR
signal
band,
from Earth
but here we
surface to the
found
detector.
as the number of
And
bands
if we
are
are getting
increasing
more signal,
and
the
the
resolution
same
of the
field is
data will
changing
be
in
better.
time, because
The
we are working
resolution
in a
like
time
your
domain,
spatial
same
resolution, your
field is
radiometry
fallow
will be
initially,
better.
then
So for
little crop,
those
and then
things,
more
we
crop.
require
So in
that
time domain, that
energy
NDVI
should
is
be,
changing.
the
So
signal should be
CBSI
more, so
takes
the dwell
care
time should be
with
more.
each image
But in this
which
case, the dwell
bands
time should
should
be
be
is
considered.
less
So we don't
because
have
this is
to
having a
feed the
rotating
bands
scan mirror,
in the
and
NDVI.
satellite
It
is
will
also
take
having
care
motion.
its
So
own
that scanner has to scan
feed
fast
to
and it
NDVI.
has to move with the satellite
That's the
also.
beauty.
But
It
in
is
this
just
case,
like
with the movement of
when I
satellite, it is
say
collecting the
the
data.
mobile phone
So
is used
that
very nicely by a rickshaw
dwell
fellow.
time
Why?
is
Because he's not
higher
interested to
here,
know
but
on
here the
which
scanner
frequency the
had to
mobile
move
phone is
fast
working,
to complete
on
the
what is the
swatch. So that's
motherboard,
why
and
the
so
dwell
forth.
time
He
is
just
less
want to
here
know
in this
the
case.
green and red button. So here what we have done, the
Now,
technology is in the back end. If we
for
just
getting
press
high
one button,
spatial
we
resolution
can
data,
the
there are
algorithm
another kind
will
of
tell
technique.
us which bands
Like
should
I
be picked
told
up
you about
in a
this
given data.
Pscmrcet
Nowadays
scanner,
in the
because
multispectral
dwell
image,
time
you
is
may
more,
see
so it is
there
going to
are 10
provide
to
you
12
better
bands
resolution
are
data.
available,
Now, in that
and
case,
we get confused
linear array of
which band
detectors
should be
are
used
there.
for a
So in
particular
place of
indices.
linear array of
So
detectors, we can use
CBSI takes
area
care.
array of
It provides
detectors.
for us
So area array of
the
detectors
best
will
suitable
acquire
bands,
data.
so
Like
that
suppose
with
first
that band combination,
a
it
line
gives
had acquired the
maximum
data, then it
enhancement
had
to
moved
that
further.
class. That is
Then
also one
second
of the
line had
beauty.
acquired the data for the same area. It transferred the
So here
data
you
to
can
the
see
following line.
the
Then again, the
outputs for
other
the
detector which is
sunflower.
following,
We
that
are
is
able
also
to
collecting
map
the data.
not even
So
second
whatever
level,
signals we are
third level.
receiving, we are
Second level is
integrating
first
those
level is
signals,
crop.
and we are
Second
getting
level is
the
sunflower,
better
and third
details,
level
better
is
signals data, more signals
the
for this
sunflower crop
area,
is
and
early
we can
sown,
generate a
middle
better
sown,
resolution
or
data.
late sown. So we are
Coming
going
to
up to
another
third level
technique
of
which are
mapping
used by
within
your Indian
sunflower
sensors.
crop. So here you can
So
see
they
we
are
are able to
called as
map
step-on
early sown
steer.
as a red
It
patch,
is like
middle sown as a green
this
patch,
is suppose the
and the
target
late
which
sown as a
satellite had
blue
to
patch.
observe,
So we can
and
now we can
sensor
do
is
social
moving like it is
aspect
stepping
analysis
at different.
that why
It is moving at
the
different
sowing
steps
has been
and
done
steering to the
at
different
different
positions.
time.
So suppose
And
it is starting with
we
this
can locate the
time.
fields
It is
and we can
moving
have
at
a
different step,
interview with the
observing the
farmers to
area,
know
means like steering
why
this
the
particular
sowing has been
area,
done at
then
different
moving at
time.
different
And
step,
that way we can
moving,
conclude the issues
observing
coming
this
up in
area,
that
moving at
area
different
that
step,
farmers are
observing this
sowing
area.
at different
So
time. Maybe it's
in
personally
this
showed the
case, we
farmer,
are also
the field was
observing
not
so much
ready
data,
or
and
the
we are
seed was not
integrating those
available,
signals, and we are
and
getting
that
a
these
better
all
resolution data.
these all statistical information we can
Now,
generate
coming
while
to the
in the context
resolution.
of
So
sowing of a
normally what
particular
happens
crop.
whenever you are using any digital
This
photograph
is
and you
also
are
same
zooming it, it is
sunflower
getting
crop at
pixelated.
early
And
sowing,
why it is
middle
pixelated?
sown, and
Because
late
this is the
sown.
smallest unit of any
Then
image
we have
that is called as
also
picture
done in the
element.
agriculture
So the
domain
short form of that
the
picture
burn
element is
paddy
called as pixel.
fields
And
identification
you know
in the
that we are
surrounding
not
of
able to
Patiala. We
manipulate
have
any
taken
hard
Patiala
copy
as a test
photograph,
site.
but we can
So
manipulate the digital
the paddy
photograph.
burn field in
Why?
northern India
Because
is
your
very
computer
hot
is reading
news,
nothing but
specifically in the
some
month of
numbers.
October
And those
and
numbers are what?
November,
Those
and it
numbers
gives a
are
very
spectral
strong
reflectance values
feed of
of
pollutants in the environment,
acquired from the
and the
Earth's
nearby
surface.
capital
So
of
you
India
know that each object
is very
giving
seriously
different
affected
reflectance
due to that
values
pollutants
at
coming in the
different wavelengths.
atmosphere. So how to
Now,
control
coming
is
to
we should
like
able to
which kind
identify
of
the
data you can
fields, and
use
then we
for
can
which kind of
take charge
application.
to the
So
farmers
for
who are
that you
doing this
have to
activity.
understand
What happens
resolution.
here, what we've
So
noticed in the field,
resolution is
from
what?
end of
Ability of a
September
system
onwards, we can
to
see this
render the
activity starts
information
because
at
the
smallest
paddy is getting
discretely
harvested,
separable
the
quantity
early
in
paddy,
terms of
and this
distance,
activity
in terms
starts.
of
So can we
wavelength,
map
wavelength
these
band
information up to
of
field
EMR,
level?
in terms
The
of
answer is
time,
yes.
and
We
in
have worked
terms
with
of
Central
radiation received
2
by the
data,
sensor.
and we have
So
taken
they are
here
categorized into four categories,
burning
that is
image
spatial,
and the
spectral, and
post burning
radiometric,
image.
and temporal.
And we have seen in the field, the
Spatial is
fields
something
are the
like,
moment it is
suppose we
burned
have
in the
two
evening
objects
hours,
which are 1 meter apart,
immediately they
and
do the
suppose the
plowing
spatial
and
resolution
they do
is
the
10
sowing
meter
of the wheat
of
crop.
that
So
pixel.
here you
So
can
whether
see we
those
have
two
mapped
objects will be
from
appearing,
30th of
we can distinguish
September
those two objects which are 1 meter apart,
in
we cannot
2018,
do. But
5th
if
of
those two
October,
objects are apart,
12th of
your
October, 15th of
spatial resolution is
October,
suppose 1 meter
20th of
or 50
October,
centimeter, those
25th of
two objects will
October,
appear at different
30th of
pixels, so we can
October,
see the
then
detailed
9th of
information
November,
in
and then
this
19th
particular
of
high
November. So you
spatial
can see
resolution
by
data.
end of September
Spectral
to
resolution
middle
is
of
what?
November,
A
every
measure of
5 to
width
10
of
days
wavelength
interval,
which is
we
used
are
to
able
generate
to
the
map the
image. So
fields
narrower the
of the
bandwidth,
burn
higher
paddy
the
fields.
spectral resolution.
Up to field level mapping we are
So
doing.
you can compare
So
with
if we
two
do this
cameras like black and
monitoring
white
every
camera and
some
colored
very
camera.
prominent
So black
interval
and
of say
white
5
camera
days, so
using
farmers
entire
will be quite
visible
alert
wavelength range
that
as single
the
band.
government is
But in
watching
color
them,
camera,
and
you
they
are
will not
dividing that
do
into
these type of
3 bands,
activities.
that
They
is
can
red, green,
see
and
some
blue.
other
Means you are
substitute
separating those
for
bands in a finer
removing these
bandwidth to
dry
get a
biomass
better
from that
detailed
field.
information, so that you can
So you can
differentiate
see
the
in this
feature more
animated image
clearly.
also
Radiometric
the
is
time
what? A
tag,
measure of
the different
what is
fields
the
were
minimum change
mapped.
in radiance that can be measured. So your sensor is measuring radiance, and those radiance values are assigned with some digital number value depending on the radiometric
If there are
range, that
questions,
is
I can
quantization
take,
level.
and if you
So
want some break in
if that
between,
is
because 2
radiometric
hours
values are
lecture continuous is not
we have suppose
genuine
8-bit
time
data or 10-bit data,
to
so we
make you to
can
sit,
provide
but
more
still as your
radiometric value
choice, I
to the
can go on
radiance,
doing
and
it.
we can differentiate the smaller
It's all up
changes
to you.
observed. Temporal is how frequently we are observing the data for the same
There is one
area.
question
So that is providing the temporal
by
resolution.
FDP.
So let
How
us
do we minimize
go
the effect
one
of
by one the
different
spatial
spatial
resolution. So you can see here,
resolution
this
of
is the
multi-date and multi-sensor
detector,
data while
and this is
doing
the area
such
which is
kind of
viewed by the
analysis? Is
sensor.
there
So this is your
any
instantaneous field of view, that is the solid
difficulty
cone,
between
which
or
you can
difference between
calculate by detector
object-based
dimension
classification
upon
or
focal
fuzzy
length.
classification?
And
Okay,
whenever you are
let me take
multiplying with
this
the height,
question
it
also.
will
You will
tell you
get
about the ground
partially
resolution
break, or let
element
me see some
covered by
any other
that
question.
particular detector.
Yeah, there are a few
So
questions
whenever
coming
you
up,
are
so let me
flying
take
with
in
a
between
higher
these questions.
altitude,
First
the
question what I've
ground
seen is,
resolution
what is the
element will
difference
be
between
coarser.
fuzzy-based
So that's why
classification
your
and
spatial resolution is coarser in your geostationary
traditional
satellite. So for
classification
detailed
method?
mapping of land
Difference
use
between
practices
traditional
requires
is
a much
basically
greater
we
spatial
are talking about
resolution.
hard classifier. That means here
Now coming to
one pixel is
the
labeled
application. So for
as
which application,
single
which
class,
resolution
say
data
water.
is
But in
required.
the
So for
fuzzy, if
meteorological
there are 2 or
application,
more
cloud
than 2
patterns,
classes, so
movement,
we can
1
apply
to
the
2
fuzzy
kilometer
classifier.
resolution
It
will be
can map
sufficient,
how much
and
is
water
class
vapor
1,
analysis 8 kilometer resolution will be
how much
sufficient,
is class
and
2,
oceanographic
and how much is
application,
class 3 in the
chlorophyll,
form of
ocean color
membership value.
monitoring,
So that
chlorophyll
is the
segment
difference
map, and
between
etc.
fuzzy-based
There are various
classification and
applications.
traditional
300
classifier.
to 1100
And
meter
second
resolution is
question is
sufficient.
coming,
For land use mapping like crop monitoring,
how
forest
do we
mapping,
minimize the
hydrological
effect of
application,
different
20 to
spatial
30 meter resolution is
resolution
sufficient.
of
For land use
multi-date? So here
like cartographic
we have
planning, urban
experimented
planning,
already
2 to 6 meter
in
resolution is
when I was
sufficient,
talking about
and for military
Haridwar
surveillance
test
less
site,
than
which was
equals to
mapped
1
for
meter.
paddy as well as
So
Ganga
you
River
can
and
now I'll
canal.
show you the
There we have
difference between
used
different
Landsat image,
resolution.
and with
You
the
can see here, this
Formosat
is the
image,
data of
Landsat
ocean
gives you
color
30 meter,
monitor, and we have taken 4 kilometer by 4 kilometer area
and
from that
Formosat is
area. You can see you
at
are
8
not
meter.
able to
So
see
what we
many
have
of the
done, we have
features in this image.
resampled this 30 meter
But
to
whenever we
8 meter.
increase
So
the
that way
spatial
you can take
resolution to
care the
188
spatial
meter, we
resolution
started
of
seeing some
multi-rate
of the
image. You can
features,
bring
but
all
not
the
here.
images to higher
But when we
spatial
move to
resolution.
72
Of
meter
course,
spatial
when you do
resolution,
it,
you can see
the
some of the
information
features
content
started
will
getting
not
here
increase,
in this particular
but
case. This is
technically
response sensor data.
you can have one-to-one
And in case
correspondence of
of
the
36
pixels,
meter resolution,
so you can do processing.
see that this
So that is the
particular
answer
data
of first
sets
one.
are here airstrip is also coming very
Second
clear
is
in
there
this
any
case.
difference between
Now coming to the
object-based
another
classification and
resolution,
fuzzy
that is
classification? Yes.
23
In the
meter
fuzzy-based
and
classification,
5.8
it is
meter
using
resolution
only the
data. So in
pixel
23 meter
information.
resolution, you can see
And
more details
of
are
course,
there, but
as
here
per
the
the
shape of the
classifiers and as
buildings
per
are
the
not
input
clear.
data,
But
you can
when we
take
use
care
the
about the
6
mixed
meter
pixels, you
resolution
can take
data,
care
you can
about
see the
the
edges of or the
noisy
boundaries of the
pixels, you
features
can
are
take care
more
about the
clear, because it
non-linearity
is
of the
utilizing the
classes, you
full
can take
range
care
of
of the
the
spectral overlap if you
visible
use
to
the
near
temporal
infrared
data.
wavelength.
And
And
if you are using
thus,
heterogeneity, if you
because
want to
of the
minimize the
wider range of
heterogeneity, you
sensitivity,
can
the
basically
panchromatic
take
is
individual
able
sample
to
as mean.
provide high
In the
spatial
object-based
resolution.
classification, we are generating so
And
many
in case of
parameters
multispectral, we
like
are further
shape,
subdividing into
texture,
smaller wavelength range.
hierarchy,
So it
and
is
the
receiving
use of
smaller energy.
object-based
So that's
classification
why
is
our
to
spatial
process
resolution is
very
comparatively
higher
coarser.
spatial
Now
resolution
this is just
images, so
another
that
example. You can
individual
see with
objects like
56 meter,
buildings,
30 meter,
cars, roads
23.5
can be
meter
mapped.
and 15
But
meter
in the fuzzy
resolution.
based, we are
So
not
with the
mapping
change in
these
the resolution, you can see
where
the
these
detailed
specific
of the
objects. We are
details of
basically
the features are
focusing on the land use,
changing.
land, very
And whenever
specific
we are using
land
4
use,
meter
land
and
cover
1 meter resolution
classes to
data,
be
you can
mapped.
see all the features are coming
Then
very,
there is one
very
more
clear.
question: what is
So
the
with the higher spatial
resolution of the
resolution, the
maps
smallest
required
details in the
for
image can
agriculture
also be
studies
observed.
for fuzzy based
Now coming
classifier?
to
I
spectral
think the
resolution.
question is
Spectral resolution
on the
normally describes the
output. When we
ability of
get the
sensor to
output,
define
what
fine
is the
wavelength interval.
scale
So
of the
normally,
map?
depending on this, the sensors
Depending
are,
upon the
there are 3 categories
resolution you
of
are using.
this
Suppose I have
data
used
depending on spectral
10
resolution.
meter
That is panchromatic, multispectral.
Sentinel-2
So this
data.
I
So there
told
are
you the
some
difference
thumb
between
rules
black and white
by
and color
which you
camera.
can
So
estimate
this is
what
also
may be
similar.
the
Like
scale,
if you
at
are
what
using a
scale
black and
the
white camera
output
and you
has
are
been
taking the photograph,
generated. So
so
thumb
you
rule,
can
there are so many
differentiate the
theories. One
features
theory
with
says
different gray values.
pixel size
And if you are
multiplied
using
by
a colored camera, you can
10,000.
assign different bands
So
and
if
you
you
can
do
generate a
that,
different color composite
it
out of
becomes
it.
1:1
Now
lakh.
coming to
So that
hyperspectral, if
way
you have
you
more
can
bands, means if you are
decide
further subdividing this
the
wavelength
scale
range
of
into more
output map.
details, we are
Next
able
is
to get
how
more
to
number of
interpret
bands in
two
this case.
features showing
So you can
same
see here,
pixel
whenever
value.
we are
Okay,
using Landsat 7, this
two
is the same
features
data,
showing same pixel
data of
value. That
same
means that
area
is
of
spectral
Rishikesh.
overlap.
This is Landsat
In
7
that
ETM
case,
plus
if
satellite
these
data,
classes are
which is with
changing,
6
like
band. So you
water
can see
and
here, we can
tree,
plot the
so what may
nature of
happen, tree may
spectral
have
reflectance
flowering,
curve.
tree may
So we
have
can
leaf shading. So if
identify
you
this
take
is
temporal
vegetation.
images,
In
the
case
water
of
will remain
band 9,
same,
we
but the
started
tree
seeing
will
certain
change. And with the help of this
absorptions
temporal
coming over
information,
here.
you
So
can
this can
discriminate
be
tree
observed
with
with more number of
water
bands. And
during
when we increase the
digital
bands to 150, you can
classification.
see smaller details
So
are
these are the
going to
few,
come.
I think,
So higher the spectral resolution,
questions
better
I've
ability
tried.
to exploit
Now I can
differences
move
in spectral
further.
signatures. So,
And that way you've
but
got
for
some
display,
break
only 3
also,
bands can be
because
displayed
continuous
by,
lectures
because
listening
in
is not
computer only 3
so easy
color
task.
guns can be used, that
So
is
now you can see
RGB.
in the
So your
larger
display,
perspective, the same
only
burn
these data
fields
sets are there, but in
mapped
that
in different
we have
dates,
6 bands,
30th
we
of
have 9 bands, and we have
then
150 bands.
19th of November and so forth, starting from 20th
Now
of October,
coming to this, for
25th of
using
October,
various data sets,
30th
we
of
can generate
October,
different color composites. So
9th of
whenever we are
November
using
and
red
19th of
through red
November.
color gun,
So this is
green
larger
band through green
perspective.
color gun, and blue band through blue color
And
gun, that is called as
next,
true color or natural
again in the
color
agriculture, you
composite.
can see
But
we have
whenever
tried to
we are
map
using
sugarcane.
near
Actually,
infrared through
sugarcane is not
red
a crop.
and red
Within
through green
sugarcane,
and
you will
green
see
through blue, then that
subcrops,
is
which is
called as
plant and
standard
ratoon.
false color
Sugar
composite.
mills are
So
interested
these color
first when
composites
the
are required
ratoon will
because you know
come
that
to
longer
them,
the
because
wavelength, least
ratoon
affected
grows
by
is
atmosphere.
ready within 6
So
to
your
7
blue wavelength
months, but
scatters
the
more.
plant
So that's
crop
why we
takes
are
time around
using,
9
and
to
you know that
10
in case
months.
of vegetation, you have higher
So here you
reflectance
can see
values
we
in
have
near
used
infrared
AWIF's
range.
image long back,
So
which was at
that's
60
why we are
meter
using the standard false color
resolution. And
composite
here you
in
can
case
see
of
the
interpreting the remote
green
sensing
and the
data.
red one.
Now these are the
So one is
various bands,
ratoon
and for
and one
which
is
band which
plant. So here
type
the
of
green
data
one
sets
is your
can be used. So normally blue band are
plant and the
useful
red
for
one is is
concentration of
ratoon.
air
So we
water
can discriminate the
purposes.
two
For green band,
sub-crops
it
within
records the
sugarcane,
green
because
reflectance
sugarcane is not a crop
vegetation
actually.
and
Within
assess
sugarcane,
plant
you have to
vigor,
tell it is
reflectance
plant
from
or
turbid water.
ratoon. The sugar
Then coming
mill
to
are
red
interested
band,
to
this
know
band
in their
operates in the
sugarcane
chlorophyll
catchment how
absorption
much is
region and is
ratoon and
best
how
for
much is
detecting
plant,
roots and bare
because they
soil.
know
Near
ratoon come
infrared
first
band is
to
useful
them
for
by
discriminating
October onwards in northern India,
for estimating
and
biomass. It
plant
separates
comes
water body
by
from
January
vegetation and
onwards.
discriminates
So they
soil
should know the
moisture.
stock
And
how much is
mid-infrared,
the
that is
stock
band
going on
5,
for them,
is
so that their mill
considered as the
runs
best
for the
single
full
band for differentiating
defined duration
more
from October to maybe
maximum
March
of
or
the
April.
land cover features. And this
So
also
this is very
discriminates
important
snow
technique,
from the
and
clouds.
this was done long back in
Coming to
Avis.
this
We have
particular
experimented
infrared
with
band,
list 3,
that is band
and
7,
there we have
because
tried
band 6
to
is
add
thermal band.
Landsat
So
data
here I
also.
have written band 7.
Why we should use
So this band is useful
the
for
dual
discriminating
sensor
mineral
data
and rock
or
types and for
multi-sensor
interpreting
data,
vegetation
because
cover
we
and
are
moisture.
working in optical
Now,
domain,
you can
and
see
then what
here, these are
happens
the
in the
various
optical
spectral
domain,
reflectance
there
curve.
are chances
So
of
if you
cloud
have
cover.
to differentiate
So we may
between
require
snow
very
and
frequent
ice, you can
images
snow
of
and ice
time
and
domain,
cloud.
time
So you can see
tagged
cloud
images.
is having
So
almost
there can
higher
be cloud cover
reflectance,
for this
but in
image,
case of
and
snow,
this
it is
image may
having
be
higher
very
reflectance
important
in
to
visible
give
region,
the
but lower
very
reflectance in
unique
longer
physiological information of the
infrared region.
crop. So
So
how
you
to
can see
achieve
here,
at
whatever
the
cloud
nearby
and snow
date,
are there, they
is
all
it
are appearing
possible
white
to
in
use
way
other
higher
optical
near infrared
data?
region.
So answer
But
is
when we
yes, we
use
have
the
tried with Landsat,
short wave
and
infrared
nowadays
region,
we are
cloud is appearing white,
experimenting
but snow are
rigorously with
appearing
SAR
black.
images.
In case of
And
this
if
green
suppose these
reflectance, you
3
can
images are
see
not available,
that urban features are
so can
having
we
higher
replace these
values,
images
but
with the SAR?
other features
And
are
very
we are
beautiful
not able
sensor
to
today
distinguish.
is Sentinel.
Here
The
when we
Sentinel
use
2 is
near
optical and
infrared
Sentinel 1
reflectance,
is
the
SAR. So
vegetation
can we
is
use
having high
SAR
reflectance
Sentinel 1?
and water
Answer
body
is
is
yes. So
having lower
here we
reflectance,
can
so that's
feed
why
the
they are
SAR
able to
images, which
they are
can represent the
differentiated
unique
in this
stage of the
case.
crop, to discriminate that
Now
crop
coming
with
to
other crops
radiometric
lying in that
resolution,
area.
as I
The
told to
beauty
you
of
that
SAR, the
radiometric
Sentinel data
resolution of
is,
an imaging
this is
system
for SAR
describes its
1 and
ability to
for
discriminate
Sentinel 1 and Sentinel
very
2,
slight
their
differences in the
geometrical
energy.
registration is very
So
good.
whatever
So
radiance
there is
values we are
1-to-1 pixel
observing,
correspondence
so whenever we
between
have to
SAR and optical.
differentiate
So
that,
these
we
problems
can
you don't
differentiate through the
feel in the
quantization
Sentinel
levels
data. Previously, when we
provided
used
by the
Landsat with list
sensor.
3,
So
we have
you
to
can
struggle
see
a
here
lot
that depends
to
on
give
number of bits. So 2
very
to the power
perfect
number of bits
pixel
will
to pixel
represent number of gray
registration,
labels. So
because
if
they were
suppose
having
it is
different
1 bit
orbital
data, we have
parameters.
2 gray
So it is
labels.
very difficult
If
to
we have
achieve
4
2
bit
with
data,
length of
16
ground
gray labels
with
ranging from 0 to
ground
15.
control points.
If we
But
have
in the
8
case of
bit data, we
Sentinel
have
image,
256 gray
the
labels
SAR
ranging
and
from 0 to
optical,
255.
they are
So you can
very,
see here,
they are registered with very high
when we are
accuracy. So
using two
we don't
colors,
have to
we
struggle
are
to
only
have
able to
pixel
assign
pixel
two
correspondence
values to
from
this
two different
data.
sensors. So
When we
nowadays
use
it is not
16 colors, you
that we
can
can
see
insert the
that
optical
16
to
values are
optical.
assigned
We
to
can
different
add
particular
SAR
features.
image
But
also.
when we
And
have
I
more,
give
you
the
can see
example in
the
the
features
class
which are having
that
smaller
if
changes
people don't
also
accept
can be
that we
assigned.
can use
We
dual
have assigned
sensor,
different
that means
radiometric
data from
values.
two different sensors or data from
Now
more
coming
than
to
two
temporal
different
resolution,
sensors as a
this
multi-sensor
depends on
concept.
two
I
things,
tell in
that
the
is
real life,
instrument's field of vision and
a
satellite
Tamil
source.
Nadu girl can
So
marry a
it
Punjabi boy.
represents
They
the
have different
frequency,
culture. They
that
have
how
been
it is
brought
acquiring
up
the
in different
data for that area.
environment. They speak different
So
language. Their
as
eating
you
habits are
can see,
different.
suppose
Wearing clothes is
one
different. Everything is different.
orbital
Still
pass
they
is
marry
made
and
by the
survive
satellite,
in the
and
life.
same
Same way
orbital pass
here,
is
if we
made by
learn
the
from the
satellite
nature,
by
cannot we
taking the
use
repeat
the
coverage.
different
So
sensors?
that is going
Answer
to tell
is
you about the
yes.
going to give you the
Only thing you have to
revisit of that
believe it
area.
is possible.
And
I have
revisit you
believed
can
it from
also
last 10
do
years. Initially,
by
I worked with
tilting the
optical to
sensor.
optical,
Suppose we
and
have passed
nowadays
from
I'm
that particular
intentionally
area, we
rigorously
tilted the
using the
sensor
SAR
and
with
we can
optical,
capture
and
the
I'm
same
getting very
area.
good
So
results.
revisiting can be done by two ways, by
So here
tilting the
you
sensor
can see
or
one
by
of the
making the
example
same
again
orbital
for
pass.
paddy
So you
fields,
can
but
see
what we have
here,
tried, we have
for
used the
meteorological
kernels
application,
concept to
hourly
handle
need
the
to monitor the
non-linearity between
clouds are
classes in the
required.
fuzzy
For
classifier. So
oceanographic
here you can see
application,
we are
2
able
to 3
to
days of
map the
repetitivity is
transplanted paddy
required.
fields on
For stereo viewing,
24th of
0 to
June,
1 days of
then
repetitivity
10th
is
of
required.
July,
And for
and we are
vegetation monitoring,
also
5
able to
days of
separate the
repetitivity.
water bodies,
You can
because
see
in the
here why
transplanted
these
paddy
data sets
fields
are
there
required,
are
because
water
if
bodies like
suppose you have to
river,
go for change detection,
canal,
you can
or
see here
small
this data is
ponds,
acquired in
and
November
again river.
2009, and
So
this
can we
data is acquired
separate
in
these water
February.
bodies
You
with
can see
the
this vegetation
transplanted
features
paddy
are getting
fields?
dried here.
Answer is
So how it is
yes.
appearing in this particular data. Now
Here you can see
coming
with
to
the
the
naked eyes
various
itself,
Earth
as a
observation satellites
harvesting
launched by
stage
different
information while
countries
using
and different
World
space
View 2
agencies.
data,
So this
which is
is
at
a
multispectral
table which is
2 meter
representing various
data I
satellites.
got
So from
freely
Europe, we have
in 2010,
France
and
has
this
launched
was
Spot
also
series
accepted
of
as one of the
satellite. And this satellite
research
was having one of the major advantage that
recognition
this is
worldwide
having
in the
tilting
first top
capability,
15.
and it is
And
of
what
another
we have got it
capabilities
here,
there. So
we
that's
have
why it is
just used
able to
one image
provide
of
you
3rd
stereo
March
data of that area.
2010
This was
and
one of
2nd
the
March 12th
good thing
April
with this
2010.
satellite
And you
series.
can see
And
from
recently
this
they
date to
have
this
launched
date
Spot
harvesting
6
is
and
going on,
Spot
and
7
these fields
with
has
a
been harvested, which
purpose
are
of
basically wheat
getting
fields.
high spatial
So
resolutions
just using
data
these
sets
two
for
date
whole
images
Earth
as
surface.
the harvesting
Then
stage
from
information,
European
we are
Space
able to map
Agency,
the
these are few of
wheat
the
fields,
microwave
and you can
satellites which
see with
was
the naked
launched. That
eyes
was
how nicely the accuracy
ERS-1
has
and
came
2
up,
and
and how nicely
NVSat.
these wheat fields has
But
been
recently
mapped. And
they
you can
have
see
launched
here
Sentinel
these
1A and
fields are
1B
also
and
appearing
Sentinel
red,
2A and 2B.
but
So
these fields
this
have not
1A and
been
1B is actually
been
providing the
mapped.
SAR data sets in
These
C-band,
fields are also appearing
microwave
red,
satellite
but
data
not
sets
been
they are
mapped as
providing. That is
crop,
openly
because you can
accessible.
see they're
You
coming
can
black. That means this was
register
not the
to
wheat
their
field,
website and
and
you
this
can
was not the
download this
wheat
for
field.
your
This was also not the wheat field.
and Sentinel-2A and
So you can
2B.
easily see
So
how
till
there's
10
been
meter spatial
removed,
resolution
and only
data,
the wheat
they are
fields
also
has been mapped very
providing
nicely.
to you,
Again,
and that
further,
also you
we
can
have
use.
also
There are
experimented
other
again
bands
with
as
waves
well,
images
but 10 meter
with
spatial
P6
resolution
for
data in
wheat field
multispectral
in the
is
Udham Singh
accessible
Nagar
through
district.
this particular
We have
Sentinel.
taken, because wheat is grown from
Then
November
from Middle East
to
Israel, we
May,
have
we have
Eros
taken the
A
image up
and
to
B.
March
Then from NASA, we
November,
have Lancet
and this
series
is
of
the preliminary
satellite with
steps we have
Bird,
done. TVI,
Iconos, then Orview. This
and here you
Iconos
can
and
see the
Orview
wheat
satellite
fields
series
again
are
with
your
the fuzzy
commercial
classifiers. Why
satellites.
we are doing
Then
band
Lancet
showing?
8 was
Because
launched in
spectral dimensionality
2013.
should be
We have Worldview
minimized,
satellite
because one side
series
you have
also.
time
So
dimension,
those
and one
satellite
side you
data
have
sets which are used in Google Earth
spectral
images are from Iconos
dimension, and already you
and
have two more dimensions
GeoEye1.
as
So they are from
row
this.
and column. So
Then
image
from
is actually
Canada, we have
three-dimensional, not
RadarSat series of
four-dimensional. So
satellite.
now you have four
Then
dimensions.
from
So
India,
this
we have
is
Indian remote
always
sensing
there,
satellite
row and
series, and
column or
Cartosat
latitude, and
2
time is
series
there, and
are
spectral is
recently
there.
launched. We
Since
have
you want to
Resourcesat
maintain
1,
time
2.
so that you can
So I'm
map the
going to
specific
discuss those
crop, so
satellites
spectral
also. From Japan, we have
information should be
ALOS satellite.
reduced,
So ALOS
and
2 is still
we have
working,
done
which is
it
having
through
microwave
band vision concept.
sensor. ALOS 1 was having multispectral
Again, we have
sensors as
tried
well.
in the south,
So those
Maharashtra,
sensors
Aurangabad, for
data sets
cotton
are
crop
also
as
there,
one of the
which you can
PhD
use.
scholar.
These are
And you
few
can
of the
see the cotton crop there, it's grown from
distributing
May,
agencies
and
which
it's
are
getting harvested by
taking care
December
of the
or
data
Feb up to
distribution. In case of India, we have
October
NASA
onwards,
Remote
harvesting
Sensing
starts.
Center.
The
Earth
plucking of
Explorer
that
is one of the
bulbs
websites which are taking care
of
of
the cottons, and
Lancet
we are
series
able
of
to map
satellite data
the
sets.
cotton
So that
fields
also you
here
can
in
use for your
the surroundings
own
of
project
Aurangabad.
work also.
Within Dehradun, Shivalik hills
Now
are there.
coming to Lancet
The
series of
broadleaf forest,
satellites.
can we
So
map
first
that?
satellite
Yes,
was
answer
launched in
is using the
1972
temporal
with
data.
185
Very uniquely
kilometers
we can
to
map
orbit
this.
with multispectral scanner
We have
sensor.
also
So it
tried
was
in
having
the
4
urban.
bands, green, red,
That's a
and 2
little unique
near-infrared band
application.
with
Last
80
time we have
meter spatial
experimented,
resolution.
and this
And
work was
first series
also
of
published
satellite
in
was
SN
Lancet
Applied
1,
Science
2, and
Springer
3 with
Journal.
similar sensor.
Can we map
Then
the
Lancet 4 was
building
launched in
change detection?
1983
In the
with an
built-up, we
upgraded
simply
instrument
map
thematic
only the
mapper,
how much
which is
built-up has
having
changed.
blue, green,
But here
red,
what we have
near-infrared,
tried
and
to
2
map the
photo-infrared, and 1
building
thermo-infrared band with
footprints,
30
which
meter
has
spatial
changed
resolution.
from
But
open
swath width
space
was
to
same. So you
building
can see the
as a
sensor's
new
capability
building.
was
So can we
increased
map the new
because
building
the
level mapping?
altitude here
Answer
is
was
also
yes.
decreased.
We've
Earlier one
used
is
the
around
two-date
900
image,
kilometers
one
and
of
this was
October
around 700 kilometers
2013.
altitude.
That's a Landsat image.
Then
And
Lancet
second
5 was also
October
having similar instrument.
2019,
Lancet
again
6
from
was built just
Sentinel-2
after
image.
the
You can see the
launch.
example of dual
Lancet
sensor,
7 was
but
launched in
sensors are different.
1999,
They are having
which is having
different
additional
spatial
15 meter
resolutions. Can we
panchromatic
accommodate
sensor.
that? Answer is
Then
yes.
Lancet 8 was launched on February
We have used here
13
classifier
with
fuzzy
operational
based
land imager and
PCM
thermal infrared
classifier,
sensor.
and you can
So
see we
in
have
this
taken some
additional
training
2
and
bands
test
are
sites
there,
within
that is
Dehradun.
coastal blue
So
and
this was the
cirrus band
Baruwala we have taken
is
as
there in this
a
particular satellite
training site,
sensor data,
and these are the
and
test
2
sites
thermal
in
infrared
Doon
band of 100
University,
meters spatial
Kalidas
resolution
Road.
is
That's
there.
our own campus and the surroundings.
Now
Sabji
coming to
Mandi, main
Spot
Sabji
series
Mandi
of
of Dehradun,
satellites. So
and
first
then
was launched
ISBT of
in
Dehradun. So
1986. As I
these are the
told you,
test
this is
sites.
having off-nadir look
You
capability,
can
so
see
it
here
can tilt the sensor
within
and see the same
Kalidas
area.
Road and IRS
And as
campus,
I
we are
told
able to
you, this
map the
constellation
building
Spot 6 and
footprints
7
which has
was with
been
the purpose of
transformed
getting
from open
high
space.
resolution data
So
up
this
to
is Shivalik apartment
2024
here
for whole
on
Earth
the
surface.
Kalidas Road. This is a new Vikram Sarabhai building.
Now coming to
This
your
is a
Indian
Golden
remote
Jubilee.
sensing satellite
This is a
series,
mess
we
here. This is a
started with
Golden Jubilee hostel, and this
IRS-1A,
is the
LIS-1 and
outside
LIS-2, which is
building
with
which is changed
72
from
meter and 36
concrete
meter
roof to
spatial
tin
resolution.
roof.
Now
And
we
this is one
reached
of
to
the
Cartosat 2
apartment at the
series and
entrance of IRS
Resourcesat
called
2A,
Meridin
which is
Heights.
having
So
LIS-4
these all
sensor with
specific
5.8
buildings
meter
were
resolution
able
in
to map,
multispectral.
which has
And in
turned up in
Cartosat
the
2
last
series, we
6
have
years. So
panchromatic
here we are
in
not
less than
mapping
1
only the
meter
built up.
resolution and
Within built
multispectral
up,
with
we are
around
mapping
2
the
meters spatial
buildings
resolution.
which has been
So
transformed from
we
open
started with,
space.
you can
When
see
we have compared
72
with the NDVI
meters from
difference, we just see NDVI has
1988 we
changed,
reached
but
till
we can't see that individual building.
less than
Here
1 meter
we can
spaces
see again
resolution.
with the conventional post classification change
Now
detection,
these are
we
few of
cannot
the
see these
sensors
buildings are
and
coming so
the
nicely.
images from various data. So this is
Same way you
IRS
can see for
wristband camera. So you
Baruwala,
can see how the
which was a
sensors
test
are
site,
appearing
which
with
was training
blue,
site.
green, red
The
and near
individual
infrared
buildings,
channels.
which you can
So
see
these
on the
are the
Google image,
detectors for
previously it was
different
not
bands.
there.
So
Here,
as I told to you,
but
either it is whisk broom or
with
push broom
time, these
sensor, for
buildings turned
different
up
bands
as
the
a one of the
detector will be
colony,
different.
and you can see these
So
buildings
in
have been
this
mapped
case,
so
this one
nicely.
sensor with
When we
72
have compared
meter
with the
resolution, this
NDVI,
is from
difference is not
Chandigarh
came
area. So you can
through
see how the
conventional.
image
We
is
can see only
appearing,
built-up
and
change,
this
but
is the
not the
smaller portion of the
individual
same
building
area.
change.
So
Here you
you
can
can
see.
see with 36
So
meter
that's the beauty
resolution
of
how
this
the data
approach.
is appearing.
we have done for Doon University.
Now
only
coming
2
to
new
the
buildings
Liski
came up,
sensor with
which has been
23
mapped very
meter
nicely
resolution.
here.
This is the
But in
image
the
from
conventional approach of
Hyderabad.
NDVI
So
difference
this is
or
your Hussain
conventional
Sagar
post
Lake, and this is the
classification
Hyderabad
change
city with 23
detection, we
meter
cannot map
resolution.
these
And this
buildings
is
so
your
nicely.
IRS panchromatic camera, that is a
Again,
single
for
band
Sabji Mandi
camera.
surroundings,
So you
there
can
are
see
very
here
large
that
apartments has came up,
buildings, this
and
is the
which we,
Chandigarh,
in
which
the
is a
last
planned
6 years, we are
city.
able to
So
map
the
these new
colony of
apartments.
this and buildings
But through
were clearly
NDVI change
extracted
difference
through,
or
can be
through
extracted through
post
this type of
classification
data
change
sets. Now coming
detection,
to
which is
WIFS
conventional
camera data, so
built-up
you can
change
see with
detection
WIFS
approach,
with
we are not
188
able to
meter
map
spatial
these new
resolution. So you
apartments so
can see how
nicely.
the features
And
are
for
appearing in this
ISBT,
WIFS camera.
ISBT is quite old
Then
one.
coming
This
to
is the
56
ISBT
meter spatial
campus here.
resolution, you can see this is
But
the
in the
AWIPS
surrounding
image.
of
So
it, we
you
are
can
able to map the
differentiate
new
here that
malls
how
which just came
snow
up
will
and the
be
new
appearing
government
in this
offices.
area
So
and
these are
how
the new
cloud is
buildings in the
appearing in
last
this
6 years
southern
came
part
up, which
of
are
this
able to map
image.
this,
So this is
but
the
which were
spatial
not able to
resolution
see here in
advanced.
the
This
conventional
is your
built-up
wide field
change
sensor.
or
This is
through NDVI
advanced wide
difference.
field sensor with 56 meter.
We have also tried in the post earthquake damage
Now coming to your Liski
identification,
image again of
specifically long
Hyderabad
back
city. So
one
when the
earthquake came
23
in the
meter
Bhuj
resolution data is
in
there, you can see the
2001
detailed
on
information for this. And
26th
with
of January. So we
5.8
have
meter,
taken
this is
2
one
date
of the
image
part that is
pre
Kankadia Lake in
earthquake,
Ahmedabad
that is on
city.
4th of
So you
January. We
can
have
see
taken
the
one image,
different features
and
very clearly in
second is
this
post earthquake on
spatial resolution.
29th of January
Now this is
2001.
your Cartosat
And
images,
you can see
that
here
is
we are able to map the
Cartosat
liquefaction,
1 and
because
2
in that
images.
Bhuj
So you can
area
see the
lot
spatial
of
resolution is high. So you
artificial
can see
water
the
bodies were
individual buildings
formed
in this
due
particular
to the
data set. These are from
liquefaction
Hyderabad, Bangalore,
activity
and this is the
in that
Bangalore
area.
Vidhan
And
Sabha.
there
So you
are
can see how
natural
it is
water
coming over
bodies. So
here,
can
and
we
one of the
distinguish
stadium
which is the
near to
natural
that
water
Vidhan
body
Sabha.
and which is the
And this is one of
liquefaction
the
area?
Australian airports. So
Answer
you can
is
see individual
yes.
flights in this particular data set.
So you can see all these red patches are the
Now this is the
new
recently launched
artificially
Cartosat 2
formed
series
water
image. So this
bodies.
is the fused images of panchromatic
In
and
the
multispectral of 2 meter.
again the Bhuj
So
area
this is
with
less
different
than 1 meter
techniques
resolution data. So
using
you can see
IRS
here that
1D
individual buildings
list 3
very
data,
clearly in this
we are able to
image.
map the liquefaction area.
Now
And
these are the
in the
Indian Earth
Balakot,
observation missions in the near
that is
future. So
Pakistan occupied
Cartosat 3
area
will
in
be going to come with
2006 and
panchromatic with
5 and
around
6. There is an
0.25 meter
earthquake came,
resolution with 60
very
kilometers far
heavy
field
damage has
and
occurred,
multispectral
around
with 1 meter.
80% built up
Spatial
was
resolution.
damaged.
Resource
So
at
here the
3 and
question
3A
was,
with
can we
advanced
map
RIS-3 sensor with
the
10 meter
urban damage
and
area
925
and
kilometers
urban
for
undamaged
width.
area? Answer
Then
was yes. The red
Oceansat
patches are
3
the
and 3A
damaged one,
will
and
be
the
launched
blue
with
patches
ocean
are
color
the
monitor,
undamaged
remote sensing
urban
sampler,
area.
that 3S and
Then
3SA
can
with
we
1.25 meter stereo
distinguish
imaging.
this
One
urban
of the
damage and
future
non-damage with
satellite
the
is
landslide? Answer is
geostationary
yes. So here
imaging
you can see
satellite,
these
in
are the
which we are
landslide
going
patches
to
which were
get
able to
high
map. We have
temporal resolution
already
data with
compared with
50
the
meter
very
in
high
multispectral and
resolution images for the same area
around
which was
100
available to
meters
us,
or
and we can
300
we were
meters in
able to
case of
compare our
hyperspectral images.
results with that very high
Then coming to
resolution
other countries,
images.
high spatial
How
resolution
we
satellites. So
proceed
Iconos
for
was the
this
first
temporal
commercial
data? For
satellite
this also we have developed
which was delivering
as an
near
extension of
photographic
Smite
quality
tool,
image of
which can
anywhere
handle
in the
the
world.
temporal data
Then
in 4
QuickBird,
steps.
WorldView
Just in
1,
4
2,
steps you
3,
will
and
get the
4.
output.
So
Here you have
WorldView
to load
4
the
was
first
one of
image.
the
Other
satellite which
images
is
you can load from
providing
here,
1, 3,
and
and
same
4,
palette you can
which is
generate
the
the
highest
NDVI, just a
resolution
single
provider,
click.
that is around
From
31
NDVI it will generate
centimeter
the training
in
data
case of
also, and here
panchromatic,
you
and
choose
in
the
case of
classifier, and
multispectral,
finally it
it
gives
is
you the
around
classified
1.24
output. So here you
meters
can see
and
the loading the
1.24 meter
images.
spatial
Here you can
resolution.
select the number of clicks
GUI
for
was
training
the
data,
earlier
and for
satellite which was
indices which
providing
you
high
want,
spatial
you want
resolution,
single
that
click
was
or
41
multiple clicks.
centimeter. But
And
recently,
this
due
is
to
the
some technical issues, they
approach
increased
as
the
a region
altitude. Now
drawing
they are
to
able to
collect
provide
the samples
0.46
for
meter
training purpose.
spatial resolution. Then
And
Pleiades 1A,
you can
1B,
save the
SkySat
NDVI
1,
output,
2,
and after
and
that you
Korean
just
satellites
choose
are
any of the
also there,
classifier. These
which is 1,
classifier
2,
series of
3, and 3A.
classifiers which are
So they are
taking
also
different
high
distance
spatial
concept,
resolution data
and you can apply
providers.
any of the one
So this is
to
one of the
extract
Iconos
only one
image of
class,
Indian
because
Institute
these
of Remote
classifiers like
Sensing
PCM,
campus. So
we
you
have
can
gone for
see
MPCM
this is
and NC
1 meter
also.
resolution data,
They
1
can
meter
map
and 4
a
meter
single
multispectral
class.
So you can see
Here you can see
individual
PCM,
trees and individual
here and
features you
PCM
can
classifier,
buildings
here
you
you
can
can see noise clustering.
identify
So
through
all
this
these
type
three
of data
classifiers are
sets.
fully capable
This is
to
one of the
map
image of
single class. So there
GOI1
are
and
large number of
Iconos image of
applications like
2009 and
in agriculture.
2011.
If you
This is
want to go
Fukushima
for
Daiichi
yield
nuclear power
estimation,
plant. So you can
per
see the
square
features
meter you can
in
know how much is the
these
yield,
two
but you
images.
want to know how many
Then
in how
coming
many
to
fields
COMSET
that crop
3
has
and
been
3A.
grown. So
So
that is only
and Worldview
possible.
3
You have to use
and
temporal
Worldview
data.
4. You
You have
can
to use
see
specific
if you zoom
classifier
this
which can
particular
map a
area,
single
you can
class
see
and so forth,
individual
which
cars
can take care
parked in this
noisy
particular
information, which can
data
take care the
very,
mixed
very
pixel,
clear.
which can take care the non-linearity between classes, which can take care heterogeneity within classes and so forth. So these are the
Coming to
things which
meteorological
you have to
satellite,
take
normally
care
this
while
designed
mapping
specifically for weather
the
prediction
second
and
level or
monitoring.
third level of information
Advantages
from a
are
given
global
image.
coverage at very high temporal
I
resolution.
hope my
Various type
PPT
of
and
meteosats
slide is
are as
coming
follows.
fine.
NOAA
I'm reaching
series
to my end of my lecture.
satellites operated by US named after National
And yeah,
Oceanic and
this is
Atmospheric
my
Administration. These have near polar sun-synchronous orbits. GOES, GSAT, and INSAT series satellites
Last
are in
slide,
geostationary orbits. So India has launched GSAT and INSAT series satellites, which are used for telecommunication and meteorological purposes. Now, where you can find this particular information, so ITC Netherlands has the database of different sensors and satellites. So you can see the different vendors, distributors through this website, and you
So
can search
last
those
year we were able
particular
to publish one book on fuzzy machine
information
learning
about those
algorithms
data
for
sets.
remote sensing
If
image
you want to
classification
real-time
with
track the
CRC
satellite,
Press,
you can
Taylor
use
and
this
Francis
website to
publisher.
track the satellite
And
also, that
this
how the
talks about
satellite
total
movement is taking
story
place.
about fuzzy
These
classifiers
are
with
few
full
of
range,
the data browsing
with the actual
websites through which you can
practical
browse
methodology we
and
have
you can
developed
download some of the
and the
data
tool
sets
details.
free of
And
cost.
we
So
are
you
going
can
for
see this
second
is
book on
the,
specifically on deep
in
learning
case of
with different concepts in the
this
remote sensing
one
domain. Which is at
Noida
the midway.
and
Hopefully in the coming 6 months we will get
.nic.gov.in.
the second
So
book
in this you
in the
can
market
download
on
list 3
deep learning
data
with
of
applications in remote
around
sensing
24
areas.
meters spatial
Now we can
resolution
think
from
about any
for
questions if you
Indian
have.
region
I'll try my
through this
best to
website. That is also openly
clarify your
accessible.
doubts,
And
your
if you want
questions.
to download
I'm
the
quite
data Landsat
early to
series of
finish it off.
data
I've
sets, so
not
you
given
can use
much.
this Maybe
can have more time for discussion.
usgS.gov. And for downloading the Sentinel data, you can
Now
use
stage is
this
to you all. Please,
scihub.copernicus.eu. So this data websites you can use for your data browsing and downloading purposes. So thank you.
Hello, Kiranami madam, please you read out the questions from the chat box. Hello, Kiranami madam.
Sir.
Read out the questions. Actually, participants, they
Yes,
have
sir.
posted the questions in chat box.
Yes, sir. Sir, here is a question, sir.
Yeah.
Could you please practically show sample image classification using fuzzy classification using software?
Okay. This I will do in the end, or you want I can do in between also. I'll just give you one example because I have to just see relocate. I'm not ready for it, but I'll just see my data and other things. Just give me a minute. And
My name is Lynn Healy. I'm the Technical Project Manager in the Digital and Data team at the Joint Nature Conservation Committee, and I'll be your chair for today's webinar.
Show you how the tool
The
works
Joint
and
Nature
how you can
Conservation Committee,
classify.
JNCC, is the public body that advises the UK government and devolved
Since I'm working on my own
administrations
office
on
PC, so it is easy
UK-wide
for
and
me
international
to
nature
relocate all the
conservation.
things. I'm
We
not
are
ready for this
an impartial
for live
scientific authority,
demonstration, but
and we
anyway,
provide advice
since
on
I can do
practical,
it, so I will do it.
policy-relevant, evidence-based
Since I was
solutions
sitting in the
to
same
support decision-making. Just move my slides on. It works. There we go. The aim of today's webinar is to introduce you to the potential role of Earth observation data, products and services for operational use across a range of policy areas. Before we go any further, I'll need to go over some housekeeping rules, and you've probably already heard that we're recording today's session and we'll be making it publicly available on the JNCC YouTube channel. We'll be hiding delegate names and images. So please remain on mute throughout and keep your webcams off unless you're presenting.
Because I've not stopped my sharing.
We'll also be sharing a selection of the PDFs. We'll be sharing the slides via PDF, apologies, and we'll email these directly to you and let you know when they're available through Twitter. If you wish to ask the speakers questions, please type these into your questions tab. And if I ask your question to the speaker and you wish to add a follow-up or clarifying question, please use the raise your hand function and I will do my best to unmute you and bring you in verbally for the follow-on question. So obviously, please note that you should be happy to be introduced by your name if you want to do so, because it's being recorded.
Now you can see that
please feel free to tweet about the webinar. So this is the tool here. And if you do so, please use our JNCC hashtag so that we can pick it up and retweet,
just select here
at the end of today's session, we'll be sharing a link to a short feedback survey. Please do fill this in, as it really does help us to improve these sorts of sessions in future, and all the feedback is anonymous.
So here you can see it is reading.
So today's agenda looks like this, and the focus will be on introducing Earth observation data and technologies with lots of case studies and practical examples.
And it has displayed the image. It displayed the last band. I hope you are able to see this image. What is displayed?
Helena Sykes from Natural Resources Wales,
Yes, sir.
and Mark Richardson from Planet.
Then you can
to kick off
display
the webinar, I'll just
image
first
into
explain
false
a little
color
bit about the Copernicus program,
if you
the
want,
funding
because by
source,
default it
and
is
the
displaying the fourth band.
JNCC's
You can take
Copernicus User Uptake
4,
project.
3 and
The
2.
Copernicus program is the most ambitious Earth
So this is
observation
your
program
false
to date.
true
Copernicus
standard false
delivers
color
operational
composite.
data by observing our
And you can
environment
see this is
primarily using a
Hardwar
suite of satellites called the
city,
Sentinels.
and this is the upper Ganga
It
canal which is
collects,
going from Hardwar
stores,
towards
and
Delhi.
analyzes data
This is
and
Ganga
provides
river,
products
and
and
this is one
services
canal coming
openly
from
and
again from
freely in a wide
Hardwar
range of
side,
applications,
right?
as you
And
can see
maximum
here.
because this images of
The
March
funding for today's session
and the
is
maximum
the
fields
Caroline
are
Herschel
filled with
Framework
wheat.
Partnership Agreement.
So what I will do, I
It's a
already have a
consortium of
signature file, but if you
organisations of
want, you
which
can create the
JNCC
signature
are
file
one,
while
and
clicking
it
on the
aims
image.
to
Like
increase
if you
the
click
uptake
here,
of use
it
of
will say, do you
Copernicus
want to save
data,
clicks? You
products,
say
and
yes.
services.
So window
It
has
does this
popped
by
up. You can keep the
implementing a
window
series
this
of
side,
actions.
and you can click more on the water body. You can see here
JNCC's
clicks are coming
statutory
up.
UK
3 clicks.
international
You can just
remit
notice on
and
the
strong
command prompt.
culture of partnership, working, and
4 click,
innovation
5, 6,
means
7,
we're uniquely
like that. Clicks
placed
are
to
there.
develop
If you
shared,
say add,
cost-effective
save
solutions
signature,
for our partners
and
and
now you can give the
stakeholders.
class name, say water.
So our action has a series
So
of
this signature has
components
been saved.
designed to enable
Later
long-term
on, you
uptake
can go
of
to
Copernicus
classifier,
data across UK public
and this
environmental
window
functions.
comes. Now you can see
Today's
large number of classifiers
webinar introducing
like
Earth
noise
observation
clustering
is
without
part of two
entropy,
of our
fuzzy
projects,
C means,
one working
fuzzy
with the
C mean
Animal and
S.
Plant
Here it is
Health
using the
Agency
contextual
and
information.
the other with Welsh
Then
Government
here you
and
have,
Forestry and Land
I can just
Scotland.
come down. It is going up. So here,
So now to start the
then
session,
you have here
I'm now pleased to
possibilistic
introduce
C
Gua
means. I talked
Jones with a
about
couple of slides
modified
from Paula in
possibilistic C means.
amongst
This is the best
to
one.
explain what
You can
Earth
apply.
observation is and to
Then
give us a
here
tour
you can
of the
open the signature
technology.
file. I'm taking the ready-made signature file which is already ready, or just now which I've created. That also possible. We can
So
do that.
over to you, Gua.
I'm already using the already captured file. This is the water, and if you say OK, now you can see it is giving you the statistical parameter mean for band 1, band 2, band 3, and band 4. And you have the variance covariance also here in the command prompt. This is a variance covariance matrix 4x4 only for one class. So if you want only water body, you can do it. You just select modified possibilistic C mean. There are other variables which is free, because once you take MPCM, the M is a factor which controls the fuzziness.
So
if M is tending to 1,
and
then it is
I am going
hard.
to kick things
When
off
M
today
is
by giving
towards
everyone
infinity, then
a
it gives
basic
you fuzzy
introduction to Earth
output. But
observation.
since we
So
are taking
Earth
MPCM
observation
with single
101,
class,
if you will.
M becomes free, and other variables are for
So
other
the purpose of
algorithms which
this
I will
first
not
session by
discuss.
me
And
is
here
to
you
go
can see
through the
large
basic
number of
science of
distances
Earth
are there,
observation
like equilibrium
and to give
distance,
you a
variance
flavour
covariance,
of what the
diagonal
technology can do from
variance
the
covariance,
sensors
Manhattan,
perspective.
chessboard, mean
Later
absolute
on,
difference,
you will
Canberra,
hear what will be
breakers,
done
cosine
from the
correlation.
perspectives
There are
of
around
the
18, 19
application side
distances we
and
have
the
explored,
integrating
but in the
Earth
book
observation
or in
into
the commercial tool, you
operational
see
use
only
side.
equilibrium distance
So
or
hopefully at
variance
the end of the
covariance.
afternoon,
Variance
you will
covariance
have a
distance is
complete
called
overview of what
Mahalanobis
it
distance.
takes to work with these data
Yeah.
and
So
what it can
here
do
I'm
for
just
your
taking equilibrium
specific
distance.
areas. I will also
And
be
just if
raising
you say here
awareness
classify,
of the advantages and limitations of the technology,
please keep your mic
and will
close.
hopefully give you
So
the
here you can
tools
see it
to
has
be
already
able to
completed.
ask
It says
yourselves the right
mu
sorts of
has been
questions when it
computed
comes
for
to
modified
answering
possibilistic
whether
C
Earth
mean.
observation
Now it is
data can
prompting you
help
save.
you with your
So here
work
I give
areas.
say suppose test.
So we start off
Dash
with
15.
understanding the terms.
So you can see here
Now,
test
if you've come
15,
across
today's
the
15.
technology
So
before,
you
you
can
will
just
have
see the
heard the
output
term
is
remote
already
sensing
done. It says
and
base
Earth
classification,
observation used.
and it is
So
just doing
what's
it
the difference?
and it may, within few
In
seconds it will save.
truth,
Now it says
both
process
terms are
complete.
used
Output is test
interchangeably within
15
the
0. 0 means
community,
first
and
class.
the term you will
So what
hear
I
is
will do it
largely
here,
dependent
I
on
will open
geography. So
one
for
more.
example, our colleagues in
But I will
America have
run
always preferred
this
to
tool
use the
one
term
more
remote
time so that
sensing,
I can get one more
while over
window.
here in Europe, we tend
And
to
now
use
I
Earth
will display the
observation more.
output test 15. Here you can
This
see
is starting
the
to
file
change, and
test
Earth
15. This is
observation
the
is
test 15
becoming
0,
the more
and
standard
this is the header
term.
file. I'm selecting
And
the
hopefully
image,
these
say open.
definitions will give you a
Now you
clue
can
as to
see
why that
here the
is.
water has been
So
having
remote
very high
sensing
membership
is
value
the term we
compared
use
to
when
other class,
gathering
right?
information about an
So this is only
object
one
or
step I've shown
phenomenon
you, and if
without
I just
making
click
physical
here, you can
contact,
read the
while Earth
membership value of the
observation
class
is
water.
gathering
If I
information
just click here,
specifically
you
about
say
the
yes,
Earth systems
you can see
using
here
remote
the
sensing
value is
technologies.
252.
So
Because it is
all
in
Earth
8-bit,
observation is
the
remote
value should be
sensing, but
255.
not
So
all remote
252 is
sensing
very close to
is Earth
255,
observation.
hardly difference of
the example I
3.
like to use
But
here
if you see
is
other
the
pixels,
remote
dark one
sensing
or this one,
technologies they use in medicine,
it is
such as
15.
X-rays, which is
Little
clearly
forest,
not Earth
it is
observation.
showing 254. So other classes are having value,
So
say
all the
250,
technologies we
150
use
or 100.
is based on the
But
science
water is
of
having
the
very high value. Say
electromagnetic
canal. In the
spectrum.
canal, if you see, it is
I found this
254
fun little
because canal has
diagram
more pure
from
water, more uniform
xkcd.com
depth
to
water.
help you
So
remember
the
those
value is
lessons
very
in high
close
school
to
physics
55.
classes about the spectrum.
So this way you can map.
Now we only
And
use a tiny
there are some other
proportion
approaches which I have
with our
not shown
own
here.
eyes, the visible
It
light
will take
part,
time, but I've just given you
and you can see how
flavor
narrow that part of the
of working
spectrum
of the tool.
is.
Same
Now,
way,
the
I can show
sensors
you
we
the
for
temporal
Earth
one,
observation
how the temporal
uses this whole
module
part
works
of
of
the
it one
spectrum.
of this.
So when you hear me talk
It'll
about
just take a minute,
sensors seeing
since you
beyond
have
the
already
visible,
given me
this
charge.
is what I
Let
mean.
me just show you.
So
That
many
you are
sensors out there
satisfied,
collect data in the
and
infrared
this
part
I
of
will
the
show you geo. I will
spectrum,
not
which
run
we cannot see with our eyes, moving through to thermal and then onto microwaves and radio waves. So the
this one is the
sensors
temporal one,
we work
and
with generally
here
work in two
you can
different
load
ways,
the one image.
which are
I'll
called
just not
passive
load all the
and
images, just I'll
active
show
sensing.
loading one image. So
Most
here
Earth
I have load
observation
one image.
sensors are
Again, it is
passive,
reading that
only
image
receiving
right
data
here,
from
4
reflected
band
sunlight.
rows column. It
But
is
a few
8 bit
sensors utilize
like that.
active sensing
And if
by
you want to
capturing
display
the
this image
return
in
of
false
their
color,
own
you can change the
transmitted
band
signal.
combination 4, 3,
Passive
and
sensors
then
cannot
2.
see through cloud, but active
So again, you
sensors are
got the same
generally
image in the
not
temporal.
affected by
Now
cloud.
from here, you can load the
We
temporal
don't
images.
really use the terms
Any
passive
number
and
of images,
active
2,
in
4, 5.
everyday
If you have 6
language
images
in the
temporal of
field.
the same
So
area,
when
you
referring
go on
to these
loading it.
sensors, we
And
tend
after
to use
that,
the
after
term
loading, you decide here
optical
which
for passive,
band combinations you
and
want.
then the names of the
Like which
technologies
indices, like this is
for
this is
active
simple
sensors.
ratio.
For
This is
example,
NDVI,
radar
this is
and
TVI,
LiDAR.
this is EMSABI2
The
or
key point
EMSABI,
here is that
and
remote sensing
EVI. So
technologies do not directly
from
measure the
this
Earth's
is only
surface,
mathematical
but
expression.
uses light
And
and
once you
waves to
click on the
infer
image,
the Earth's
it will
surface.
generate the
So we measure by
indices,
proxy,
and also
and
it will
this is
generate the
why
training data from the
calibration
same
of
click.
sensors,
And after that,
which
you
almost
can
all
say here
satellites
region
go through
growing.
before missions
So
become
region
nominal,
growing,
and
it will collect the
validation of
samples in the
outputs are
surrounding. You
always
can
a
define the
necessity.
window. Suppose 20 by 20 means 40 by 40
Now,
from
when
the
we
center
think
pixel.
about Earth
20
observation,
this side,
we
20 that
automatically think
side,
of
20
space.
up and 20 bottom. So
But
you get
remote
a
sensing
40 by 40
technologies that
window. In
observe
that
the
40
Earth's
by 50,
surface can be
in
utilized
that
on a
40 by 40
variety of
window, it will
platforms.
find out the
In
similar
fact, the
pixels
earliest
using
form of
some
Earth
mathematical
observation is
algorithms
aerial
like
photography,
Persian correlation
captured from
coefficient
planes,
or cosine
or
correlation and
aerial
so forth. You
platforms.
can select all these things. You
So
can say
sensors
on.
can also be put on
Region
drones
growing
to
is
collect
on, and
imagery,
the moment
and
you
these
click, it will
technologies are
generate
rapidly
the
evolving.
indices as per the formula you have
So when
selected.
making
You don't
decisions
have to
about
define the
whether to
bands,
use a satellite
and
or a
it will
drone,
also select the training
the most
data for you.
important thing to
And after
remember
that,
is
you
that
just take the
satellites can
classifier, the
cover a lot
large
more
number of
ground,
classifiers which are
albeit at
capable to
coarser
map
detail,
only
while
one
drones can capture
class.
high levels of
And in the
detail,
within
but it would
PCM, you
take
can
you a
have
very long
different
time to
distances.
cover the same
Within
area that
MPCM, you can have
satellites
different
can.
distances and so forth. So
So there are
we
also other
have made
regulations with
this versatile.
aerial
So
and
with
drone
different
flights
angles, we can
to,
test the
which
performance
don't
of
really
the
impact
algorithm.
satellites. So
I
those
hope you
platforms
got the
could be
flavor.
more expensive in the
Temporal, I'm
long
not
run,
showing you full
depending
because I
on what you're
require actual
measuring.
temporal images. Then I have to
For
relocate in my
example, if
PC
you
where they
wanted
are
to count
kept.
birds,
I do
then
forget
satellites
sometimes,
probably
but I've
won't really
just given
help
you
you that
flavor.
much.
For single date,
So it
I've
does
just shown you
depend on
to extract water.
circumstance and
Same way you can
context.
map wheat
But
field
more
and so
about
forth.
that from
But
Paula
a
later.
temporal, if you are going for level 2 and level 3
So if we
classification, you
just
can do
take
it. It works.
a closer look at
And I can
satellites,
show you one more thing,
there are currently
what I've
thousands
explored
of them
about
out there, but
heterogeneity.
only about
Just give me one
800
more minute. I have plenty of
satellites are
time, brother.
dedicated
I've just
to
taken
Earth observation.
finished a little early, so I'll
This
just
number is
show you
rapidly
have that.
changing, and I have to update it every now and
Maybe
again.
I'm not sure
So
it is
these
kept here or
also
not.
cover
Just let me
meteorology,
relocate.
which tend to operate in the geostationary orbits, so following the rotation of the Earth, keeping a fixed eye
Okay,
on the
yeah.
same area, while most of the other satellites that we're familiar with operate in low Earth orbit, so similar to the simulation on the slide. So it takes a while to get full coverage of the Earth. So moving on to the considerations that would be important to be aware of and to know when it comes to understanding the data. There are 4 resolutions that we should bear in mind, and that hopefully understanding these will make you move forward leaps and bounds to understand the data. From now on, I'm
So
mostly
here,
talking about
I'll just show you how we are
optical or
dealing the
passive
heterogeneity
sensors, but I
also
will let you
in the
know
same tool. I'll just open it.
when these refer to passive
So
sensors
here,
as well.
the tool comes.
So the first resolution is
Now here
spatial,
again, you can open the
and
image.
this refers to a sensor's ability to identify the smallest size detail of a pattern in an image.
So here you have
So
already the
what we
signature
really
file, but
mean
if
when we
you
mean
open this
spatial, when we
window,
talk about spatial resolution,
so this
is
window
pixel
will
size.
take the mean parameter.
Now
but
both
here, if you
passive and
apply
active
this window
sensors
and
have
if you choose
pixels,
these
but
4
I'll explain in a
classifiers,
second.
they
what we
will
mean
not
by
use
pixels.
mean, they will use the sample as it
The
is.
second resolution
And
is
this way you can tackle
spectral,
the
and this
heterogeneity
refers to the
within
sensitivity of the
class.
sensor to respond
here, this
within
4,
a
PCM,
part of the
MPCM,
electromagnetic
MLC. In MLC, we have also tried
and this is
to
only
deal
relevant to
or to
optical
take each
sensors.
sample as it is in place of
The
generating
third
the
is
statistical
radiometric.
parameters. And
So
then
this is probably
noise
the
cascade.
resolution that you need to worry about the least, but it does refer to the ability
I
to
hope
measure signal
this gives
strength
you your
or
answer
brightness of
as a
objects.
live demonstration.
And again, this is relevant to all types of sensing.
Yeah.
And
Please,
last but definitely not least
another question
is
is
temporal
this.
resolution,
Software is good
and this
for
refers to
such
the
kind of image
frequency at which a
classification.
sensor revisits an area.
please
And
repeat,
again,
madam, again.
this is relevant to
Which
all types of
software is
sensing.
good for such
So
kind
the
of
reason
image
why these
classification?
resolutions are important for you to know is that there's
Because
usually a
this
trade-off
one
between one
is my, you
or
can say, my
sometimes
own
all of
baby,
these.
my love.
For
From
example,
my
traditionally,
PhD,
if
I
you wanted a
started
sensor
in
from space that
2004.
covers all of
Long
the surface of
backstory,
the Earth
and
every
then
day,
I
then
finished
you
my
would have to
PhD. Then I
accept a
got so
much
many
lower
ideas which were
spatial
left
resolution
from my
of
PhD.
about 1 kilometer
Then
squared or
again,
lower.
further,
The
I
technology
mentioned that
is,
I'd love to
however,
work with students
improving
from
at
BTech
rapid
to
speeds,
PhD, all
and
range
you will
of
hear about a
students from
constellation that
BTech,
offers high
PGD,
temporal and spatial
MSc, MTech,
resolution from
and then
Mark Richardson at Planet later.
PhD scholars. And from there, it was
So what
developed
is a
as a
pixel?
team regularly, continuously, with as per idea
The
we get it.
simplest way to explain is that
But
it's the smallest
similar type
element
of
of an
things you
image,
can do through
and they are
NV
usually
up to
square in
limited.
shape.
Like at
They
least you can get
record
the
a
fraction
mean
images through
value
NV
of the
with any
measurement
of
of
the
the pixel.
classifier. Because
So
NV
if
is
your
a
pixel size is
commercial
10
tool,
meters squared,
scientifically
then
developed
you'll get
commercial
one
tool.
value for that whole area in your image.
And it has large number of
Pixels
classifiers
are not
compared to
linked to any
other
real-world objects on the ground, so they
tools like
have no
ADAS.
relationship with anything
ADAS
that we
is
see
purely
in
commercial
an
tool,
image.
so you don't see much
For
advanced
optical data,
algorithms,
the pixel
but in NV you
size
can
is
see very
determined
dedicated
by
advanced
the field of
algorithms, but
view,
not
which is
what
the
we have
diagram you can
talked.
see here.
Fuzzy we don't see
Which
in any
means
of
the
the
angle
commercial
at
tool.
which the imaging optics
Right?
is
But
looking
still,
down at
with
the
other
Earth's
classifiers,
surface.
you can generate
So
the
if you
fraction
have
images.
optics with a low angle looking straight down, then your pixel size is going to be small.
But
If your
here
optics
I can say
as a much wider angle,
it is not a
then your
commercial
pixel
car. It
sizes
is
are going to be
designed by
bigger.
ourselves. So we know
You will
what
notice
we
that I've
want. We
labeled
want
optical
4-door
only in a
car
couple
or
of these
1-door car or
factors.
5-door car
Now,
with
radar data,
cars
like
to
I
run with
mentioned,
on 4
does have
wheel or 3
pixels,
wheels. So
but they're
that is
not
our
determined by field of view.
idea,
So
and
there's a slightly different
for a
way to
specific
get to
purpose. So
pixels.
that way we have
And
designed.
this means that they're
But in commercial
also
tool,
not
you don't have
always
that freedom.
square in
So whatever
shape
they have
and tend
developed,
to
you
be
have to use
more
them as it is. So best one I can tell you
rectangles or
the
oblique in
NV
shape.
tool.
So now we're going to take a quick look at
Next
what it
question, sir. Could we
means,
use
what the different
object-based
spatial resolution
classification
means
for
and what they look
classifying
like.
sentinel data from
First of
landslide
all, I'll explain the
identification
scale
at
we
micro
use when
scale?
referring to spatial resolution.
For
So the
Sentinel,
scale
because it
is
is 10 meter, you
low,
have to see
medium,
the
high,
information
very high,
content available on the
and
image.
this
If you
refers to the
see
number of
up to say
pixels it
30
takes
meter
to
images,
generate an image.
they have
So an image with
only color
1
information.
kilometer
If you
square
come down up to
pixels
10 meter,
has a much
images
lower
are
number
more
of
strong with
pixels than
the
an image
texture.
with 10
And if
meter
you
square
come down
pixels.
below 10 meter, so
The
they are
numbers
more
you're seeing
strong with
here are
respect to
common
shape.
pixel
At
sizes
10 meter, you can see
in
they
sensors that
are
currently
still
exist. But the
strong
images you're
for color
seeing
as well as
refer to
texture.
a small
But at
island
10
in
meter
the
for
Turkey
landslide, if
Caicos
you use
Islands in the
temporal
Caribbean, which
information,
is
because
only about
landslide we have
100
already
meters
experimented in
wide.
as one of the
So I'm
PhD
showing you
scholar,
a
and he got good
Landsat 8
publications in
image, a Sentinel-2
2010
image,
to
and a
13
Pleiades
he
image.
worked for
And
landslides,
how
also for
they've captured
Balakot.
this island in
And
their
that
own
is our own
respective spatial
experience at 10
resolutions.
meter, because that time
For
we worked with
Landsat, you can only
the
just
list
make
3,
out
which
that
was
it's an
at
island,
23 meter,
and you
and
would
we
be
got the
able to
results.
guess
And if
that
you
there was
come to
some
10 meter, you can
vegetation
really
in
get
it
much
and
better
some
results.
sand.
You can take
It's a bit
pre-landslide
better
and
for Sentinel-2,
post-landslide
and you would probably be able
images.
to
And
track
if you take both
any
the
changes
informations
to the
as a temporal
coastline
image, you can
or
definitely get
if
much
the
better results
extent of the
from
sand or
landslide, from
vegetation
Landsat
areas
2
have
images.
changed.
In
While the
place,
Pleiades
there is no need to
image,
use
you
object
can
based,
pick
because
out all of
object
the
based means the
individual
shape is
scrub
more
bushes
dominating. In the landslide
in the
area,
sand
the shape
area.
is not so much dominating.
Now,
It is very
understanding your
irregular,
application is pretty
natural
important
shapes,
when
patterns,
accepting that a particular
which can be
resolution
done by
is
the
good
pixel
enough
based
to do the
classifiers.
job,
But of course,
because
you
there
have
are
to
data
incorporate
access
the
costs
temporal information.
involved.
Otherwise, the
So
landslide, which is
if
exposed as a
you're
soil,
happy with
it is
Landsat or
exposed as
Sentinel
soil,
imagery,
it will give you same
both of
signature
these
with other
sensors provide data open and free at the point
ground
of
which is
use.
uncovered, which bare
As for
soil,
many of
will
the
be giving
other
same
lower
signature like
resolution
landslide. So you get
satellites, they tend to
confused.
have
So there
no
will be very high
data
spectral
access
overlap.
costs,
At least you have to use
whereas
2 date
the
image,
Pleiades
pre
image is
and
pretty
post
expensive
landslide
in
date, and then
comparison.
you can
You're always
map.
going to have to pay
Specifically
to
the
access this
landslide
level of
time, there is
spatial
rain, and
resolution
maybe there is
from
moisture
space. So
increases,
consider
so
carefully
you can
whether
incorporate
Sentinel or
the water
Landsat
band also,
or any of the other lower
NIR
spatial
band rather,
resolution
NIR sway
satellites
band.
could do the job first. So moving on to
And that way I think
spectral
you can get much better
resolution.
results.
This section only refers to optical data sets.
with our experience.
So images are made out of a series of what we call bands. The next slide will give you a visualization of what I mean by bands. But a single band, when displayed, is always black and white. In a GIS,
I
for
still
example,
goes
you
on
display one band.
experimenting because
But when you combine
when
more
I
of
am
these
surrounded
bands,
by
then you can
students,
generate
I
images
never feel that I'm
represent what we might,
aged
how
on.
we might see the
I
world with
feel
our own
still I'm
eyes.
young. So
So
I
we call
goes on
this red,
experimenting
green,
with
blue
the
image, or a true
students,
color image. So these
developing,
bands
experimenting,
represent
application testing, and
one
then
part of the
publishing.
blue, one part of the green, and
So it
one
is
part
not
of the
open
red
source.
parts of the visible
This my
part of
love,
the
and
spectrum,
I still
respectively.
feel there
And
are a
only
lot
when
of
you
scope,
combine them do we
a lot of
visualize
things I can
images
do.
in true color. Thankfully, our
We
own
have
eyes
given
do this for
its
us, so we
detail
don't have to worry
in
about
our
that.
first book that
So
is
the
already
spectral
published last year
resolution
on 20th of
refers
July,
to how
called Fuzzy
many of
Machine
these
Learning
bands
for
are
remote
present in
sensing
one
and data
image.
classification under
And it
CRC+.
also refers to how narrow
And
they
the
are.
second book
So
is
by
under
narrow, I mean what
progress.
is the
We are at the midway. We have already
breadth of the
compiled the chapters.
electromagnetic
Final
spectrum that they cover
editing
in
of the
one
chapters is
band.
going on. I
So
hope
most
in
optical
the coming 6
images
months
are
we can launch the second
multispectral
one.
and will include
That is
a
also
small number of
addiction
bands. That's a
of writing
relatively
books. I
broad
was not so
frequency.
much used to of
And
writing, but
hyperspectral imagery is
with
what we would
time and
call
with
images
learning
that
and seeing
have
others,
a very large
it
number
has
of
made
bands at a very, very small frequency.
good initiative
These
to write
hyperspectral
also,
sensors
initially
are
in
less
initially
common,
in conference papers, then
with only one
journal
true
papers, and then
hyperspectral satellite
nowadays
currently
books.
still
The
in
second one
operation
is
in
coming up on deep
space,
learning
but
with an
unfortunately Hyperion is
application as
nearing the end of
classification,
its mission
detection,
life and
and
is not operating at nominal.
within application of
But
detection
the
for
future
classification,
technologies
and
means that
also
more
image
hyperspectral sensors will
transformation.
become
And also we
available
have discussed about
in the
heterogeneity
very, very near
handling
future.
through fuzzy based classifiers
So to help
in
with the
this book, which
visualization
we
of
missed
bands,
in the
I've got the
previous book,
spectrum up
because that
again.
time we did not got
And
that
this is
idea.
what I
We did not
mean,
thought it is possible.
hopefully,
And
what I mean
we
by
got that idea.
hyperspectral versus
We have experimented,
multispectral.
and we are getting the good results.
So each
One
of the
PhD
bands
scholar
are
published the
represented
paper
by a
in JAR,
box here,
and second one
most of the
PhD. So one
multispectral
PhD
images, which
student of 3
is
months project
ASTER,
also.
Landsat 7
That
and
paper
8,
is
and
under
Sentinel
review,
2,
and 3-4
have
papers
one
are also
box
coming
each
up
for
in
red,
the
green, and
same
blue.
domain. So
And the wider
this
the
tool we have
box,
not
the
kept yet
broader the
open,
frequency.
because we are developing, we are modifying,
So
and we
the
are
bottom
using, and we are
line
testing its
represents
behavior of the
MODIS.
algorithms, and then we are publishing
While
the things.
MODIS isn't truly hyperspectral, hopefully it
My hunger has
demonstrates
not
that,
stopped.
because it has three bands in the
So
red
that's the
part of the
thing.
spectrum as
Yeah,
opposed
madam.
to one, that it has a
But
higher
yes,
spectral
anybody
resolution than all the other
wants to
sensors that you can see here.
work with
You
us,
will
and if they
also
have some
notice
idea, we
that bands
jointly
coincide with peaks
sit
in the
remotely,
atmospheric
because COVID has
transmission,
made us to sit
and
remotely, and
that
we can
is
do
not
it.
by
COVID
mistake.
has stamped today to remain
So
remote, isolated, and
these
work.
parts of
But
the
I'm
spectrum are
working
where
from
electromagnetic
2004
energy
onwards.
is
Around
transmitted.
15 years back
Without it, we
onwards,
wouldn't
I'm
get
working
reflectance
remotely.
measurement at
It is
all.
possible because everybody has
So
mobile
those of
phone,
you
and
who have
everybody
beady-eyed will
has
notice
laptop,
that there
and
are some
mobile
bands
phone is for
in
communication, and
those
laptop is for
areas where
processing.
there are
So if we can
zero
use these two
atmospheric
technology
transmission.
strength, we can
And these are
remotely
mostly put on
work
sensors
jointly.
to
It is
capture
possible.
what is going
There
on
is
in the
common goal
atmosphere at a time an image is captured. And this
What
helps
is the
us
best
with
process for
understanding
cloud
the atmospheric
removing of
conditions so
satellite
that we
data
can
without losing
process the
data?
data to surface reflectors later on.
Loss,
I will talk a little
we
bit
have
about
not yet
reprocessing
estimated, but we have
later.
seen per paper. We have tried, yes,
The other thing you
few
might
months
have
back
noticed is
using
that the
deep
atmospheric
learning
transmission
GYAN
percentage is pretty low in the
approach
visible,
model
and
for
that
removing the
limits, and that
cloud in the
basically limits
temporal
the
domain.
amount of
We also
information that we can
struggle
capture in
that
that part.
if we are using
We can still
temporal
get some
images,
data,
specifically with the
but
burn padded fields, we
it's
found some
not
images
at
were
its
partially
maximum
cloud,
capacity.
not fully cloud. Fully
So
cloud
one
we
of
have
the
not
easiest way for
experimented,
me
and
to
I'm not
demonstrate
sure. I'm
why
not
we capture
possible that
images in these
fully
bands
clouds
is the
covered images
example
can be
of
removed,
remote
can be
sensing
cloud free,
of
but partial
vegetation.
cloud patches can be removed.
Now
We
we
have
know
tried
how
in the
light
temporal domain
interacts
using
with
GYAN, and
leaves,
we got
which is
good
what I'm
success.
showing you here.
And after that,
And we
using
know
that
that a
images for
large part of the
classification
terrestrial
in the
environment
temporal
is
domain,
covered by
we got the
vegetation.
good
And
results.
we
So there
also know
is
that it's
up
one
to
of our
certain limit,
critical life
it is
support
possible
systems
to
on the
remove the
planet.
partial
So
cloud,
it makes
and we
sense
can
for
make
us
these
to make
images
sensors that are
to
able to
use,
monitor
because from nothing,
vegetation.
if you just throw that
So
image,
the visible
you don't have
parts, both
anything
red
to
and
use.
blue, are mostly
But if you
absorbed
try
by
to pre-process,
chloroplasts close
then
to
you
the leaf
make at
surface,
least
where the
that
green
image to
part
extract
is
some level level of information.
of the visible is reflected. And this is why
But
we see fuzz
we are
green. So
experimenting
this is
for a
probably
few
quite
years
common knowledge
using
to
SAR in the
all of you.
temporal. So
you will
I hope
notice that the reflectance is
partially you
still
can use the
relatively
SAR
low
information
compared to the energy
as a
that hits the
backscatter
leaf
coefficient or
surface,
other parameters you
and
can
this
generate.
is related
We
to
have
the
yet used
atmospheric
only backscatter
transmission
coefficient.
that
We
I
are
mentioned on the
experimenting
last
now
slide.
with more parameters from the SAR.
Now, the
Can we
near-infrared
parallelly
plasma spectrum
incorporate
is
with the
completely
optical
ignored by
image,
the
and can we
chloroplasts and
map the
interacts with the
specific
middle
crop at
part of
different
the
level?
leaf, or
So
what's
we are
the
trying
new
to
mesophyll,
experiment this, and
which means we can
I hope
understand a
so.
little more
Since
about
I
cell
feel
structure
we can
with
get
data collected in the
much better
near-infrared.
results.
You will
Since
also
there is
notice that a
feeling,
lot
I
of the
think
energy
this
is
may be truth
reflected
also.
back.
So that way you can
And
do
that means we get a lot more
or
information
there are some
in the
other
near-infrared and beyond.
conventional cloud
So this is why
removing
Earth
algorithms. You can
observation
experiment
and
them and
seeing
see. But of
beyond the
course, because it
visible
is
is
basically
powerful,
cosmetic
as
approach,
it allows us
some
to see
distortion will be there.
things
You cannot
and
achieve
measure
the
things that we wouldn't be able
new
to with
image
our own
without
eyes.
distortion, right?
So to allow us to
Yeah, madam.
differentiate between different types of vegetation and indeed land covers within the
Hello?
images, we use what we know about reflectance characteristics of those
Hello,
land
madam.
covers and
Sir, there is a one
create
question,
curves
how to
like
get
this,
satellite
which are called
images?
spectral signatures.
Satellite images you can download.
So these are the
Mainly, there are
different
so many
land cover,
sensors.
the most
I can tell
basic
you three
of the
broad
land cover
sensors
types.
are available.
For
You can download
vegetation,
the
you will
data.
see
One
the
is from
curve.
Landsat. So
Now
for
the
Landsat,
shape
you can download.
for
You can
all types
explore
of vegetation
USGS
is likely
site,
to be the
and there
same.
you log in, and you can
There'll
download
be
the
probably
Landsat
slight
images, and
difference
from
in
others
value
ancillary image
depending on the
data
type
also,
of
maybe DM if it is
vegetation.
available.
For
But
example,
Landsat
conifer
images you can
trees
download.
will have much
Second is
lower
from Copernicus
near
site, you can
infrared
download
than broadleaf trees,
Sentinel-1 and
but
2
there'll only be
images.
slight differences. The shape of the
If
curves for
some images are
vegetation is
offline,
always
after a
going to be the
few
same, well, for
months, they
healthy
keep the images
vegetation at
offline. You can
least.
put a request in the cart,
So this
and these
allows us to
images will be
explore
online after
vegetation
within a week,
health.
and then you can
So any
download. And the
deviations from
third
this expected
sensor image is
curve would
hyperspectral, that is
indicate a
Prisma,
change,
which
and
is
that
now
something
free.
is going
But it
on
is not
with
continuous.
the
It is
vegetation in that
patchy.
area.
Somewhere it is available, and some area it is not
So
available.
similarly,
But
you
if you
will
feel of your
notice
area it
that
is available, you can
water does
download.
have
And if you
a
want to just
spectral
experiment of
signature,
any area, you
and
can
that beyond
experiment.
near
So there are three
infrared,
sensors data you can
all
download:
light
Landsat,
is
Sentinel,
attenuated or
1
absorbed.
for
So
SAR,
we
and
should
2 for
expect
optical, and
nothing
Prisma
in
hyperspectral
reflectance.
satellite-based image.
But so this massively decreases the
So
chances of what we
another
could
question,
do on
what
the
are the
water
best
surface and
methods
below.
to enhance the features in
And a quick
images?
mention on how imagery does
Enhancement,
work underwater.
you can have
So light is
linear and
attenuated by
non-linear
water,
enhancement,
and
as well
the
as filter
intensity of
approach.
light decreases
So with that you can
exponentially
do
with
enhancement.
water
So these are
depth.
three type of
Now you will
well-established
have
techniques you
just
can
seen
explore
from the
it.
spectral signatures that water
Basically
does absorb
enhancement, and then you can
everything
go for
beyond the
image
visible.
fusion also.
So
If
you
you
should
have
expect
panchromatic
no
image, that way
reflectance
you
in the
can
near infrared and
pan
beyond.
sharpen, or you can
But
enhance
you will
the
get some
image with
reflectance in
respect
the
to
shorter
spatial and spectral.
wavelengths. So in the blue part
But
or
the
the green
enhancement
part of
is
the
used
visible.
only
So
for
those are the
visual
two bands
interpretation.
from
You
multispectral
can't
imagery that
improve
you
for
have the best
classification. But
chance of
yes,
working with
if you
in
are
these
incorporating
environments.
panchromatic image, that way your
You will see
classification
that the blue
result will
bar
improve.
does extend beyond 20 meters depth. Ooh. But this is the best case scenario.
Yeah.
And there are other
Questions are
things that
over.
impact what we can sense.
Yes, sir.
So in
Otherwise, they're
reality,
asking questions.
we probably could confidently
Sir,
say
one
that we
more
could
For
use
Prisma, I
this
have not
sort of remote
downloaded. You can
sensing up to
explore
10 meters,
from internet
15
because I
meters at
don't
best, but
remember.
the
Frankly
accuracy
speaking,
significantly decreases
one of
after
my
that.
PhD scholars trying to
So
download,
one of
but I
these
have not
causes is water
downloaded myself.
turbidity, which causes
A
light
few
to
months back, only
scatter,
the Prisma image
and that
was
unfortunately
freely
increases the
available. You
chance
can
of light
explore from
absorption.
internet
So very
how to
turbid
download
water
Prisma
would
image, and I think you will get the
significantly
link.
decrease the
If you
depths
want,
that
I
we
can
can sense.
explore. Number of
But
times
conditions
I
at the
just
surface play
explore
a
from
massive
internet
role as
nowadays. I
well.
don't go to
So
library also,
sun glint
because everything
happens when
you can
sunlight is
explore from
reflected
internet
off the surface of the
today.
water at the same
Sitting on same
angle
table,
as
you
the
can do
satellite
everything.
sensor views it.
That
So
is the
it
beauty of this
results in
today's
a
technology.
mirror-like specular reflection, and that decreases the depths that we
Madam.
can sense underwater.
Questions are
And
completed,
waves,
sir.
Yes, madam. Thank you.
if there's a lot of them, that
Sir,
creates a rough surface, and that
a very good
increases
morning,
the
Anil
spectrum
sir.
of light.
Ji.
And
Myself,
that
Dr. Ravi
also
sir.
decreases the
Ji, sir.
depths
Morning,
that we
sir.
can sense.
Good
So
morning, sir. How are you,
opportunities
sir?
for
I am
underwater
fine,
Earth
sir.
Thank you,
observation
sir. Thank you
are
so much.
highly
First, I would like
dependent
to
on
thank you,
water
sir, because
conditions as well as
last time also in the
wavelengths.
month of, I think, March
So
also,
you
you
would
were
need a bit
accepting
of
our
luck
request.
and
And
probably a
again, you
high
came
temporal
forward to take this
resolution
session,
to
sir.
increase your chances of
From our
getting useful data
institution,
to work
I would like
in
to
this
thank you so
environment.
much.
And again, this refers to
You are showing concern on our
data
institution,
only.
sir. Thank you, sir.
Thank you to you, sir,
A quick
for
slide
considering
on
me in this updating
radiometric
program to deliver
resolution.
one talk.
But
and
I would
thank
assume
you
that this
to your
is the
management,
resolution
to
you
your
need to worry
University
least
of
about
Vijayawada
with your
for
questions, like I
considering
mentioned
giving the
earlier.
approval
But
for
it
you
is
to
good to be
consider me in this
aware of
FTP
what
program. So
values
thank
you're
you all.
including when opening an image for the first time.
It's my pleasure,
So
sir.
when
Please, sir.
referring to
Always
redirecting
very
resolution,
And
what
it
I
is
really mean
always
is
from
bit
my
depth.
side
So a
recognition and
2-bit
thank you
image will only give you
for
4
giving
values,
opportunity
1, 2, 3, and
considering
4,
my some
while
knowledge sharing it to all
an
your
8-bit
participants. Thank you all
image
again.
will give you
Thank you, sir.
values
No
between
problem.
0 and
Sir,
256.
I am following your session
So
from
all the
starting
sensors,
onwards.
such as the
Yeah.
Landsat
You are explaining fuzzy
earlier missions,
classification and
uses
traditional
8-bit data,
classification,
as
spatial
does
resolution,
aerial photography.
and
Aerial photography
separation
tends to be
between
8-bit
those
data,
techniques. How
and a
will
lot
be
of
utilized in
sensors that
a
we put in
practical
drones
way,
as well.
like separation between
But
plant
the
and
largest bit depth that
ratoon,
you'll come across
sugar
today
cane,
is
Yeah.
from Sentinel-2,
like
and that
rice
gives you
fields, how to
values
identify
from
by
0
using
to
kernel-based fuzzy classification,
65,545.
and
So if we're
practically
trying to
how
distinguish
we
between
can
two pixels that look very, very similar in color,
identify the
but may
objects
have
like
a different condition,
ISBT,
for example,
Dehradun,
semi-improved
and how
raster
to
Yeah.
find the
to a
pre and
space-rich
post
meadow,
earthquake
they'll probably
effects,
look the same from above,
like
but they're
boozy
completely different
earthquakes.
habitats on the
Like that,
ground.
I am following
Then
from
you
the
have a better chance of
Yeah,
integrating
exactly.
them
You have
with the
noted down
imagery
all my
with a
applications
big,
where I have
large
worked. I'm
bit
thankful
depth,
for it.
because
And that
it
you have
gives you a bigger
focused
range to
every
choose from.
second delivery of my
Unfortunately, there is
lecture
a
with
small
an
limitation
different
with
application. I'm
larger
really
bit
thankful
depth,
from my bottom
and
of
that
my
is
heart,
that
but it is
it's
possible
twice
because
the
I'm
volume
doing
of
it. I'm not
data.
sharing the
So you
bookish
have to
knowledge.
consider
These are
storage
all my
volumes and costs.
experience, all the,
Just to
and
give
these
you
all
a feel
works we
of
have
the bit
published. If
depths
you
of the
search
most
on the
popular
internet,
optical
you will get the
sensors out
papers
there at
what
the
we have published, and
moment.
you can go through. And if you
So
have some doubts, I
Sentinel-2
can
is the
clarify. I
largest, of
cannot do
course,
it in
but
single
a lot of them
second,
operate on the
but it's
11
a
to
long
12
thing we have
bit
developed. But
ratio.
we have all here, we have maximum in applications we have
So
done
moving on to the
for
fourth resolution,
temporal
which
image.
is
I can tell you
temporal.
one MTech
So
student
why is
currently, one
temporal
girl
resolution really
from
important to
Hyderabad. Her
consider?
father is in
There's lots
ICR
of reasons, but
Hyderabad,
for
and she's
optical
now taken
data,
up
the issue here is cloud,
tur dal,
because these sensors
yellow
can't see
dal
through them.
or another dal in
So
the
while a mission may have
Bhupapalli, some
frequently
district is there in
visits over
AP,
a certain
Bhupapalli,
area of the
something like
world,
that. So in that
it may
complete district, she's
make
trying to
little
map that
difference to
yellow
those
dal.
parts of the world that are perpetually
And she
covered
will
in
go for
cloud.
third level. That
So
can she map
this is where the
the
missions that require
sowing
daily
periods,
data have a
different sowing
significant
periods or
advantage,
harvesting
because
periods,
it
because it is
massively
a
increases the
kharif crop
chances of
grown
getting
with the
data
paddy,
at the
and it goes up to
surface.
January, Feb harvesting,
The
from
example
June
you're
to
seeing here is
February
from the
harvesting. That
MODIS
is conventional
sensor
growing,
on the
and
Aqua
she's
satellite,
trying to
so
map the
1
harvesting
kilometer square
stages. What in
pixels,
different time
and it
can we
captures
map the
data
different
over the globe
fields which
every
has been
day.
harvested for
You can
yellow
see
dal
that
in
the daily
Bhupapalli? I think
data
that
is
in
covered in
AP there is one
gaps
district
because of
called
cloud, but if you merge more days
Bhupapalli.
together,
Yeah,
then
yeah.
eventually
J
you will get
Bhupapalli.
a complete
Yeah.
picture without any
So
gaps.
now she has started,
Unfortunately,
and she has
temporal
taken
merging
intentionally.
means that
She
you
is
do
not in my department in
lose the
IRS.
most
She's in
accurate
other department of
information.
IRS, but
So again, there's
forcefully
a
she has
trade-off
fighted
for
for it
doing
to
this.
work with me and to work on
But
this topic.
generally, the
So I'm
trade-off is
thankful
always
for
with
her
temporal
also.
resolution.
And her
So
father is
high
in
temporal
ICR as a
resolution
senior
is
scientist. So they have provided the
something that doesn't
ground truth
traditionally go with
samples
high
of
spatial
these crop.
resolution.
And parallelly she has
The
other
Landsat
crops like
missions,
paddy, chili, and
30
other
meter
things. So we
pixels
can
cover the
separate the
globe
other
every
crops, and
16
we
days
will
at the
try to map
equator,
with the
while
harvesting stages of
Sentinel-2 is
this yellow
probably
dal or other dal
the
or
best
tur
you're going to
dal.
get out
And
there at
she will also
10
try,
meter
because
spectral
this
resolution,
tur dal is
spatial
grown in the
resolution, because it
rainy
covers the
season,
globe
because sowing
every
period is
5
coming from the
days at
rainy
the
season
equator.
from
Now, I say the
August to October.
equator,
She's not
but
getting the
as I
optical
mentioned
data,
earlier,
so she
these
will try to
satellites
add the
operate
SAR images
in
also. Then she will
lower
experiment
orbit,
how much
so it takes a while to
Sentinel-1
cover all
SAR
the
image is
globe, but
helpful
the frequency is
to
much higher
complete the
on the
phenology
poles.
of the tur dal.
So 5 days at the
Excellent, sir.
equator probably equals 2 to 3 days, every 2 to
So
3
you can
days
see I
in the
involve
higher
the family
latitudes,
members
or
in
the
the
latitudes
project.
that we currently are in the
See,
UK.
by God gift, her father was
When
a
it comes to
senior
temporal
scientist, so
frequency, the
I requested
commercial
this way you can
sector, so the
encash
very
the
high
opportunity
spatial
which you have.
resolution, tends to work slightly differently.
Excellent, sir.
And
I can tell
they
you,
like to,
there were
or they
two
Family members
girls.
also they
reposition
are
the
doing
Just one
satellites
very
more
best.
thing
to
I can
point
tell
it at
you
different
in
parts
few
of the Earth at
seconds.
different
There were
times.
long back
So
one
their
MTech student was
temporal
working working with me,
resolution
and
or
one MSc student was
availability
working with
is
me.
dependent
MSc
on
student
their
was from
availability and task
Tiruvananthapuram.
list.
Her father was in
The
again
exception,
ICR.
once again,
Her
here
father
is
became
Planet, which you will hear
guide
about
of
later.
second girl.
So
it was
radar
not pre-planned,
data,
but it's just coincidence.
this does
And I was
apply
looking
to
the
radar
opportunity to
data.
encash when
Clouds are less
he
of an
met me,
issue for radar,
asking that
obviously,
please guide
but you
my
still
daughter
have to
properly.
consider the
Don't worry, but I
frequency.
came to
So,
know
for
she's senior
example,
scientist in
the
ICR.
temporal
Then I
resolution
requested
for
him, can you
Sentinel-1 is
help me
global
to
coverage
get
every 6
the
days
ground
at
truth
the
data
equator.
of Kasawa crop in Tamil Nadu in Salem district
Now,
in
I've
Tamil
not
Nadu
really
is well
talked
known for
much
cassava
about
crop,
active
and
sensors,
that second
but
girl
I've
has taken
got a
second
couple of
objective for
slides to give
cassava
you a
crop
flavour
mapping,
of what is
and they have
possible.
assisted us
Without
to
going
provide the
into too
ground
much
truth of
detail
cassava
on
crop.
how they
So
work,
the second girl
as
father
we
became
don't have enough time to cover
co-guide of
that.
first girl in the MTech project.
We do
So that
have
way,
the training
everything
sessions
is
on radar
opportunity
that
in
are
this
happening
world. I can
later
tell you,
on in the
whatever
year.
comes to
So if
you,
you are
don't say
interested in
that my
learning more,
boss has
then
given this dirty work,
please
and please take that
register
work
for
as a
those.
prasad and try to
Now,
do. You will definitely
unfortunately,
get
the
something
active
from
sensors
that.
are
But if you
always
start
more complex,
crushing to your
produce
boss
data that
and
can be
to your
morphed into
surroundings, what
several
this
different types
dirty job
of
has given to me, they have taken
data
a good
types.
job by them and
So
dirty job given to
not as
us,
straightforward
then
as
you will
optical
always
data
remain
sets.
negative. So always
So I'd
remain in
always
positive domain.
recommend you get
You
an
will
expert
really
on
see
board
the
to help
growth in your
you
life.
deal with
That is
this
my
data
own
types
experience last
regardless.
15 years, I can tell you.
So
Excellent, sir.
here I'm
As a
just
guru,
showing
you are
you the
doing
different
excellent.
frequencies that radar data,
Excellent, sir.
or to be
Excellent.
more precise,
I'd like to
amateur
thank, first I
radar
would like to thank you.
operates, and the sort of
I want
things
to
that
wish
these
you a happy
frequencies
English Day.
interact with on the ground.
Yeah, thank you, sir.
As you will remember from
Thank
my
you, sir.
slide on the spectrum,
Thank you once
these
again.
sensors
You
operate
are
in the
elaborated
microwave and radio wave
very
section.
nicely
We've got
regarding the
missions that
fuzzy logic
operate in the
system.
X,
Excellent, sir.
C, S,
I
L,
hope
and
this
P bands.
cooperation
So
I am
these bands
expecting
are
in
very,
next
very
also.
similar to the bands I showed you
I hope all
earlier,
the
and
participants
with a
enjoyed a
slightly lower
lot
resolution
from
for
this
optical.
session. We are receiving
Now,
the
the
very,
wavelength is the
in the
critical
chat box, we are
factor here,
receiving
and it
the feedback
determines
from
what the
the
radar signal
participants. Are
interacts
very
with on
nice
the
session.
ground.
It's a very informative
So
session.
X-band
It's
radar
excellent,
has
sir.
very little
As a
capacity
today
to
Engineers
penetrate
Day,
into
I
broadleaf
really,
forest,
I
as it
met
operates at a
really a
wavelength
good
of about 3
engineer. You are
centimeters.
giving number of
So the data
solutions to
from
the
these
society
sensors will
also.
give you
Once
information
again,
on
thank
the
you so much,
structure of
sir.
the leaves,
Thanks a lot.
on the top of
Yes,
tree
sir. Thank
canopies,
you.
for example, but nothing beyond that.
Thank you all.
C-band
Thank you,
can
sir.
penetrate a little bit
Madam, please
further
go
and
ahead.
will interact with the branches of the trees, while
Thank you, sir.
L-band
Thank you so much.
interacts with the
As
trunks
sir
of the
said,
trees.
we met
The
really
most
a
common
good
form of
engineer
radar data output
and
is
who
what we call a backscatter product,
completely
and this is the
show
image
a
that's in the
path.
background.
So how to do our further works,
So
further
the image
research,
in the
and
background is
what are
actually
the
from
ways
Sentinel-1, which
you
is
showed a
C-band radar,
lot many ways
and
how we
C-band
can
radar tends
proceed
to
and
be
what are the ways
most
in
commonly
which
known
way
as
we
the
can proceed
workhorse
and
of the radar
what are the
sensors.
tools we can use and
Now,
everything. So
backscatter
really a
refers to
wonderful
surface
session was, sir.
roughness.
Thank you so much,
So
sir.
a high value in
Thank you,
backscatter
madam.
is
And
related
I'm leaving
to a
this
rough surface,
meet.
so
Thank you all
Okay,
trees,
for
sir.
giving this
mature
opportunity
crop,
again.
Okay, sir.
and will
you,
give
sir.
you a high value, which in a black and white image come out as really, really bright, whereas a low backscatter value refers to smooth surfaces, so water bodies tend to have smooth surfaces, and these will come out as black in images. Paula will show you more of these images later and talk you through how
Madam,
to
what about
interpret
the
what
next
you're
slide?
seeing.
Next session
And
is
it's not
from
The next
quite
session
as
will start at
straightforward as
11:15,
interpreting
sir.
optical data, because
Okay.
optical data is more like
We
looking
request
at
to all the
photographs.
participants, please
It is also
follow
worth
the schedule,
mentioning at this point that
because we cannot
Sentinel-1 is currently the only radar satellite
we
mission
cannot
out
remind
there
you
with
each and
open
every
data.
time
So
in the
other
chat box.
missions such as Tandem
Please try to
X,
understand.
which
We
is
should
X-band
you should
radar,
maintain as per
or
the
ALOS
guidelines given by
Pulsar, which is L-band
Airtel
radar, are
Academy.
not free at the
We
point
should
of use.
maintain the
So
attendance
data
as well
access
as
costs
we should
apply.
this thing as an engineers day. We need
The
to
other
think out
most
that we
common
are the
type
faculty
of
members.
active sensing
We
is
need to give the
LiDAR,
number
which
of
stands
solutions to
for
the
light
students.
detection and
What the things are
rating.
required in the society.
These sensors work by sending
So
out millions
once
of light
again,
pulses or
I wish
lasers
you a happy
and
English
then
Day to
record
all of
reports
you.
back.
And I request you, please
You
follow the
do
timings.
get what we
Thank
call
you
a
so
point
much.
cloud as a first output with LiDAR data, and it can give you information about the landscape in 3 dimensions. But the most common outputs or application from these data are mostly to generate digital elevation or terrain models or bathymetry. So these sensors are mostly operated from a plane. You can also put them on tripods. Terrestrial laser scanning is what we call that. Or you can put them on the bottoms of boats. The LiDAR missions haven't fared well in space, but there are a couple operating. And the reason for this is that the power required to send the lasers out at the distance from low orbit is too much for the satellites. So that's why we don't really have many active LiDAR sensors in space. But ISAT is a LiDAR mission that's still operating, although it isn't nominal. And JEDI is the other one, which the JEDI sensor is currently on the International Space Station, and it's a purely research mission. And because it's on the International Space Station, it only covers up to Cardiff of the UK, unfortunately. So it does not give us complete coverage of the UK. Now, the one other major thing that I need to tell you before I finish, and that is the fact that not a lot of sensor data arrives onto your computer without some pre-processing required first. There are exceptions, of course, so some of the marine missions and lower spatial resolution satellite data do tend to produce analysis-ready data sets, but the higher spatial resolution sensors tend to not do this, basically because it's difficult. But saying that, methods are now well established. You would need to be an expert to carry out the pre-processing, unfortunately, so this was seen as a big barrier for picking up Earth observation data in all sectors. But in the UK, we do have a long history of producing analysis-ready data sets, starting with the Landsat archive for Wales, and Sentinel-1 and Sentinel-2 analysis-ready data is now routinely produced for all of the UK and being made available to all users free of charge. So for Sentinel-1, we produced the Pscmrcet project, like I mentioned earlier. But just to make you aware that other products are available, such as interferometry. So just to give you a quick introduction on how to access the Sentinel-1 and 2 data sets that we produce, I'm going to hand over to Paula for the next couple of slides.
Yes, hello everyone. Thank you. I'm just going to talk through a couple of new services that have been launched this year to give us access to analysis-ready data. As Gwawa said, it's very
No issues, sir. It is always, we are always available for you and
Thank
for
you,
the
sir.
students we do have. So since we do have the knowledge, it is basically for the sharing to the others too.
Yes, sir. Yes, sir. Thank you, sir.
Thank you so much.
Once again, a happy English Day, sir.
Same
Thank you,
to all. Happy Engineering
Yes, sir.
Day.
Today is special day.
Right, right.
Most of the
Very
participants are faculty members, sir.
Okay, that's
And
very
some
good.
of the technicians are also there, sir.
Oh, that's very good.
Those are belongs to civil department.
Uh-huh.
I think 4 technicians are there.
Okay, that's good.
Technicians are also came forward to learn the new things.
Okay.
The
That's very
PG
good.
scholars
Really,
are
it's
also
very
there.
nice. Remote sensing is one of the technology which is growing very fast now in
Yes.
all the sectors.
Yes, sir. Yes, sir.
And out of the remote sensing, this hyperspectral is particularly now having a very good impact because all the extraterrestrial bodies like Chandrayaan, Moon, Venus, we do have the sensors which is actually giving us an idea about the water and its availability.
Yes, sir.
So that is also very good initiative. I think you have taken at a very right time.
Thank you, sir.
This type of courses is really very, very needed for the young faculties as well as the technicians, those who are in this field.
Yes, sir. Actually, in this field, we are in our department. The 4 faculty members are working on these hyperspectral and land use, land cover, and especially in GIS and remote sensing. 4 faculty members are working.
Oh, that's very good.
And also, we have our department is a nodal center for IARS, sir.
Okay, as you said, program.
Conduct various activities to the students also.
Yes, yes. I'm
The
seeing
last year,
one of the
hopefully,
faculty
we
who have
conducted
interacted with me, I think in the last session. One of your faculty, I was just seeing that she has interacted me in any of this section that previously happened.
Yes, sir.
I'm unable to see you.
Yes, sir.
Madam, please.
Yes, sir. I have interacted with you, sir.
Yes, yes. Regarding the course, you
And
have
really,
interacted
it's
with me
my
earlier.
pleasure to see you, sir.
It's my pleasure too that we have materialized
and one
finally
more thing
what
I
you have
want-
invited me earlier.
Sir, and one more thing I want to convey, sir. After seeing your profile, I think you are Saraswati Putra, sir.
No, no.
So after seeing your profile, really, sir, we think like that only. So
No.
me and one of my we have seen, sir. So we think whatever journals and everything courses you have taught in outreach program and everything, sir. So really,
Definitely, we all are basically trying our best to give the students whatever we have learned in the last 30-40 years. So it is completely being a teacher, it is our responsibility to give our best. So we are giving our best to the students as well as to the country too at any time.
Yes,
and you finally, I think I can remember that last 3-4 months back, we have started this journey when you were talking about the FTP, and now we are in the final stage of materializing this one. It is all your efforts too at that time, which was materialized actually finally now. And out of your work, definitely I'm seeing that 80 or 100 people are going to get the benefit of this FTP, definitely.
Thank you, sir.
Madam, please, you go ahead, madam.
Welcome back to all the participants for DAY3 session 2. Good morning, sir.
Yes.
It's my pleasure to introduce Dr. Himanshu Goel, sir. Dr. Himanshu Goel is currently working as assistant professor in the Department of Applied Geology, NIT Raipur. He received PhD, PGDG from ITC, Netherlands and IIRS Dehradun. He served as guest editor advances in Space Research Journal elsewhere, advances in spaceborne SAR remote sensing for characterization of natural and man-made features 20 to 21. Dr. Himanshu Goel, sir, and Dr. Pscmrcet and Geospatial Information Science Journal, Advancement in Geospatial Science in Earth Science 20 to 21. He has published 5 book chapters, 1 book titled Hyperspectral Remote Sensing Application for Mineral Exploration in Human Himalaya, India in 2015. He has published 44 papers in reputed international journals, 11 national journals, and 22 international conferences publications. Sir is a life member of Indian Society of Remote Sensing, India International Geospatial Society, USA, IEEE Alumni, International Institute of Geo-Information Science and Earth Observation, ITC, Netherlands, and Indian Institute of Remote Sensing, ISRO. He organized 2 sponsored workshops. He served as a course coordinator for 18 IIRS outreach programs. He invited as a guest lecturer and delivered lectures in various reputed colleges, acted as an co-chair in the conferences, organized national and international workshops, seminars, and conferences. And he awarded second prize for post presentation at Asia Pacific ESRI regional meet held in New Delhi 2007. Best second poster award on JS Day Indian Institute of Remote Sensing Dehradun in 2008, and second best poster presentation at 10th National ESRI user meet held at Delhi in 2008 to 2009. First best poster presentation at 11th National ESRI user meet held at Delhi in 2010. He is a reviewer member of 22 reputed journals like Elsevier, Springer, Taylor, and Francis Willett. Dr. Himanshu Goel has supervised 1 PhD, and for your ongoing, he is currently handling 3 sponsored projects and 1 consultancy project. This is the brief biodata of this session. Resource person Himanshu sir. Now request Himanshu sir to hand over the session.
Thank you very much, madam, for your elaborated view. I'm really very glad to see that you have gone through the profile and you are sharing everything with the students with a very hard working. Today, I'm sorry, I've done something wrong. Just a minute. Is my screen is visible?
Yes, sir.
Okay. Can we start now?
Yes, sir. You can start.
Thank you so much. Thank you so much for inviting me for this lecture. Myself, Dr. Himanshu Goel, working in the Department of Applied Geology and IIT Raipur. One of my specialization is basically the hyperspectral remote sensing and its applications. So since this batch of teachers is having the multiple dimensions, so we will be talking about something related to multiple dimensions, but more emphasis would be given to the geology or the remote sensing itself. But we will also touch the aspect of how this technology is basically helping to others department and what are the other applications we can do. Now we are starting with the hyperspectral remote sensing. The science of acquiring a digital imagery of earth materials in very narrow contiguous spectral bands. This is basically what hyperspectral is different from the multispectral. In the multispectral too, we are actually acquiring the digital imagery of the earth. But in the hyperspectral, it is name itself indicating there is hyper bands. Hyper means hundreds of bands are available, which is in a contiguous manner. Contiguous manner means we in the electromagnetic spectrum having the windows, or I should say in the spectrum, we do have different regions where we can do the imaging on the earth. In the hyperspectral, benefit of this is that it is not only talking about the acquiring the digital imagery of the earth's surface. At the same time, it is talking about the materials. It means we are now concerned with the chemical composition of the object. In the earlier stages, those who are working in the multispectral imageries, they usually talk about the materials in a very narrow situations. We are not able to identify the actual material of the object. But this is basically the beauty of the hyperspectral remote sensing is that we can talk about the chemical composition of those earth features which actually reflects energy in visible to shortwave infrared region. When my mean is visible to shortwave infrared region, it means we are talking about strictly with the 400 nanometer to 2500 nanometer, because this hyperspectral remote sensing, whatever the sensors we do have right now, is more or less falling in the visible, infrared and shortwave infrared portion of the electromagnetic spectrum. So the range is very big in terms of the material aspect. So whatever the earth material we do have, they in general reflects energy in the visible to shortwave infrared portion of the electromagnetic spectrum. Even when we are talking about the geology, those who are geologists or the materialists we do have, most of the materials or the minerals which is actual altered, weathered or clay, that can easily be identified by using the hyperspectral remote sensing. Am I audible, madam?
Yes, sir.
Okay, thank you. So it means itself what is it? We can identify the materials available on the Earth's surface, or in terms of geology, mineralogy, or the other aspect too. For instance, if we do have the building, the material of building is also reflected. When we do have the road, which is formed either by the tar or by the cementing material, it has a reflection. Anything which is being constructed using the material available on the Earth's surface in general have its reflection, whether it is forest, which is actually in a natural, water, vegetation, built up, whatever the class is. So it is basically the science which is taking us from one narrow region to the next level of understanding of the material understanding science, where the material is basically on the top. We will be touching it slowly, but before that, I would like to give a glimpse of this, what it is. Imaging spectroscopy for remote sensing involves the acquisition of the image data in many contiguous spectral bands with the ultimate goal of producing a laboratory quality reflectance spectra for each pixel in an image. When we are talking about the laboratory quality reflectance spectra, what it means is, it means that in the laboratory too, sorry, in the laboratory, we do have the instrument which is called as the spectroradiometer. That spectroradiometer actually gives us an idea about the reflectance value or the reflectance spectra of the object you are basically looking for. It means reflectance spectroscopy, which is available in the lab, is transformed to the satellite, and now the satellite is taking the pictures same way as the spectroradiometer, and the spectroradiometer gives us a continuous spectra of each object we are looking for. At the same time, if it is in the sensor, we are looking for the pixel, and under this pixel, whatever the material is, we are taking the spectra of that material. Now, those who are working in the computer science or material science, I would like to draw your attention here is that when we are talking about the pixel reflectance spectra, we are indirectly or directly talking about the mixture of the material available in that pixel. If the material, whatever it is, beneath the pixel is same in all the pixel areas, it will give you the proper reflectance spectra of one object. But if it is more than one object, maybe road and near to the road, whatever the soil cover or the geology is, then it will give you the reflectance spectra in terms of mixture. So that mixed spectra, which you will get through the spectroscopy from the space, can be segregated up to a certain level, and we can understand what are the materials are actually available under this pixel too. So there is a lot of scope for those people who are working for the spectral unmixing. Now, earlier we were talking about the spectral unmixing of the pixel when we are working about the multispectral. But now we are talking about the spectral unmixing of the spectra, reflectance spectra. When we are coming to the hyperspectral domain, it is one of the thrust areas that how we actually segregate the spectra of the mixed spectra which we are getting from the hyperspectral data. So that is very good research we are currently looking for because most of the mixture analysis we have done is restricted to the multispectral data. But for the hyperspectral data, we do have a very few people who is working on the reflectance unmixing, so pixel reflectance unmixing of the spectra. This is basically what the spectral profile. When we are talking about the spectral profile, this is basically the spectral profile within the range where your bands is actually falling. These are the bands. So whatever the range of your bands, range of your band means from where it is starting in the visible and where it is ending in the shortwave infrared region. So this way we are getting the reflectance, and at the same time we are getting the absorptions regions. So these absorptions regions are basically the chemical composition indication of the materials available in that area. So we can do it for any object available on the Earth's surface. Now, what is basic funda behind this sciences? This is basically electromagnetic waves. We do know that we do have the electromagnetic waves, but these electromagnetic waves is actually falling in the multiple regions, which is gamma, X-ray, ultraviolet, visible, infrared, shortwave infrared, thermal infrared, microwave, and radio. So we are actually falling under this area up to the shortwave infrared, though NASA is working with the hyperspectral sensor in the thermal region too. And I think 2022 is the date when they are going to launch a satellite for the hyperspectral thermal sensors. Currently, we do have the hyperspectral visible to shortwave infrared regions. So this region of the electromagnetic spectrum is basically used for the multispectral sensing, and at the same time, this region is also being used for the hyperspectral. We will talk about this later. Now, the same region, visible, and the region of 400 to 700 in the visible and shortwave. Now, coming to the benefit of this region. Most of the materials, which is either man-made or natural, most of the time it is reflecting in this region. This reflected infrared up to 3 meters is also the part where we can get, apart from that, metal content available on the Earth's surface. Now we are talking about other aspect too, where the metal content or the mining of the metals, which is actually in a open cast mines, we can also infer this situation by using the thermal infrared region too. The thermal infrared region is basically being used for the thermal property of the materials, but at the same time, when we are talking about the material identification in terms of the mining or geology or anything, thermal infrared region is one of the most important regions for identification of the metal content available on the Earth's surface. But this doesn't fit for the water. If any metal content in water, it is not possible to identify it directly, but we will get some indications about this too. Now, when we are actually covering the remote sensing aspect, the 4 things which we have to understand is the resolutions. Madam, somebody has taken the class of resolution?
No, sir.
Okay. So I'm touching this because this correlation of the hyperspectral is basically related to the resolution itself. These are the keys, I should say, to identify the whatever imagery you have. The quality, in terms of quality, comes with the 4 types of resolutions. The first one is called as spatial resolution. The second one is called as spectral resolution. The third one is called as radiometric resolution. And the fourth one and the last one is called as the temporal resolution. All the imageries, wherever the sensor is, but all the imageries having, it is must for the imageries to have these 4 components. And by using these components, we can only identify the quality of the imagery. So That is the basic of any of the remote sensing images, that resolution. If you know very good things about the resolution, you can do something better. Now, first one is called as the spatial resolution. Spatial resolution is what it is in a small is called as the instantaneous field of view. Yani, what it is basically the smallest possible feature detected on the ground by any of the sensor CCD array. Sensor is basically made for the CCDs and CCD arrays. So a CCD array covers a small area on the Earth's surface, and this area which is covered by the sensor is called as the spatial resolution. Sorry. So there are the two things which we will have to understand. One is called as the field of view. One is called as instantaneous field of view. When we talk about the field of view, it is basically the maximum coverage a satellite have or sensor have. It means spatial resolution actually defines the spatial coverage of a sensor. Again repeating, spatial resolution is basically define the spatial coverage of the sensor. Spatial resolution is what? Smallest possible feature detected on the ground by a CCD array, right? So whatever the pixel we do have, the smallest feature, smallest pixel we do have, that is basically the instantaneous field of view. And how many pixels at a time can be detected by a sensor, that defines basically the field of view. So at a single CCD array, when we do have a single CCD array, how many pixels are actually there in a line? This is basically the coverage, which is called as the instantaneous field of view, field of view. And under this field of view, we do have the instantaneous field of view. So how many pixel in length, width is basically covered, that defines the spatial coverage of the satellites. The smaller the pixel, better the resolution, the smaller the field of view. Bigger the pixel, coverage would be wide, information would be less. See. Can you see both these images? Am I audible?
Yes, sir.
Okay. So this is a 30-meter resolution, spatial resolution. And this is a 1-meter spatial resolution. So if you see that this is your field of view, you are covering a huge, large area. But at the same time, in a 1 meter, you are only covering to this much of area, which you are seeing here. So in this image, because it is a 1 meter resolution, we can see how many cars are being parked outside. But in this imagery, we do have the coverage, but the information is very less. See, this is, we do have the example is 80-meter resolution, 40-meter resolution, 20-meter resolution for the same area, 10-meter resolution, 5-meter up to 0.5 meters. So when we are taking maximum resolution, we are basically losing the field of view. So better the resolution, more the information, less the coverage. It is a thumb rule, because the CCD array has its own capability. So narrow the pixel, narrow the coverage. Wider the pixel, wider the coverage, but information would always be in a narrow. And what information is? This information, what we are talking about, is basically the visibility, right? Spatial resolution is concerned directly with the visibility by eyes only. We are not talking about other concern, because when we are seeing this area, definitely it will look very good because we are able to see the roads, houses, cars, everything. But that is basically for our eyes only. The information which is in the image, I don't know. But the information which can see our eyes is basically very good because I can see everything very clearly. This is one of the aspects of the remote sensing, that whatever we are seeing fine in the image by the eyes seems good. This is all about the spatial resolution. Now coming to the second aspect, which is called as the spectral resolution. Spectral terms itself indicating which is, we are talking about the spectrum. So the spectral resolution is basically what? Defining the ability of a sensor to define fine wavelength intervals. What fine wavelength intervals is? Try to understand by this. In the earlier time, we were using the black and white photography. In the black and white photography, we were having the mixture of blue, green, and red, which is falling under 0.4 to 0.7 micrometer. When the color image came, we are actually having the fractions. And what fraction is? It is defining a fine wavelength intervals. So fine wavelength intervals indicating is that we are giving the intervals. 0.4 to 0.5 is an interval, 0.5 to 0.6 is an interval, 0.6 and 0.7 is an interval. So spectral resolution is what? Defining the fine wavelength interval in the spectrum wherever it is being used. The finer the spectral resolution, the narrower the wavelength range. This range would be narrower for a particular channel, or I should say band. So earlier we were having everything in one band. Now we do have in multiple bands, but that multiple bands are basically falling under the visible portion of the electromagnetic spectrum. So blue, green, and red is basically can be seen because our eyes are actually sensitive for the visible portion of the electromagnetic spectrum. Now, that hyperspectral remote sensing is basically this only, where we do have the wavelength intervals more than what we are seeing in the multispectral remote sensing. In the multispectral remote sensing, we are seeing a range between 0.4 to 0.5. So in this region, 0.4 to 0.5 region, we are having only one band, 0.5 to 0.6. Maybe the range may change. The range means 0.5 to 2.58. That would be a range for our band. But that is basically defining the single band in the region itself. Now, when we are talking about the hyperspectral remote sensing, we are actually also fractioning these regions. It means 0.4 to 0.5, we do have the 10 bands. Under this region, we are having the 10 bands. Under this region too, we are having the 10 bands. Or there is one more aspect of this is called as the ultraspectral. When the ultraspectral we are talking about, this 10 band range would become 20, because currently we are having 10 nanometer difference. But when ultraspectral will come, or we do have the spectroradiometer, which can go up to a 1 nanometer difference only. So it means for 400 to 500, we are getting 100 channels. We can get 100 channels because we are fractioning these regions into 1 nanometer, 5 nanometer, 10 nanometer. That is basically our need. So on the basis of our need, we are fractioning the resolution, and that resolution is basically called as the spectral resolutions. So hyperspectral remote sensing is not talking about the visibility, means spatial resolution. No, we are not concerning with the spatial resolution, because spatial resolution gives only the visibility aspect. In terms of spectral resolution, it gives us the narrow contiguous bands. It is contiguous, there is no break in between. So that contiguous bands are basically used for the chemical composition identification of the object. When we do have, it is what? It is basically reflecting, and when it is reflecting, we are getting the reflection on the basis of the chemical composition. So whatever the aspect we do have in terms of hyperspectral, that is more concerned firstly with the spectral resolution. So hyperspectral is all about the spectral resolution rather than the spatial resolution first. Here we do have the visible, this image shows only 0.4 to 0.7 nanometer, but the hyperspectral range goes 0.4 to 2.5 micrometer. Now the third one is called as the radiometric resolution. That is also one of the special case when we are looking for the matters in terms of the reflection. This is what? It is a sensor's sensitivity to the magnitude of electromagnetic energy. It is basically the sensitivity of the sensor and the sensor ability to discriminate very slight differences in energy. Earlier we were talking about the slight differences in the spectral resolutions. Now we are talking about the slight differences in the energy in terms of the reflection, which is called as the radiometric. It is basically radiometry. The finer the radiometric resolution of a sensor, the more sensitive it is to detecting small differences in energy. Let me go to this. Try to see these two images. The left one you are seeing is a 2-bit image, and the right one is called as the 8-bit image, a 256 gray level. So it is 2-bit means 2 to the power 2, or 8-bit means 2 to the power 8. So radiometric resolution is basically talking about the bits and bytes information, and that bits and byte information is what in terms of the remote sensing is the gray levels. Gray levels means the slighter the difference. For instance, if you are seeing this area is actually this area which is seen either dark or light. But if you will see here, we do have the different ways of reflection, or the materials are different in this region, and this region. So better the radiometric resolution, better the reflection, and the slight reflection can also be seen. This is basically how we are actually covering to the bits and bytes, 2 to the power 2. So when we are coming to 2 to the power 2, 4, 8. So currently we do have 12 bits of images. The hyperspectral sensors are also having the 12 bits of resolutions. So why this resolution is important? Because when we are talking about the chemical composition in terms of the spectral resolution, at the same time, our eyes should be able to capture which area is having the difference in the energy. So by seeing this image, I can see that this area is having the different chemical composition as compared to this one. This area is different as compared to this one, and this area is again having a different chemical composition as compared to this one. This chemical composition, you should not confuse, means what? Since it is a small area, it will definitely will be having either the same soil cover or the same geology, but we do have something else. It may be possible that we do have the grassland here, a big grassland, and in this area we don't, and seems like a path. So we are not getting any grasslands here. So in this area, the grasses are actually, it may be in this area it is larger, it may be this area it is smaller. So this is what basically the mixing of the chemical composition due to the different object availability of that area. So apart from whatever the soil spectra or geological spectra we will get here, we will also be getting the spectra of the grass too. So what type of grass is, it may be possible we may quantify. So this is all about the spectral radiometric resolution. Now coming to the, this is a temporal resolution. The name itself indicating temporal, the times. So the temporal resolution is the revisit period and is the length of time for a satellite to complete one entire orbit cycle. It means when we are talking about the temporal resolution, in short, for instance, a satellite is seeing to my area today. After how many days, the same area with the same angle, the satellite would see my area. That is basically the temporal resolution. So temporal resolution means simply the same area covered by this satellite after how many days. So for instance, Landsat generally have 16 days, MODIS 1 day, Nexart needs 6 minutes, rain mode 10 minutes. Again, spatial resolution play a very important role in the case of temporal resolution. Why? Finer the spatial resolution, temporal resolution would be more. Broader the spatial resolution, temporal resolution would be less. For instance, MODIS. The MODIS resolution, spatial resolution is 1 kilometer. It means the pixel which is showing you the information about the object is having a ground length 1 kilometer by 1 kilometer in terms of length and width. So in 1 kilometer, it is not possible to see anything on the ground, but at the same time, it will giving you a revisit period of a day. It means tomorrow, whatever the area it is seeing today, tomorrow the sensor will come to the same place and will imaging the Earth's surface with the same angle too. So that is basically the idea behind this, is that if we are concerning with the spatial resolution, our temporal resolution would be defeating. If we are looking for the broader spatial resolution, our temporal resolution would be high. So that is basically the user dependent. Whatever the use of our satellite is, on that basis, these resolutions are basically defined. Now, this is what we were talking about, the difference between the multispectral and hyperspectral remote sensing. Multi means many bands. So which we are seeing are many bands. When we are seeing the spectral profile, we are seeing this gap. This gap is basically due to the gap in the escutcheon of the bands by the sensor itself. But in the case of hyperspectral remote sensing, we are not seeing any gap in between. And the same is being reflected in the spectral resolution. Now, I do have a question which is also having the answer in the same way, that why multispectral, why hyperspectral? In the case of multispectral, we are having these gaps because multispectral sensors does not acquire it continuously. So many regions of the spectrum is having the information of the object is actually missing. In these regions, we do have a lot of information about the object or material of the Earth's surface, but that is basically missing. At the same time, in the case of hyperspectral remote sensing, we do have a number of information which can gather by this. So by seeing this, we are actually getting the information in an uninterrupted manner, and this uninterruption with giving you the information about the chemical composition of the object. This is how we look in the case of panchromatic, in the case of multispectral, and in the case of hyperspectral. So we do have bands, but they have a broadband sensing. So these are the broadbands. In the short-wave infrared too, we do have the broadbands, but in the hyperspectral, we do have the contiguous bands. So this is the main difference we do have. The multispectral, which is called as the broadband remote sensing. Hyperspectral, it is called as contiguous band of the sensing. Now, this is how the difference you are seeing in the spectra of alunite mineral in the Landsat, in the MODIS, as well as in the lab. So what red ticks are basically the bands available for the sensing. These are the MODIS bands, but this is a contiguous spectral band. So if you will see, we do have the absorption feature here, we do have the absorption feature here, 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 and here, which is completely missing in the broadband sensing. So that broadband sensing is giving you a small indication about the alunite mineral, but in the case of hyperspectral, it is giving you a proper absorption features of the different mineral. These are some of the hyperspectral sensors which is available, but they all are airborne. The different organization we do have in the different countries, they are working with the hyperspectral remote sensing, but they all are now in the current stage is airborne. We do have some spaceborne, out of which only Hyperion and Hesperi, which is of Indian satellites, Hesperi, and the Hyperion is basically the NASA satellites, are available. But recently, the Prisma was also available for the hyperspectral community. Rest are basically being used for the military purposes, and they have their own missions. So earlier in 2005, we were having only 14, 15, up to 14, 15, we were having only one satellite, which was Hyperion, and which was launched actually in 2000. And it works up to 2010, though it was initially programmed for 2-3 years only, but it worked well with the 2012 up to 12. Prisma, we do have a very good satellite. Now it is freely available. Hesperi is also available with this, and we do have the outer space missions like Chandrayaan, Mars, Venus. So these instruments are also available. Hyperspectral instruments are also available for that mission too. So recently Chandrayaan, like M3 from the NASA in the previous Chandrayaan, was some of the missions which was actually with hyperspectral sensor. We are coming with the Hyperion. It is basically launched by the NASA under a new Millennium Program, and that is called as the NMP, in the November 2000. It was developed first to demonstrate the hyperspectral technologies in the space. Before that, we were not having any satellites. So that EO satellite was having 3 sensors. One is Ali, second is Hyperion, and third one is LISA. Ali was basically the broadband sensor, LISA was basically the spectral array imaging, and Hyperion is basically for the spectral analysis or spectroradiometer. Now coming to the resolutions or the informations which we have just talked. Spectral range, when we are talking, it is 0.4 to 2.5 micrometer. It means it is covering all visible, infrared, shortwave infrared regions. So when we are seeing in the panchromatic, we don't have any bands, but in the visible, near infrared and shortwave infrared regions, we do have 35, 35 and 172 bands. It means in the visible portion, 0.4 to 2.5, we do have the 35 bands. In the near infrared, we do have 35 bands. In the shortwave infrared, we do have 172 bands. So it is total as around 220 bands. In the thermal, we don't have any bands. The resolution in terms of spatial, it is 30 meter. And on that basis, this is called as IFOV, and FOV, which is called as the swath. It is called as only 7.5 kilometers. Temporal resolution is 220 days. So all the resolution you can see, radiometric is not available. It is basically 12-bit. So all the resolution information we are having under this slide. This is how the coverage, when we are talking about comparing with spot and Landsat, we do have a broad coverage in terms of the broadband. But in the case of Hyperion, we do have a full coverage without any flow, 0.4 to 2.5. Another mission we do have currently with the NASA and ISRO joint program, which is called as the AVRIS-NG. AVRIS-NG is basically the airborne sensors at the current stage, but this is basically in a pre-launch study case. We are expecting its launch somewhere in the next year, and this data would be free for all the science community because it's a joint program between NASA and ISRO. So if we understand the technical specification, the range is again 380 to 2500, which is basically the range. If we are talking about the spatial resolution, it goes up to 8 meters. And radiometric, it is basically 12 bits. And temporal, we don't have because currently we are using it in the airborne mode. So in the airborne mode, whenever we want, we can take, but that is basically dependent on the situations or the permissions of the airborne missions. So that is basically for the comparison. And one more thing which needs to be noticed here is that in the earlier mission, if you see, we were having the 220 bands, but now we are having the 425 bands. So 425 bands now we are getting with the AVRIS-NG because the spectral resolution is 5 nanometer. In the case of Hyperion, it was 10 nanometer, but in the case of AVRIS-NG, it is 5 nanometer. So with the 5 nanometer resolution, we are actually having the just double of bands, 220 to 425. This is how the hyperspectral data looks like when we are looking for the spectra of this place. We are getting the spectra of that area, and that spectra is basically the reflection of the chemical composition. Now, once we do have the data, the most important thing we do have is its processing. Hyperspectral data, due to its high spectral facility, it has a large volume too, because we are getting the multiple bands. So the same single data would be around 2 to 4 GB. So this 4 GB data need to be processed at a multiple levels for the information extraction. So this is a flow diagram which can actually give you an idea about how to process the hyperspectral imagery. This hyperspectral imagery requires a pre-processing. Pre-processing are basically the sets of some process which we tell you in the next few slides, but it is very essential steps. After the pre-processing is completed, we are going for the atmospheric correction. Then we are going for data dimensionality reduction, because so many bands are there and they all are redundant in nature. So we are reducing it. Then we are identifying the pure spectra from the images too. The pure spectra means we are basically looking for those pixels which is pure in nature. If it is there, then we expect the pure. If it is not there, we do expect some other minerals which is maximized towards purity. Then finally, we will be moving towards the classification. In the multispectral image classification, we generally, what we do, either we go for supervised classification or unsupervised classification. In the supervised, finally, we used to go for selecting some of the pixels of our study area, and we used to give it to the system to identify the same pixels to the entire image. At the same time, in the case of hyperspectral remote sensing, spectral or the pure spectra is basically the feed of the classification. So whatever the pixel we are providing to the classifier, it will classify accordingly. Now, these are the few steps of pre-processing of the hyperspectral data. The first one is called as the signal to noise ratio, SNR. SNR is one of the important factors when we are looking for the spectral classification. Better the SNR, better the results in terms of the reflection. Next is band selection. Band selection is what because this entire region is being scanned, some of the OH and HOH absorption regions actually falls under this. At 1.4, we do have OH absorption region, and at 1.9, we do have HOH absorption region. Apart from this, sometimes we do get the CCD array problems. So it is very essential to select only those channels which is containing the information. If the band is not containing any information, it needs to be removed before atmospheric correction. The third one is called as the bad pixel removal. Bad pixel is nothing but those pixels which is having the information, which does not have any information, or it may be dark because the reflectance, it may be in the form of a minus or negative values. So that bad pixels we have to understand, because if we do have the negative pixels with us, during the atmospheric correction, we will be having a problem. Then fourth one is called as VNIR and SWIR alignment. VNIR and SWIR alignment is basically the problem of Hyperion satellite, or the basic concept behind this is when we are imaging through hyperspectral remote sensing, it always contains two spectroradiometer. One is in the VNIR region, one is, and next is in the SWIR region. So the data which you are getting is basically the compilation of both the spectroradiometer. It means the data from the VNIR and data from the SWIR is combined together to give you a single data set. Madam, am I audible?
Yes, sir.
Okay. So the VNIR SWIR alignment, what it is basically, you have to understand when the data is being given to you, or the data of the both spectroradiometers are mixed together to create a one set, we have to understand its alignment too. If it is a problem in the alignment, we will be having a pixel shift. This pixel shift is basically due to the alignment issue. So in the Hyperion, we have experienced the VNIR SWIR alignment of a single pixel. So there is a shift of 30 meter in the VNIR SWIR region. The last one is called as the smiling. Smiling is nothing, just a sensor error, due to which the spectra actually looks like a smile. So that can be removed generally by the agencies who is providing the data. Since it is a sensor issue and we do require the sensor information for correcting this, so that sensor information can be provided by the agency who is looking for this type of work. So that a smiling correction is not basically our concern. Is a smiling correction is generally the agency's issues and they used to correct it. Now coming to the most important role of this hyperspectral data is the atmospheric corrections. What is that atmospheric correction is that we need to understand. The reflected solar radiation from the Earth's surface in its way before read by the satellite sensor has to transverse through the intermediate atmosphere, and hence the contains the information of both the Earth's surface as well as that of atmosphere. इसे इस तरीके से try to understand it in a way, when we do have a sensor in the space and we do have the rays of sun. So sun, at the same time, sun rays coming to the Earth's surface. So when it is coming from sun to Earth, it is actually going through the atmosphere. At the same time, when it is reflecting back from the target after reflection, it is again experiencing the atmosphere. So two times the rays is basically traveling through atmosphere before reaching to the sensors. That is basically good as well as bad. Why? Those who are looking for the atmospheric parameters or atmospheric understanding, this data is very good for them, because this, due to this transferring from sun to target and target to sensor, atmosphere, whatever the atmosphere was there, we can get the information about the atmosphere too. But at the same time, due to the atmosphere, the data get disturbed and it is actually sensed by the sensor, but the actuality of the data is basically removed. So to correct that, we need to go for the atmospheric correction. So whatever the hindrance is actually inherited by the data itself during these two ways movement, This is basically corrected by the atmospheric correction. The tool, which is called as fast line of sight atmospheric analysis of the spectral hypercubes, which is called as FLASH in short, is basically an atmospheric correction algorithm which is developed by the Air Force Research Laboratory Space Vehicles Directorate, America. So they have developed a model by which they are correcting the data. FLASH is basically the first principal atmospheric correction tool that corrects the wavelength in the visible through near infrared and short wave infrared region. It means, this is one of the important thing to know, is the data which is up to 3 micrometer can only be corrected by the normal code of the FLASH. So FLASH is basically meant for the correcting of the atmospheric correction between 0.4 to 3 micrometer. This is the window of the FLASH, which is containing the information about so many aspects of the atmosphere. What are the information? These all informations are required for correcting the atmospheric correction in the data itself. It means at the time of correction, what was the scene sensor location, sensor type, altitude, ground elevation, pixel size, flight data, flight time, atmospheric model, water retrieval, water absorption, so many features. So these features are basically need to be understood by us or by the ephemeris information available in the data itself. This ephemeris information is what? Ephemeris is basically a file which is given as a bundle with the data itself, and this ephemeris information gives you an idea about the sensor locations, angles, and everything. So that ephemeris informations are basically with the data itself, and this give you like zenith angle, azimuth angle, and sensor altitudes, whatever it is. Apart from this, we do require some pixel size and something, but the most important thing is basically the atmospheric model. On the basis of the area, wherever you have the data, we have to select the model, which is this window. This is basically the window. This window and this window is giving you an insight about the area you are concerning. So wherever you are in that area, you can go with this type of model. So in general, this FLASH algorithm has a model for all the areas we do have on the Earth surfaces. So we do have the information in terms of the atmospheric model, and that is basically clubbed with the ephemeris information of the data to correct the reflect data. Basically, when we are talking about the correcting the data, it means the data which we are receiving in the hyperspectral is basically the radiance, and after correction we are converting it into the reflectance data. Those who are not having much idea about the radiance and reflectance, the radiance data is basically what? Radiance data is containing the information about the reflectance from the target, as well as the atmospheric information, as well as the irradiance of the different target. So that information which is being sensed by the sensor in terms of the radiance is having the information about the atmosphere, about the irradiance of the other targets, as well as the reflectance of the targets. So what we need only the reflectance value of the target. So once we will go for atmospheric correction, we are converting the radiance image to reflectance image. So that input is basically the radiance image, and the output is basically the reflectance image. So that image is basically giving you the information of the reflectance value of the object only. But when being a atmospheric science person, we can use this radiance file to get the information of the multiple atmospheric parameters. So if we need to retrieve the multiple atmospheric parameters, the radiance files are having the information. This is how the spectra look like when we are taking the radiance and the reflectance. This is the radiance spectra we do have before the atmospheric correction. This is the reflectance spectra after the atmospheric corrections. In the corrections, if you will see, we are not seeing the data at two places. These places are basically 1.4 and 1.9 micrometer, or 1400 to 1800, sorry, 1400 and 1900 nanometers. So these two areas are basically the OH and HOH absorption regions. So we don't have any sensors which can capture the data in between. So whatever the data is being captured by the satellites, we cannot cover this area because the OH and HOH absorption regions does not reflect any kind of data in this regions. So we don't have basically the atmospheric windows in these regions. This only happens when we are correcting it atmospherically. If we are not correcting it atmospherically, we are getting something in this too. If you will see, the same reason is this one, 1.4 and 1.9, or 1400 and 1.9. The second is called as the data dimensionality reductions. Once we do have the atmospheric correction, we do have a huge number of bands, which is basically redundancy in nature. Means the data which is captured in the visible regions are having 10, 20, 30 bands, but they are redundant in nature. So we need to remove that. And how will I remove that? So we need an algorithm which is basically a dimensionality reductions. So like in the multispectral, we used to go for PCA. This is called as the advanced PCA, which is named as minimum noise fraction, the MNF. The MNF is basically used to determine inherent dimensionality of the image data and to segregate noise in the data and to reduce the computational requirement for the subsequent processing. It means this is in the case of multispectral, we do have the PCA. In the case of hyperspectral, we do have advanced PCA, which is called as the MNF. And this is used for segregating the noise or redundancy in the data and to get the maximum in terms of the data. The first transformation, it is basically a two-step process. In the first step, the transformation is basically based on the variance and covariance matrix. This noise covariance matrix decorrelates and rescales the noise in the scale. And this first step results in transform data in which the noise has a unit variance with no band-to-band correlation. It has a no correlation. So that is basically a statistical analysis based on the variance and covariance matrix. The second step is basically the standard principal component transformation. This is a PCA. Transforming the noise whitened data for the purpose of further spectral processing. The inherent dimensionality of data is determined by examination of the associated images. They are the two ways by which we can use. This is, you are seeing the results, eigenvalues and eigenvectors. So those who have a statistical analysis understanding, they can understand this. On the basis of eigen numbers, we can identify the bands which is containing the information, eigenvalues and eigenvectors. The rest is basically the redundant information. So either we can use eigenvalues and eigennumbers for identifying this, or we can use our visual examination with the images, because after some images we will be getting a very blur images. So this is basically the MNF, data dimensionality reduction. Now, once we do have the data in terms of the removing redundancy, it means we are having some good pure data. Pure data means we are talking about the non-redundant data. So the next step is to identify the purest pixel in the spectra of the redundant reduced data. This purest pixel is basically the same step we used to identify in the case of multispectral image classification, where the multispectral image classification, we need to find some pure pixels for classifying the data. The same situation is here also, because these are the pixels, that's true, but they are in the form of spectra. So we are actually identifying the pixels which is pure in nature, and the process is called as the pixel purity index. This is an algorithm which is run on the basis of some parameters, and we do identify the unique or pure pixels. How? The PPI is basically processing techniques designed to determine which pixels are the most spectrally unique or pure. Due to a large amount of data, PPI is usually performed on MNF data. It is a sequential process. First, we have done with the atmospheric corrections. Once we have done the atmospheric corrections, once we have done the atmospheric correction, we will be going for the next step, which is called as the PPI. So the PPI is only performed with the MNF data. So once we do have the MNF data, we will be going for the PPI on the MNF data only. The most spectrally pure pixels, just a minute. So the most spectrally pure pixels occur when there is a mixing of the end members. And how we are going to identify this? Let me show you. This is a n-dimensional visualizer. What we are doing? We do know the n-dimensional feature space analysis. When we are going for a feature space analysis in the multispectral, we do have the two bands feature space analysis. But here, in the hyperspectral, we do have n dimension. N dimension, that n is basically determined on the basis of the data given in the previous step, which is in the MNF. So that n is basically the MNF data which we have captured. The PPI is basically computing the continuous projecting n-dimensional scatter plots on a random vector. So this is basically keep on doing it. The only thing which we can understand is the spectrally pure spectra we are getting at the side here. If you will see that in this area, we are having red, green, and yellow and blue pixels. They are all mixtures. They are not spectrally pure pixels. Which one is extremely pure? Which we are getting in the extreme corners. So that corners is only identified when we are using it in a multi-dimension. Like in the current situation, we are using 3 bends at a time to see the entire pixel in the feature space. This is how the PPI graph look like. So this is the iteration, and that iteration is basically defined by the user itself. How many iterations do we require for the PPI? So this is a step where we are identifying the pure pixels, and that pure pixels, this is basically a pixel, right? But when we are converting this pixel into the image, it looks like this. So that pixel which you are seeing here is basically a spectral signature of that pixel. So we are getting the spectral pure pixel, but at the same time that pixel is having the value in terms of the spectral signature. The extreme pixels for each projection are recorded, and the total number of hits are stored into an image. These pixels are excellent candidates for selecting end members. That end members is basically the before classification steps or the purest pixels, which can be used in the subsequent processing. So the aim of this PPI exercise is to identify the pure spectral signatures, and that pure spectral signatures can only be identified by using the multi-dimensional feature space analysis. That multi-dimensional feature space analysis is only possible when we do have the system which actually supports this multi-dimensions. Now, once we do have the pixels with us in terms of the purity, for instance, these are the 4 or 5 pixels we have selected in terms of the pure pixels. Now, the next and the final steps comes when we are classifying the data. When we are classifying the data, we need an algorithm. And in the case of hyperspectral remote sensing, this algorithm is called as spectral angle mapper. The name itself indicating that mapper is basically based on the angle of the spectra. That's why it is called as spectral angle mapper. So mapping is based on the angle of the spectra. So how it is? We do have the material A spectra. That material spectra is our pure spectra. So we do have the pure spectra from the pixels in the image. When we classify that pixel, it will match the angle between the reference spectra and the image spectra. So that angle is basically the difference, or I should say the similarity index. Narrower the angle, better the quality. Wider the angle, less the match. So this is basically a physical based image classification which uses n-dimensional angles. That n-dimension is again the dimension. N-dimension means we are talking about the n of the MNF. How many bands we do have in MNF? We use the same in the PPI, and the same dimension we have used in the spectral angle map. So that n-dimensional angle to match image spectra with the reference spectra, and that reference spectra is basically our PPI spectra. SAM, or spectral angle mapper, calculates the angle between the spectra and treat them as vectors. Vector is what? Because of this angle situation, angle can only be determined when we do have the two different vectors in a space with the dimensionality equal to the number of bands. SAM is an automated method for comparing image spectra to individual spectra, or this is very important. SAM is basically a method of comparing image spectra to individual spectra or spectral library spectra. We do have these spectral libraries, and it is also possible that we can use the spectral library material spectra with the image itself. If you know what is in your image, you need not to take the pixel from the image itself. It is also possible that you can take the spectra from the just a minute. Sorry for the interruption. So we can have the spectral signatures comparison in terms of the individual spectra, which is collected from the image, or we can use our spectral libraries, which is developed by the different agencies, or it is also possible that we can use the field spectral signatures of the material itself. Whatever the material we have collected from the fields, we can get the spectra in the lab, and the same spectra can be used for the comparison of the SAM. So for the input of the SAM, we do have number one, the individual spectra taken from the image. The second one, we do have the libraries with us, the spectral libraries. So we can take the spectral libraries spectra, or the third one, we can go to the field and we can collect the spectra from the field itself, and the same spectra can be used for the classifying the image using spectral angle mapper. This is how we used to get the results of the SAM. SAM gives you results in two formats. One is in a single mineral image or material image, and second with a single image with all the materials. Am I audible to all? Am I audible?
Yes, sir.
Sorry, actually I'll have to confirm because sometimes connection get disconnected. So what we are getting, we can get the output in two aspects. The first one, if I need the material map of a particular kind of object, we can get the material too. The second one, if I need a map which is giving you an illustration of multiple material at a time, we can also get that. For instance, the map which is shown here is from different minerals. So they are all different. But at the same time, if you need a single map which is having this chloride, goethite, elite, and muscovite mineral, we can get the single map too. Now, why we are talking about this single and multiple maps? The reason behind this is, since it is giving you the composition of the material, and in a single pixel, we do expect the multiple compositions of the object. So when we are using only a single map for the different chemical composition, it may be possible that the one mineral may overlap to other. So if you will see, most of the time you are seeing that this from the very far it seems look like same, but when you are going it inside, see the muscovite minerals concentrate to this area. It is lesser than this. So it means there is a mineral which is actually the muscovite, but it is less than this one. But if they both are combined, only the elite, because of the maximum nature on the Earth's surface, it may disturb this area, and this will be superseded by the elite minerals. So we won't get a fraction in terms of the muscovite in that area until unless we don't have the single chemical composition map. Now coming to the hyperspectral remote sensing application, we do have the immense possibility in multiple fields in terms of the application. The first one is geology. So in the case of geology, different minerals, as I earlier told you, different altered, weathered, and clay minerals can directly be identified by using the hyperspectral technique. The next one is called as the soil. The soil type, we can understand the type of the soil as well as the quality. And the quality is basically based on the chemical composition. Then snow. So in the snow also, we can talk about the cover fractions, grain size analysis and everything. For forestry, forest type identification, we can talk about the forest type. It means an individual species can be identified in the forestry itself. Then ecology, so the chlorophyll, leaf water, cellulose, pigments, lignins, this all can be identified by using the reflectance spectroscopy. Then the coastal waters, in the coastal water regions, we can talk about the chlorophyll contents, phytoplankton, etc. In the agriculture, we can talk about the crop type identification, crop disease identification, etc. And in the case of urban, it is urban and material mapping. Apart from this, in the case of computer science, we can talk about the different classification algorithm which is available in this area for the spectral fractions. So unmixing spectral fractions, n-dimensional T visualizers, and MNF, particularly noise reductionists, are some of the areas which can be explored in this. I do have an example in terms of the study. This is basically related to the geology, but we are basically concerned with how the material, geological material in terms of the mineral are being identified in this area. So this, what you are seeing is basically a hyperspectral image. In the false color composite, you are seeing a false color composite of that image. And this area is Ascot, Pithoragarh. So it is basically Kumayu Himalayas and Nepal border. And in this area, at some place, we do have the underground mines of copper, lead, and zinc. But since it is Himalayas, so this is one of the prospecting zone for identification of the different type of minerals. So the first thing which we go for the geology, the same way we have fractioned the geology. If you will see the map, the same area is actually being fractioned on the basis of the geological aspect. So we can see the geological map of that area. Now we have divided this whole study into the 3 aspects, which is very important. Since in the Himalayas, field work is not very common. You cannot go to the field directly because this is not a motorable road. We do have so much of undulations and we don't get the road at every place. So in that area, it is not possible to go randomly anywhere. And for that, we have identified some places on the basis of pre-field analysis. So we have divided into 3 phases. One is the pre-field analysis, one is the field work, and another one is the post-field work analysis. In the field work, in the pre-field analysis, what we have done, we have classified the image for the regoliths. So if you will see, this is the image which we have classified on the basis of object-oriented classification. This object-oriented is basically the multispectral image classification or hyperspectral classification algorithm for the object-oriented. Why we have used the object-oriented? In general, we are basically having the geology. So geology or the zones which we are actually looking for seems like a small object. So we have identified this on the basis of the objects we do have in the field itself. So this way we have classified. Once we have classified, we have marked some of the areas which shows some promising results, out of which A site is basically the known site, which we know earlier that this is the place where we do expect the base metal mineralization, copper, lead, zinc mineralization. And the same signatures we are getting to the other sites too. Then the same process we have applied in the lab itself, out of which once we have identified the pure spectra up to here, we are getting these results for the all sites. So these are some of the few minerals spectra which we have taken from the hyperspectral imagery only. This is the results of the hyperspectral imagery, and the results shows that this areas, particularly A, B, C, D, whatever it is there, is actually giving us a prominent mineral in terms of the altered or weathered mineral. Then we have gone for the spectral angle mapper classification. That spectral angle mapper is basically again classifying the entire object into the different mineralogy. So now we do have a surety that a particular place is rich in multiple minerals. Now we, once after finishing this, we are basically need to go to the field to check our results, because being a geologist or being a remote sensing person, it is not possible to speak everything on the basis of the spectral signatures. We need to go to the field and we need to understand the aspects we are seeing in the image, in the classified image. So these are some of the indications we have identified at multiple sites. That sites are basically again ABCD. So this is what you are seeing is basically site A, and site A is giving us a very prominent signature for all minerals we are actually having. These are the results of site B, and in the site B we have identified some of the gaussianized outcrop as well as the metal signatures. Whatever the gray signatures we are seeing in this is basically the base metal signatures. These are the clay pockets we have identified. So this is the clay signatures we are having actually with this. So this is the second site where the weathering and alteration is prominent, and we were able to identify the sites in the field. Reaching to this place, we took around 1 day with the pedestrian movement. It was not a motorable road. So we reached there after a 1 day drive by all of us, our team. This is the third place where this black spot which you are seeing, or this you are seeing, is basically the magnetite mineral, iron bearing minerals. So these are the hydrothermal zones we have identified, and these are the magnetite mineral we were having in this area. The fourth site is basically, it's a talc mine. We were not aware about this mine earlier, but when we reached to the surface, then we identified that this is basically a mine. This is a mine where the talc is basically being mined. So all the four sites which we have identified using the object-oriented classification were again checked in the field itself, whether the classifying of an hyperspectral imagery with the object-oriented classification gives you a proper result. So same time we are having two classification. One is object-oriented, which is giving you an idea about the object or the places. At the same time, we do have the spectral angle mapper classification, which is also confirming the same at the site where we do have the objects in terms of the object-oriented classification. Now, this is all about my field work. Now, next step is basically the post-field analysis. Whatever we are seeing in the field, it is not possible. Being a geologist, we cannot directly comment which mineral it is. How will I identify? Some of the steps or some of the analysis need to be done in the lab itself. So we are coming back with the samples and we are analyzing it in terms of the multiple aspects. The first one is basically the spectroscopy. Now this is how the spectroscopy looks like for all our areas. We are getting the elite mineral at all places, and this is a lab-based spectral signature. So wherever the absorption features we are having here, at the same absorption features we have identified in the Hyperion image tool. This is a goethite minerals. So we are getting the goethite mineral signatures in multiple areas, all four areas. This is muscovite for all 4 areas. This is chloride for all areas. So how we are identifying? We are doing the same analysis in the lab before the field. We are doing the same analysis in the lab after the field with the spectroradiometer. So this is basically a correlation with the spectroradiometer in the lab and spectroradiometer in the space in terms of the hyperspectral sensor. So this is a correlation how the spectral signatures given by the hyperspectral sensor is actually confirming the presence of the mineral, and the same mineral is being confirmed with the spectroradiometer. This is how, apart from this calcite and dolomite, we have identified kaolinite and smectite mixtures and some other minerals which we have identified in the field itself. So this is how the classify says. This is a spectral angle mapper classification, and we do have the results in terms of the classification for chlorite, for goethite, for halite, and for muscovite. Now, once this is actually done, we are coming towards the geological aspect. See, spectroscopy is a very recent technology. So confirming anything by the spectroscopy sometimes give you a question that whether it is right or wrong. So we do have some traditional analysis in the all areas, in all fields. So like in geology, we used to go for petrographic analysis. So we have gone for the petrographic analysis like the quartz, chlorites for all sites, talc for all sites, muscovites for all sites, pyrite, margarite, epidote, hornblands, goethites, clays, dolomite, and for ore microscopy, for ore, basically we have identified the one base metal mineralization, which is containing the information of galena sphalerite. So both the things are also visible in the ore microscopy. So whatever you are seeing is basically the galena and sphalerite minerals, metallic minerals, which we have identified in the ore microscopy too. At the same time, we do have the X-ray diffraction technology. So that X-ray diffraction technology is also confirming the presence of the galena, sphaerocite, chalcocite, and magnetite minerals. They are all the metal mineralization. So this metal mineralization was also confirmed through the X-ray diffractions. After that, percentage was actually covered by the ICP-MS analysis too, inductive coupled plasma microanalysis. So that gives you an idea about the metal content you have. So this is gold, silver, iron, lead, zinc, arsenic, and antimatter. We do have the signatures for 3 sites we have identified, out of which one site is giving you the indication about the minerals, metallic minerals. So this site's giving you only the iron and lead and zinc, and this is only the iron, the magnetite, which we have. So this is basically a study which is giving a confirmation from the traditional aspect to the lab-based spectroscopy to the space-based spectroscopy. We are confirming the presence of the material, whatever we are found, by the different aspects, whether it is material, whether it is minerals, metallic, non-metallic, whatever it is. So we are actually confirming the presence of the spectroscopy by using the hyperspectral sensor, and this gives insight that this technology is actually helpful for understanding the studies of the material mapping of the subject or the object. So whenever we are talking about the material mapping, it is the hyperspectral remote sensing will definitely help you in this situation. These are some of the few publications we do have in the journals with the same work. So I thought I should give it to you. This is all about the signatures we have captured from the space to the lab to the spectroscope. This is basically some of the papers publication we do have with the Everest NG data. This one is all with the Hyperion data, and this one is all with the Everest NG data. So this is all from my side regarding the hyperspectral remote sensing and its application, particularly emphasis with the geology. If you have now the board is to you, the students or the faculties can ask their questions for this.
So here is a question, sir. Is there any model available to do this pre-processing steps in one shot?
Sorry, I'm not getting it properly.
Is there any model available to do this pre-processing steps in one shot?
In one shot, yes, it is available. It is available with the sensors like NV software is there, and in the NV we can do it, but there is a recommendation from my side, until unless you will not evaluate every step, you will not get the better results. See, every step, after every step, we have to evaluate the results, because the data you are getting is not a very good data. And the aspect means this is basically a personal aspect. You have some other desire, I do have some other desire. So we need to evaluate every step, and then we should move further. But for an emergency or for a quick results, we do have the modules in the NV software which can give you an idea about the full processing at a single go. Is it okay?
Sir, another question, sir.
Sorry?
Another question is this, sir. How do we get data about CO2 mixing ratio, aerosol height, etc.?
Where it is? What your question? How to get data about carbon dioxide mixing ratio, aerosol height ratio? That radiance data of hyperspectral is containing this information. The only thing is you will have to retrieve it through the radiance data. So we do have multiple modules by which you can retrieve this. Next question is there any freeware software to do processing of hyperspectral data? We do have this free GIS software which actually processes the data, but this entire atmospheric correction module and the data dimensionality reduction, we don't have the softwares, but we do have the codes. So if you have an idea about the programming language, we can use these codes for processing the data, because atmospheric correction itself is one of the typical tasks in the hyperspectral remote sensing. Is there any model available to do the pre-processing steps? Could be able to use this data to identify soil texture, structure, and chemical properties? Yes. Hyperspectral remote sensing actually enable us to understand the chemical properties of the soils. So once we do have the chemical properties of the soils, definitely we can talk about its chemical composition as its structure too. Since I haven't done anything for the soil, but for mineral, we have done it very good manner. So we can go ahead with this one. What is the importance of dip in the signature curve in the spectral data? Very good question. These are basically the absorption regions. See, what the remote sensing does is it, on the basis of chemical composition, it either it reflects, absorbs, or transforms. So that dip is basically indicates about the chemical composition. So whatever the mineral component we do have, we will get a dip in that area. So that dip is basically an indication of that type of chemical composition in the object itself. The rest is being reflected, which you are seeing. Any other questions? Am I audible?
If you have any queries still, please ask. Hey, participants, if you have any queries still, please ask. Thank you so much for this wonderful section, sir. Thank you once again, sir. In spite of your busy schedule, you accepted our request. Thank you, sir. Thank you all the participants. Third section will start at 2:30 p.m. today. Kindly make a note. Thank you all. Please join the section 5 minutes before start of the section.
Thank you so much, sir and madam, for inviting me for this lecture. I have seen so many questions from the audience, and it indicates that they have a very good understanding of the subject through the lectures or through their own experience, and they are talking it very consciously. Thank you very much for giving me the opportunity to distribute my knowledge to the participants. Thank you so much. Madam, can I exit now?
Yes, sir.
Thank you so much.
Thank you, sir.
Recording stopped.